crowded with many researchers focusing on that area. So we focused on the Weddell Sea, especially to predict the Weddell Sea ice, the extent of the Weddell Sea ice, and the interaction among ocean, ice, and the atmosphere, leading to kind of variabilities that propagate around the globe, especially influencing the climate over Southern Africa, which we have been working on recently. We found that by including sea ice thickness, we could improve the predictability, especially the predictability for December, January, February sea ice thickness compared to without having that. So that suggests the observation of sea ice thickness is very important for prediction of sea ice and also the influence of sea ice to understand and predict the influence of sea ice on global climate. We know that Syntax F is doing quite well, but also Syntax F has its fair share of failures. Especially, it doesn't do well for some of the termination of ENSO events, and also for predictions of higher latitude climate phenomena and mid-latitude climate phenomena. So we are trying to improve the model by incorporating better physics and also having higher resolutions. So we are now F2 stage, and we are now developing the F3. Also, we are including subsurface initializations now, and also increase the number of ensemble members from like 10 sub-members to hundreds of members now to test if by increasing ensemble size, we are able to predict better ENSO, IOD, and other mid-latitude climate phenomena. The F2 has sea ice, as I showed before, and also it has better resolution with better physics in the ocean model, at least. And it's doing well when we assimilate the subsurface data. We can see improvement compared to this. We see improvement in subtropical regions and high latitude regions. And that improvement also helps us to improve the predictions in the mid-latitude regions, both in Northern Hemisphere and Southern Hemisphere. We are also including whatever data available for us to assimilate. And one of the projects we did to include some of the data accumulated through biologging. In this case, the turtles, sea turtles are used to observe subsurface temperature in Arafura Sea here. And by including those information, we found the model does better by assimilating those information. And hopefully in future, we'll be able to use marine ecosystem for taking such kind of observations which can be included in the assimilation process in the climate models. We're also increasing the number of ensemble members, as I said before. The original aim was to see by increasing the number of ensemble members from tens of members to hundreds, can you improve the predictability? And we found that able to improve the ensemble predictions of some of the extreme events, like the 19 extreme phenomena, like 1988 and 89 La Nina, and 2006 positive IOD. However, the difference in the 10-member ensemble mean and 100-member ensemble mean is not that big. But if you take the probabilistic forecast, like try to see the 15% of the tails of those extreme La Nina and positive BMI, Indian Ocean Dipole, we see some improvements. We see some improvements in the predictability. And I hope we'll be able to use those informations in some of the applications where you can use probabilistic forecast. We are also trying to do the mean. Just simple arithmetic mean gives us some information, but we feel like we can select the best members from all those 100 ensemble members probably can improve the ensemble mean. And that's what we find here by just simply picking up the ensemble members which have been doing well in previous years, especially by categorizing them into different seasons or different months, and then picking up those members which are doing well in terms of their anomaly correlations and some other scores, skill scores. If we can pick up those good members, the ensemble mean will do far better than the ordinary mean we have been doing before. You can see that the blue and the correlation given in the blue fonts are far better than which are given in the orange, which is the previous way of doing ensemble mean by taking just simple arithmetic mean. And we hope we can improve this technique by including some kind of sophisticated statistical technique, including AI machine learnings. Talking about AI machine learning, I think in recent years, we have seen a lot of potential in predicting ENSO by using deep learning techniques, especially the convolutional neural network technique, CNN technique. The paper published in 2019 by Ham et al. In Nature showed that they could improve the ENSO predictions up to 2 years by using this kind of CNN deep learning technique by utilizing all the available predictions as simulated results from different models. The syntax-safe does well. The syntax-safe climate prediction model we are using at Jamstack, I showed you before, it does well to predict up to 15 to 18 months, but beyond 18 months, as you can see here, the skill score reduces. However, by utilizing CNN, we are able to do a better predictions for those longer lead time. Dr. Patil, who was from IIT Mumbai, now he's working as a young research fellow in my lab in Jamstack. He has been working on this to improve the Ham et al. Model by including more number of parameters and by improving the techniques the origin compared to the original one. For example, here he is using the sea surface temperature anomalies. In addition to that, he is taking the vertically averaged temperature anomalies, or you can say heat content for different layers. And he found some improvement in that. Especially, he found that if we take subsurface temperatures from different layers, he's still experimenting to optimize the code so that we can see which subsurface layer is most important in predicting.
Takes care of the time management.
And so we find that by optimizing and choosing certain subsurface layers, we are able to kind of improve the predictabilities, as you can see here.
Somebody should give a warning, you know,
compared to syntax. How much time I have now?
Okay. All right. Okay.
So, and also, one good thing about this CNN is that we can see the heat maps to see which areas are actually providing, which areas are actually important for those predictions and providing predictability scores to near 3 index predictions. This is the comparison among different models, the CNN with subsurface temperature, CNN with vertically averaged temperature anomalies, and the syntax safe. And we compare that with the original Ham et al. Predictions. And we see that our model is definitely doing far better compared to all those three. And we continue to improve that and optimize, also extend that to other basins like the Indian Ocean Dipole, the Atlantic Nino, and other areas. We are also using AI and machine learning for various other things like improving the initialization in our model and also improving the parameterization, especially cloud parameterizations. In addition to that, we're also using AI machine learning techniques for like some of the application studies. Here I'm showing you one example where we have applied the AI, the machine learning technique called the distributed large nonlinear model, DLNM, to predict malaria in South Africa. And the model has done quite well to predict malaria 1 to 3 seasons ahead, but not doing so well beyond that 1 month time scale. So we are improving at Jamstack, we are improving that model by including more kind of classifiers. You can see here we have several classifiers and optimizing them. And by doing that, we see that we can predict malaria at least 2 seasons ahead for December, January, February, which is the summer season for South Africa, and also March, April, May. And one of the important factors which is helping that machine learning technique is the Indian Ocean Dipole Index, especially the western pole of the Indian Ocean Dipole Index. As you can see here, it is helping the predictions up to 6 to 7 months ahead, and also for the not only for the December, January, February, but also March, April, May, kind of late malaria season in South Africa. And we hope we can improve that and extend to other regions by including not only the observation, also the syntax-safe climate prediction results. Okay, that brings me to discuss something about the climate informatics. So far, we understand the climate informatics, but without the computational systems, the climate informatics will not proceed as it has progressed so far. I don't know how many of you can recognize the card punching machine here. When I joined IITM, people used to use that, and they used to send all those cards to Mumbai for running their models. And then the next day, the person comes back and say, okay, you have a compiler error. You have to check and improve that. And it used to take months to code some of the models. And then we have rapid progresses. We have now many model codes available everywhere. And we are entering into a stage where the model codes will be coded by the computers, not by the human beings. And we are discussing now how to use climate models on quantum computers. And I don't know what is the future, whether human brains will be used or the computers will take over. As progress, we have various paradigms. Now, heading for Society 5. In the Society 5, it envisioned that data will play a role. Also, we'll have interactive bots, interactive activities, and many things will be automated. And in that way, I think we use many of the human errors, and also probably we can optimize climate information in automated by various IoT and various devices. I don't know what will happen next, but I think the Society 6 and 7 should address climate change. I hope we will not enter into water world, but in any case, we focus more on climate, the society next paradigms in our societies. So that brings to me the summary of my associated extreme events causing losses in many parts of the world and affecting the sustainability. For example, frequent IOD occurrences, the data changes in ENSO, the Antarctic Oscillation, the Arctic Oscillation, the SAM, and other climate phenomena, in addition to the global warming, are affecting human well-being. With the rapid increase of model simulated data, as well as observational data, we are heading towards a new era in the use of big data in climate science. This means we need to enhance our capacity in managing the climate big data. We hope the evolving climate informatics with the improvements in the observation and climate modeling will help us to manage extreme events in the near future, especially by utilizing AI, hopefully we can improve the predictions and also develop better societal applications for the societal well-being. I'll stop there. Thank you very much.
Okay, I think Dr. Behra has finished well in time, and there is time for questions. Any questions, please?
There is no open question in the box.
Geeta, you are not audible.
Yeah, in the chat box, it is not there. Anything?
No question.
Anybody can.
Sir, there are no questions.
So very nice overview of the data informatics in the climate prediction, and it was a very nice talk, and with a view to what the future can hold. So let us congratulate Dr. Behra and give him a big hand. Thank you.
Thank you, Dr.
Thank you very much.
Behra,
Thank you.
for very nice talk. And let us hope for the best, that we can have a better living conditions with all your studies and predictions, early warning, early detection, and societal applications of many advanced technologies and softwares like artificial intelligence and all. And it was very interesting to show from the card to that computer coding, because I remember in '85 when I joined, I have seen these cards.
We had a great IBM 312, I guess, at that time, Geeta.
Yes, yes.
IBM 16 it was, yes. Very old computer in BSSC.
Thank you, Dr. Behra.
Thank you very much. It was a pleasure to talk to you. Thank you.
I'll invite the next speaker, please.
Dr. Tamban Melut.
Okay, so shall I start now?
Yeah, I guess so.
Yeah, good morning to all. First of all, thank you so much for inviting me to this very interesting as well as very invigorating conference which is going on. And especially because this is essentially a tropical meteorology related program. So I don't belong to that. I am essentially working on Antarctic cryosphere. That too, not basically a meteorologist or atmospheric scientist, more of a person who works on cryosphere as well as the climate of the past. However, there are possibilities of interesting aspects that could be connected to the tropical system. So I think that's where I stand here, and I like to share the
You see one share screen. Yeah, correct.
Yeah. Right. So thank you so much. Yeah, that's what I would be talking today on Antarctic cryosphere in a changing world. I belong to this National Center for Polar and Ocean Research under the Ministry of Earth Sciences, where we work mostly on polar sciences and some of the ocean surrounding the polar regions. So if you look at when you talk about cryosphere is that part of the Earth's surface where water is essentially in frozen form. This could be sea ice, it could be land ice, it could be ice sheets, it could be permanently frozen land. It's called permafrost. It could be just lake ice and so on. So if you look at the cryospheric regions, Antarctica is the largest among them, which is a huge continent of size of nearly more than 4 to 4.5 times of Indian subcontinent, which is almost 99% covered by ice. And then you have this in the northern hemisphere, you have Arctic. Essentially is an ocean surrounded by the land. Oceans, a large part of the ocean is frozen as sea ice. And then there are some islands like Greenland and Svalbard and Iceland and so on, essentially because forming the Arctic region and the northern parts of this Canada, US and the Siberia and the Scandinavian countries and so on. And then there is another part of this, the polar regions, what we call these days as third pole, which is essentially the Hindu Kush, Himalaya and Tibetan region joined together, which contains the largest reserve of the ice or the cryosphere other than these two poles. And more importantly, they have the largest reserve of the fresh water outside the polar regions, and which contains also the highest nearly 12 to 14 peaks above 8,000 meters, and also contribute to major source of large rivers of nearly 10 of them. So if you look at the impact and importance of cryosphere to the world, they are quite large and many ways it can be seen. It can be talked about globally, regionally, as well as locally. Globally, if you talk about, especially, of course, the cryosphere is one area that is really contributing to the large amount of changes in the sea level, other than the thermal expansion of the ocean, which is already ongoing. In future, as it is getting more and more warmer and actually have more contribution coming from the cryosphere, that's going to be the one most major culprit in the future changes in sea level. And if you look at the Earth's energy balance, of course, the polar regions are one of the major reason why we have this, how its thermal balance is, managed, because of this extremely what you call white body, which is sitting over there in the southern hemisphere as well as in the north, which essentially makes it actually a global thermostat, controlling the whole energy balance of the globe. And also, many of you are aware, actually, the largest or the major ocean circulations, like this overturning circulations from Atlantic as well as actually which goes into the rest of the oceans, are essentially initiated at two polar regions, one in the Arctic as well as the other one in the Antarctica. If you look regionally, the cryospheres are extremely important for the water availability. For example, if you look at the Himalayan region, especially the Asian regions, for example, most of the major rivers do get the water, especially during the lean periods, like in summer periods. Essentially, the water is contributed by either the snowfall or the glaciers melting. Also, the energy security of most of these countries are depending on the cryosphere, because that's where actually the hydroelectricity generation from these rivers are dependent hugely.
You have muted your mic, Dr. Tamban.
Where is the problem with the speaker or?
Dr. Tamban, are you there?
Tamban, your mic is muted. Dr. Tamban. Professor Mohan Kumar. Problem with the speaker's side or?
I don't know. I'm not able to.
It should be some problem with the internal connectivity there.
Yes.
Can you hear me now?
Yeah. No, you are fine.
I'm sorry. I think there was an internet disconnectivity. I'm again sharing the screen.
Okay.
You will find that share screen button. You can click on that.
Yeah, but the problem is actually it's not getting visible for me. That's my problem. Yeah. Okay, it's coming on. Yeah.
Yeah.
Yeah. There are some serious internet problem here, so I'm sorry about it.
It's okay.
Yeah. So if you look at the the impact of the ongoing global warming on the polar regions, if you look at from the all the way from the southern hemisphere, the 90 degrees south to 90 degrees north, you find there is a unusually large increase in the zonal mean of this temperature that normally happen in the Arctic region. Then there is a small increase in the Antarctic regions. This is what we call actually as the polar amplification, wherein the impact or the response of the globe towards the warming is unequal or is quite heterogeneous. There are many reasons to it, and one of the major reasons actually what they talk is about is the feedback mechanisms of due to the slowly disappearing the sea ice, and then also this thermal gradient between the polar and equator regions and so on. I'm not going to get into that aspect of it. So if you look at the Antarctica, is actually a large continent of the extremes, wherein you also find that it's also the largest desert of the world, with an area nearly that of 2 times of Saharan desert, wherein even the precipitation is extremely lower than actually even the Sahara. For example, Sahara got an average precipitation of about nearly 100 centimeter per year, whereas in many parts of the Antarctica, you will find the precipitation is as low as less than 15 centimeter per year. And except very few places like Antarctic Peninsula or even some of the coastal areas of Antarctica, the precipitation is almost nil in the interior of Antarctica. If you look at the temperature actually of the Antarctica, especially if you look at the East Antarctica, there's a large areas of the high plateaus in the polar plateaus in Antarctica, wherein actually the temperature can be as low as less than minus 50 degrees and so on. And there, of course, there are also places like the warmer part of Antarctica where the temperature can reach as high as minus 5 degrees to even 0 degree in many parts. So if you look at this large heterogeneous nature of Antarctica, but however, as long as when you keep just looking from the space, it just looks like a large piece of marble, all white surface with some specks here and there. But this is actually not exactly how it looked like if you keep looking through using satellite methods for a long period. When you keep looking for a long term, keep monitoring them for a long period, what you realize actually, this Antarctica, which you thought is a very static piece of white ice, is highly dynamic in nature with the large flows of its own. The flows are, of course, mostly from the high elevation to lower elevation. So finally, they get to reach the ocean. And then there are these areas of what we call actually the ice shelves, where there is a large floating body of this ice when as it meets to the ocean, like Ross ice shelf and Ronny ice shelf, and there are many more small ice shelves here, which actually contribute to a large the loss of ice to the the surrounding oceans, especially the Southern Ocean. If you look at the ice sheet elevation and bed topography of Antarctica, you go from all the way from west to east. What you also find actually that West Antarctica is, of course, the lower elevation, as well as there is a large areas of these floating bodies of ice, what we call actually as ice shelves. Then you have this East Antarctica, where you have this ice as thick as sometimes 4 kilometers in many places. And if you look at the bed topography is as undulated as anywhere else in the world. So as a result, Antarctica, the average elevation of Antarctica is much higher compared to any other continent, because you have a land on top of which this large pile of ice is sitting. This large pile of ice is one reason actually. It's also there is a large what you call the controlling the atmospheric as well as the whole oceanic process surrounding the Antarctica. So if you look at the role of Antarctica in global climate, there are multiple reasons. First and foremost, I said actually that ice covers almost entire Antarctic surface, which is of course highly reflecting, therefore cooling the atmosphere through its ice albedo effect. And if you look at the Antarctica, as I said, Antarctica being nearly 4 to 4.5 times of Indian subcontinent, it's a giant mirror sitting there over the south, reflecting most of the the radiation which is coming from the sun, whereas the surrounding ocean actually absorbs almost 100% of it. As a result of this imbalance, and top of which, the sea ice surrounding Antarctica expands nearly double during the winter period. So this mirror almost doubles during the winter period. So such a huge difference in actually the energy balance of this region essentially makes the Antarctica a very peculiar place compared to rest of the world. And if you look at the as I said, actually during winter there is a large amount of sea ice forms. They are basically seasonally varying sea ice. Unlike the Arctic, where there could be multi-year sea ice could be there. So as the sea ice is formed, due to brine ejection, the salt is always get ejected, and the salt get ejected, and that makes the water below highly dense. Such high dense water starts sinking to the bottom, creating what we call actually one of the largest oceanic circulation, what we call as a thermohaline circulation, which essentially distribute the heat and energy across the the globe. And Antarctica is one of the key sites, other than, in fact, the largest site would be, of course, in the Arctic region. Antarctica is one of the very important place where this deep water formation is made. And if you look at the ocean surrounding Antarctica, what we call a Southern Ocean, which is actually essentially a circumpolar ocean compared to, which is part of all these Indian, Atlantic, and Pacific oceans, which has its own properties and its own impact on the globe. And it essentially isolates the Antarctica from the warm tropical oceans. And many of you would be knowing, of course, in a changing, the globe conditions where the continuous impact of CO2 is increasing year after year, ocean is one of the largest sink for the global CO2, of which Southern Ocean takes up nearly 40% of that CO2, thus playing a vital role in the global carbon cycle as well as the climate. Unfortunately, this Southern Ocean's ability to absorb this CO2 can change as a result of warming, because warm water, of course, takes up less of CO2. So, which means actually that in the future, this sink, what we see around in the Southern Ocean, could be reduced, and its impact could be reduced or effect could be reduced. And of course, many of the oceanographers do know that actually Southern Ocean is home to the largest or the strongest ocean current in the world, what we call as Antarctic circumpolar current, and it's also where we have one of the major deep water ocean forms. If you look at the impact of the global warming on Antarctica, especially if you look at the Antarctica in a very regional wise, there is a regional variability, especially highly heterogeneous nature of variability you find. The West Antarctica and the Antarctic Peninsula are the most impacted compared to the East Antarctica, mainly because East Antarctica has a larger thick ice and which is sitting over the land. East Antarctica has many glaciers which are debouching to the ocean, and there are these ice shelves which are actually essentially have an impact not only just from the top but also from the bottom. As a result, if you look at West Antarctica is losing ice faster compared to the East Antarctica. And it's essentially, as I said, actually due to multiple reasons. One, of course, you have this increased solar radiation as well as warming, actually, and also there is warm marine intrusions takes place from the coast to inland regions. And there's also tropical Pacific influences happening quite strongly and leading to a large amount of melting on the surface. But however, there's also this warm current is coming to the Antarctic ice shelves, melting from below the shelf regions, makes the West Antarctica is much more vulnerable in a warming world compared to that of the East Antarctica. And many of the stability of these ice shelves of this West Antarctica are actually in a situation where it could be, once it's initiated, the real movement starts, it will not be able to go back. So that's something which you have to keep in mind. I would also like to just mention here actually the Indian scientific expedition to Antarctica we started as early as nearly more than 40 years back. It's quite a complicated and logistically as well as scientifically, because we operate everything from Goa, but we run two stations in Antarctica, which is separated nearly about 2,000 kilometers by air, as well as 3,000 kilometers by ship route. And this is, in the past, we used to always go by vessel, which takes nearly about 1 month period to reach to Antarctica. And currently, we also have this possibility of flying to Cape Town, that is South Africa, and then to fly to Antarctica, or use a vessel to go to Antarctica. In any case, what I call the Antarctic ships are still required because to transport logistic material, fuel, and everything. So typically, Antarctic expeditions actually can last for about several months. For those people do only for a summer period to carry out research. But however, for those who are wintering over there, it is almost more than 13 to 14 months period. In the past, it used to be about 15 months. Now it's reduced to 12 to 13 months. So I would also like to just touch upon the kind of the major research which we carry out at NCPR and this particular aspects actually. So because that's I think what I just want to highlight here. Of course, the Indian scientific research in Antarctica has all its components, like from atmospheric science to biological science, cryospheric science, earth science, and environment science. What I would be just trying to focus on the research which my team is carrying out. So essentially, we have this project under the Ministry of Earth Sciences funded actually long-term, continuing project, what we call actually, on which first major 3 objectives are belong to Antarctica. One, we want to study the long-term Antarctic climate variability and its global linkages using Antarctic ice cores. I will tell a little more on this particular aspect in coming slides. The second one is we want to understand the dynamics and evolution of these Antarctic ice shelves, which I was telling you that they are becoming more vulnerable in a warming world. So we want to know how really what is their status and what are the potential factors that could be influence their stability and how they could be contributing to changing future sea level changes. Third one is we want to understand the carbon cycling within Antarctic ice, because most of the people in the past used to believe Antarctic ice, being one of the most pristine in nature, is also actually but the least cycling of carbon takes place and least important for as far as the carbon cycle is concerned. But if you look at the last 5 years of research, which is coming from various institutions as well as including our own research, very specifically clearly tells actually that it is not so. So this is something area which I would be again touching upon. So first, I would be talking about what we do with the climate reconstruction using ice cores. The simple and foremost importance why should we work on Antarctica is that we don't have long-term instrumental records. The instrument records in Antarctica is so short, and it could be longest available records are since the International Geophysical Year, which is about 60 years before. And however, for most of the other station records are only about several decades. And more importantly, these records are available only along the coastal Antarctica, where there are few stations are there. There's only about 40 stations in Antarctica, so only that much records are available. As I told in the very beginning, Antarctica is such a large continent with a large heterogeneity. Getting only instrument records, you will never be able to make a really sense of what is going on there, and you'll never be able to make a sense of what would be happening to it. So ice provides one of the most direct possible measurements of climate changes. So in fact, ice core records have changed the way the world looks at how the global change, become one of the most important cornerstones for the global climate research. And because they provide the quantitative records of temperature, precipitation, this is in fact the only way to understand the greenhouse gases in the past, and so on. And they also have the possibility of giving one of the most highly resolved climate records, which can be very well dated compared to the rest of the paleoclimatic records. One of the biggest problems with a lot of paleoclimatic the past climate records, natural archives are there actually. The dating or the chronology of these records are within plus minus several hundreds of years. Whereas for most of the climate change research, we require a much better what I call accuracy. So ice core provides a plus minus few years of accuracy to as far as the dating is concerned. So therefore, India also has started this particular research wherein we use multiple parameters. Essentially, we use various proxy records. When we say proxy records, essentially the variability of these proxies would tell actually can be quantified back to what exactly the actual climate is actually. There are different proxies, which are qualitative proxies as well as quantitative proxies. As far as I-score is concerned, they are much more quantitative in nature because the variations in the isotopes of various elements, like especially like, for example, if you talk about ice is nothing but water molecules. You have hydrogen and oxygen, in that actually. And if you can carefully study the isotopic variability, because it's fractionation of during the formation of this snow is essentially decided by the temperature at that time. So therefore, we are able to make essentially reconstruct temperature using this kind of proxy records. We can also reconstruct various atmospheric turbidity using dust content in the ice. Antarctic ice looks very clean, but there could be very minute amount of dust. So the challenge is to measure highly accurate measurements, which are about less than 300 ppb or so, the dust material. So which is extremely low compared to where you can your ambient conditions. So that means for any of these measurements, you also require a specialized laboratory, specialized facilities with a very highly clean conditions to ensure that the measurements you make are actually the real one, which is found in the Antarctic ice, and you are not contaminating any of that. So the ongoing global warming, what we understand from I-score studies is actually very unprecedented. And that's because we clearly know the longest available I-score record, which is about 800,000 years, less than about 1 million years record. We always had in the past this variability, natural variability of changing carbon dioxide as well as in tandem with the temperature changes. We always had what we call actually interglaciation or glaciation. And there will be a sharp increase of temperature as well as increase due to the increase in CO2 during at the end of a glacial period. And at like currently we are at the an interglacial period where we have a very high CO2 as well as increased warmth. But what is the difference you find since the last few decades, especially since the 1970s and 80s, there is a dramatic increase in CO2 happening. Typically, the CO2 used to be about 300 ppmv or less than that in the past. What we see, suddenly there is a spurt in that value which reached 420 ppmv now. So this dramatic change, which happens only in few decades, it used to take minimum 5,000 years in the past. So the magnitude and the scale is quite different than what we used to see in the geological past. So therefore, the response of the globe also could be highly, different than what we've seen in the past, which means that we will never be able to use specifically this as an analog, but what we will also be able to see that how the world or the Earth is able to adapt those change, this sudden increase in changes. So we, as I said, actually, Antarctica, NCPR does have initiated an I-score research way back in more than 15 years now. So we focus essentially on shallow to medium depth I-scores, especially the coastal Antarctica, to reconstruct a very high resolution climate records, which is equivalent to that to something like of instrumental records. So we are essentially trying to extend the instrumental records by calibrating along with the instrumental records. And the essential aim is to examine the linkages between the polar regions and how extratropical as well as the tropical regions. So if you look at Antarctica climate, actually, there are various factors influencing Antarctic climate. In fact, as we all know, the global nature of the ENSO, El Nino Southern Oscillation, it's almost it's a very large scale phenomena now impacting almost entire globe. So is even Antarctica. Then there is another specific feature to Antarctica, which what we call as southern annular mode, which essentially is actually the pressure difference between the Antarctic coast and about mid latitudes, which essentially controls the westerly wind system as well as many other things, sea ice changes around surrounding Antarctica. So there are these positive and negative modes. Currently, we are on a positive mode of SAM, and actually that's also one reason why we have an increased westerly wind system happening around Antarctica. Then you have this El Niño Southern Oscillation impacting in the form of actually what they call actually the Pacific South American pattern. So which essentially have a, as you will see, I'll show our own ice core record. So, essentially we'll see actually that as the, ENSO is impacting rest of the world, they also have a significant differences making in the, especially sea ice surrounding, Antarctic coast. Then you have this, what we call as the Pacific Decadal Oscillation, or, which is some kind of a long-lived El Niño Southern Oscillation, which is also quite commonly found in a multi-decadal scale. So in the coming few slides, I just want to concentrate on the kind of the research which we carry out using these ice cores, and then how what are the interesting research which we find in that. This one of that's the paper actually wherein we found that the changes, like if you look at this, especially the El Niño Southern Oscillation impact, what you see when it is strong positive, we also find a strong positive mode in the, especially in the Tronic model region where we currently concentrate actually. So this is, if this is the present condition, this in fact actually the record based on 1958 to 2001. So we know that actually currently there is a strong influence whenever there is an ENSO positive happening in the Pacific. We also have signals coming to the coastal Antarctica. So if you look at in the past, therefore we will be able to reconstruct how did this vary in the past. So using ice cores, what we did, we tried to reconstruct this variability in El Niño Southern Oscillation impact on this ice core, things like temperature and other changes. And what we find, since the industrial era, there is a significant increase of ENSO happening, whereas the longer band, this Pacific Decadal Oscillation has been at the same time has been decreasing its impact. It's a very interesting finding, because actually as in a warming world, it is considered to be that actually ENSO impact would be much higher, or the ENSO kind of the situation could be, kind of situation could be much higher. So that means that could be, there are more and more high frequency fluctuations happening in Antarctic climate in the coming years, the coming decades rather. Second one, actually, as as many of you would be knowing, as I said, actually that the westerly wind system is the one which controls the all thing happens around Antarctica. And in fact, Antarctica does not have any dust source. It's completely covered by ice. So any dust coming to Antarctica essentially comes from the continents surrounding Antarctica. In this case, actually, it could be the South America, Africa, and Australia. Because it's a westerly wind system is controlling, so the area which we work, we typically find it is controlled from the South American system. This is basically back trajectories as well as the forward modeling tells us that. So what we find that when you say the seasonally, we try to use an ice core to seasonally resolve this ice core and then try to reconstruct for the last 100 years. What we find there is a dramatic increase in dust coming to Antarctica, which is actually more than in a stepwise format, especially since the 1980s. There is a very significant increase in dust coming to Antarctica, and this increase we find is basically essentially can be attributed to the increased aridity over the southern South America, as well as favorable wind conditions. As the wind is essentially has been increasing since the SAM is gone into a positive mode in the southern hemisphere. And we also not only that we identified these changes and find mechanism to that change, we also tried to estimate the radiative forcing, what this dust could be having an impact on in Antarctic climate. So what we find that actually there is a corresponding increase in dust flux, which is leading to nearly about 30% increase in the aerosol forcing in this area since the late 20th century. This is a very interesting finding, because actually as we again getting more warmer, or maybe we are still in a positive SAM, there could be increased desertification happening in the places like Patagonian desert over here. There will be increased dust coming to Antarctica. So this will have a significant impact on its climate too, because of it influences radiative force. One of the very latest publication which just came last week, we tried to using the proxies, very what you call specialized techniques, using actually principal component analysis of the proxy, and then try to reconstruct, differentiate the temperature and sea ice variability on the ice core, in the isotope records, using which actually we could differentiate the sea ice component from the temperature component. Then we try to reconstruct the sea ice for the long period of nearly 200 years, combine them along with the latest satellite available records by ensuring that actually you have a proper calibration to the proxy to the actual data. So what we find, there has been if you look at the past records, nearly 200 years, there have been certainly a lot of variations, and since 1920s or 30s, there have been a increase in the sea ice happening around Antarctica, but that increase has dramatically increased since the last few decades. And this increase, like in this case, actually, what we try to do using our ice core, because actually the spatial variability clearly tells it is the sea ice conditions in Indian Ocean sector of the Southern Ocean is directly impacting this area. What we find that this we try to then thereafter correlate this sea ice changes in the Indian sector of Southern Ocean to the changes in Southern Angular Mode. We find there is a very high positive correlation between SAM and sea ice variability. And using this, actually, that this is for the long period I've talked about. Then using that, we further also looked at actually whether it's only SAM is influencing, how is the Pacific oscillations impacting it. We find that both SAM as well as ENSO has a significant influence on the sea ice variability along this part of Antarctica, which is essentially Western Indian Ocean sector. So this is a very, this in fact is the first available long-term sea ice record for the entire Antarctica itself. So the second aspect, which actually I hope you have a little more time. So I just want to, basically we are looking at the study, understand the ice shelf changes and how do the ice shelves are impacted in a changing world. We want to test a hypothesis, is this Antarctic ice sheet are impacted by the changes in ice shelves? Something like, are they forming like a bottle cork of this Antarctic ice sheets? What we find, this is, if you Antarctic ice sheet, I said actually a huge thick of ice, which is about nearly 2 to 4 kilometers thick. And these ice shelves are simple floating bodies of a few 100 meters thick. And there are sometimes locally, the topographical features like ice rises, which actually controls like a cork of a bottle, because that actually as long as the cork is tight, everything remains intact. But the moment the cork opens, the entire ice can start flowing to the ocean. This is something which we wanted to study, and that which we have been carrying out a lot of studies in some of the ice shelves in Antarctica. Along with the Norwegians, actually, we had a collaborative project for it. Essentially, in this particular work, actually, we tried to study the basal melt. Basal melt is a melt below the ice shelf using a specialized radar technique called actually autonomous phase sensitive radar, which is measured for several years, in one particular point. That provides you how much actual basal melt happens along with the surface melt. That tells actually us that we find that at the calving point, or where the ice is coming to the ocean, contact with the ocean, this is much higher, because as the sea ice is increased, loss of sea ice surrounding this area, there's an increased impact of this warm water to these ice shelves. And we also find that there is a strong, large amount of spatial variability across this, the ice shelves, because there is a complex interactions between topography, snowfall, wind. So it's not all as simple as you think. When you get into coastal Antarctica, the situations are completely different than the rest of the Antarctica itself. So there is a final component which I wanted to talk about, actually, the cycling of biogeochemical cycling within the glacial ecosystems, where we normally used to believe cryosphere, or especially this ice, actually has a simple, very barren land. But what we realize actually it's a frozen rainforest for life. There are over 1 million, billion, trillion microorganisms living on this, and which undergoes multiple stresses. Right, I'm completing it now. Right. So which they have a strong key roles in the ice melting and CO2 concentrations and so on. So essentially what we find that actually that the dissolved organic carbon in Antarctic ice surface can be a significant impact on the in future as the warming world, wherein actually larger amount of ice is being lost from Antarctica to the ocean. Therefore, it could impact the carbon cycling of the surrounding oceans. That's what we want to say here. So that's all I just wanted to say here. I just would like to skip a couple of slides here. So wherein I just want to say that Antarctic cryosphere is very critically important for understanding the global climate and sea level changes. Wherein there are large differences across Antarctica, and the current changes in West Antarctica ice mass loss is much faster than in fact even envisaged in the past, and is currently driven by loss and instability of ice shelves. So the addressing future changes would require quantitative understanding of the recent changes as well as thresholds and tipping points in the past. So there's also want to say that Antarctic climate variability is closely linked to the tropical and extratropical climate modes. So therefore it opens up a lot of interesting studies comparing with what happens to the tropics to the extratropics and the polar regions. Thank you so much for this opportunity. Thanks a lot.
I would invite some questions on the presentation. It's a very interesting presentation on the Antarctic ice shelves and their role in the climate. Any questions, please?
Yes, sure, sir. I want to ask one question, just a short question. Because the Antarctic region, we have got the circulation changes during its winter, whether it affects the monsoon here. Monsoon circulation will affect the monsoon.
No, but there are studies actually on the not the circulation. Actually, there are about the large scale changes. You're talking about a small scale circulation. There are large scale changes of which is brought by this sea ice changes, and all. There are studies which impacts the monsoon, but not exactly the Antarctica. But in that case, actually, it's basically in the Southern Ocean, like the Mascarenes High, where the Mascarenes High is sitting there. That actually has an impact. Actually, there are recent studies have been showing it, but not the Antarctic circulation itself. In fact, both Antarctica actually as well as monsoons are impacted by mainly by rather ENSO. ENSO has a strong impact on Antarctic climate variability as well as on monsoon variability.
There are two questions from Umesh Prasad. Question: can we have paleogeol trace into the core of ice sheet there? How much and which way things are monitored and calibrated? Tools and technique implied direct or indirect measurement depends on post-drilling deposits and geometallurgy.
I have absolutely no idea what exactly you wanted to ask the questions, but what we also, of course, how much and what way things are monitored and calibrated. Of course, I have not got into any of these details here, essentially because actually this particular talk cannot be of that level. What exactly, how we carry out these measurements, how do we do dating actually, how do we try to make indirect measurements and so on. So all those details I have not said here because that requires a complete another lecture. In fact, actually that may be another time I could be able to explain that. There's also one more question. I said that to monitor concentration of sea ice contents of 1800 to 2020, which important tools and techniques. Essentially, you use proxies. We have ice cores sitting there. We need a lot of measurements of isotopes and trace metals and chemistry. Thereafter, you need a clever analysis, statistical analysis to ensure that actually you are able to extract what I call sea ice signal from rest of the climate parameters like temperature and precipitation and so on. So it is a very large kind of studies which essentially help us to identify this variability.
Thank you, Dr. Tamban. If time permits, I have a question.
Yes, ma'am.
What is the periodicity, variation in the periodicity, Pacific decadal oscillation? Decadal means how much it varies? Yeah,
that is the thing. It varies between 16 years to 36 years. In fact, there are different formats of it actually. So what they call actually is sort of a long-lived ENSO. It's exactly like an ENSO, but it's a longer period. So there is a
like QBO, is it?
Yeah, it's much longer actually. Yes.
Okay. QBO also has same periodicity, like 16 to 36 months.
Okay, right.
This is months or years? Months.
No, we are talking about the years, man.
Years.
Not
Okay.
months. Yeah, right.
Okay. Decade. And that talk was very nice and informative, especially on that dust influx from Atlantic region and that Pacific oscillation, decadal oscillation, etc. So, Dr. Tampan.
Yeah, thank you so much, madam. I'm sorry, actually, it got a little bit extended because the internet problem. I've been talking, but nobody was listening. So I had to restart from this. So I really taken a little more extra minutes. I'm really sorry for that inconvenience. Sorry for that.
Any other questions?
Sorry to Dr. Raghu, because actually I think he has been waiting in the wings. Thank you so much.
Yeah. Now I think I have great pleasure in inviting Dr. Raghu to make his presentation.
Okay, can you hear me?
Welcome, Professor. Yes, you are audible.
Okay, and can you see my screen? Are you able to see the PowerPoint? Hello?
No, I think still
Okay.
Your
Dr.
PC
Tampan's screen is on.
Okay, so I'm trying to share my screen. But, somebody in charge there who can tell me, or?
it's not the presentation, it's your computer screen.
Yeah, Dr. Raghu, we can
Desktop.
see your screen. You can see your screen, but actually, unfortunately, it is actually showing your file inputs. You are not actually showing the actual slides.
Okay.
List of files only.
Maybe you can stop sharing it and then again start share the actual. Yeah. Now we can.
But
No.
is it good?
Go to
Yes.
slide.
This is
Slide.
good? Yes,
Yes.
I'm in slideshow.
Okay. It's
Good. Start.
yes, it's very clear.
Okay, so I can stop in 15 minutes if you want, if you are running late and other programs are being squeezed. So should I limit to 15 minutes?
No, I guess you can take your time.
Professor Mohan Kumar.
He can go because another 25 minutes is okay.
25. Okay, let me just finish in 15 because I don't want to
So I think you can go for
negotiate. Huh?
25 minutes. You can go ahead. Let's talk.
Okay,
25.
I'll reduce by 5 minutes. Anyway, so I'm focusing on water quality and health, but only want to point out a few things. This is data from 2017, actually, which shows which shows how pollution across the globe, including toxic air, water, soil, and chemical pollutions are killing people. And India tops this list over China and our neighbors like Pakistan, Bangladesh, and so on. And unfortunately, this top part, which is cutting off anyway. So these are the number of deaths due to water quality diseases, which shows that over time, the number of deaths among children has been reduced, which is great news. But actually, the number of deaths among 70-plus-year-olds has unfortunately increased. And this is a global trend, and this is also a trend in India. And it's often related to various water quality parameters, access to clean water, wastewater treatment, mixing of wastewater with water that is used for other domestic purposes, and so on. And India is, of course, a tropical country, and we have very warm temperatures, which is very conducive to microbes growing in the water, and then monsoon comes and spreads it. So India is almost like a petri dish. So we have all these bacterial and viral diseases, cholera, typhoid, hepatitis, giardiasis, amoebiasis, and so on and so forth. And the idea is to understand the environmental drivers that create the disease outbreaks, and what are the socio-economic factors that exacerbate the situation in some places compared to others. And we also have a serious water quality issue, which is now being looked at INCOIS, at least in terms of data gathering, and also NCCR, National Center for Coastal Research in Chennai. But this is just a quick look at the data that shows various blooms, some of them harmful algal blooms, or diatoms, dinoflagellates, cyanobacteria, and so on, from 1908 to 1950, and more recent period 1950 to 2009. And you can see generally there is warming, there is sea level rise, there are more cyclones, urbanization, water quality issues. But there is, of course, also increases in blooms. So monitoring water quality and then converting them into early warning systems is fairly easy. Behra was referring to some of their activity about using Syntex to produce malaria forecasts and so on. And we had done this in the US, and we have done it for cholera in Bangladesh and so on. So you can use environmental variables. If you have disease outcome data, you can link them to various drivers. And then India has invested more than 500 crores in improving weather and climate forecasts, especially at S2S time scales, especially in the light of COP26, which has made a lot of news and is now beginning to be discussed in terms of the commitments and the consequences and the investments needed and so on and so forth. And all these nationally determined contributions typically focus on mitigation, renewable energy, electrical vehicles, and this and that. And there is specific words mentioned for adaptation and the cost of adaptation and so on. For a country like India, it is best to focus on these kind of timescales also, where you have day-to-day, season-to-season issues in food and water and energy and health. So producing or translating the improved forecasts into early warning systems for health is one example. And of course, it's not just the extreme events and the floods and the cyclones and inundation that are creating health issues, but even the droughts bring lots of health risks. And India remains quite high in terms of drought risks and related health risks as well. So the question is, how can we link the predictions and so on and so forth? So obviously one has to look at the transmission pathways that are related to climate drivers or weather drivers like land runoff, sewage, which is more of a human activity, solid waste in landfills, which end up affecting oceans and estuaries and seafood and recreation, also rivers and lakes, which affect water supplies, groundwaters, which affect crops, irrigation, which affects aerosols, which affect lots of pollution-related health, especially PM2.5, which is very high in India, and so on and so forth. So the typical paradigm used is El Nino Southern Oscillation and its impact on monsoon and related heat waves or droughts, or La Nina, which is happening this year, and maybe contributed a little to the late monsoons, but Arctic ice has a lot to do with the September-October heavy rain as well, and that is affecting now the cyclones, for example. So all these teleconnections from remote forcing exist, and we have some idea of how summer rainfall and northeast monsoon rainfall are affected by the El Nino, La Nina, PDO that Tampan mentioned. There are also North Atlantic connections and so on. And we have translated those kind of teleconnections also into elevated risks of diseases like cholera, malaria, now dengue and chikungunya are also very common. And of course, there are all the other water quality diseases like giardiasis, typhoid, and so on and so forth. So lots of attention is obviously being paid to extremes and their predictions, which is good because process understanding and predictive understanding of extremes is very important. And now extended range forecast, so you have the short and medium range, so 1 to 3 days, 3 to 10 days, extended range weeks 2 to 4, and then you have seasonal intra-annual forecast. And India is also doing now CNIP 6 for projections for the future, and the model is in fact doing very well. But the question is, what good is it if we produce all these information and they cannot be applied to things like agriculture, water management, energy management, and health, because health is a serious issue in India as well. And India is making a lot of progress in terms of warning people. So this is from Gujarat, looking at 3 years of data for waterborne diseases, diarrhea, typhoid, hepatitis, and cholera, and you can see the numbers increasing here. There are guidelines provided for prevention, but these are very broad, generic instructions, and people do not go into mission mode like we did with COVID, wearing masks and taking vaccines and so on. In the meantime, some private companies are using it to try to sell things, saying the water is a big problem in India. In India, 8 million people are affected by waterborne diseases every year, and they will sell you water. But the quantity of water that people can buy, or quality of that water, and access, physical and economic access, are always big problems. So obviously, a lot of this comes down to governments at local and national and state levels to try to help people with this. So if you look at typhoid and the incidences per 100,000 people, India is the bluest, so it has got 500 to 700 cases in 2017, worse than Pakistan, Afghanistan, Nepal, and Bangladesh, which is not good, even Sri Lanka, for example. Why is it? Of course, as we said, it's a huge country with lots of issues, and this is mortality rate per 100,000. Again, India tops the chart along with some African country here, which is Ghana, I think. So we need to improve this solution, and we are very close to doing that with the improved forecasts. So I'll quickly go through some specific examples of how important it becomes to predict at a very local level the environmental drivers of these things. It is very easy to take these disease outcomes and the pathogens that cause them, and then find environmental drivers, as I will show in a minute. But then comparing and contrasting neighboring places like Surat is here and Ahmedabad is here, they're very close to each other and around this Gulf here. But we will see that there are differences in rainfall, number of days, intensity of rainfall, and so on. So Surat and this part of Gujarat is basically at the end of the strong Western Ghats kind of heavy rainfall, coastal rainfall. So you can see that the number of rainy days is high here. Surat has in the range of 38 to 45, whereas Ahmedabad is down at 26 to 33. This is the average over time. You can also see a similar thing for rainfall, which I unfortunately, this is the average rainfall. So here Surat is getting about 1100 to 1464 millimeters in a season, whereas Ahmedabad is much drier at 380 to 742 millimeters. Obviously, Ahmedabad is a little bit richer than Surat, and population differences are there. So you can see that both cities have grown from 2006 to the present by basically expanding their boundaries and including wards that have been added. So the population differences are there, which I will show in a minute. But to quickly look at the number of normalized enteric fever or typhoid cases from 1997 to 2017, this is the only data we could get, and we could only get monthly data. To do it very well in terms of predictive models, you need daily data, preferentially at least weekly data, but getting data in India is very difficult, even if the data exists, and a lot of times data are not collected. But exercises such as these can help us guide to say what we can do much better if we had better data, and why we should collect better data as we invest so much in observations and improving weather and climate forecasts. So you can see that we normalize it basically because the population is not constant and it's not the same. So you have to normalize with respect to population and so on. So you can see that the Ahmedabad is very, very different than Surat over this time. Ahmedabad is showing a increasing trend since about 2005, whereas Surat has more like a decadal variability, and the colors shown here are strong La Nina, moderate La Nina, neutral years, moderate El Nino, and strong El Nino, and so on. And even the seasonal variability with the 25th and 75th quartiles are quite different between Surat and Ahmedabad. This you can see also in a bit more detail. So here we are looking at Ahmedabad cases composited on seasonal cycle for all these years. And you are looking at here minimum temperature and maximum temperature and the normalized typhoid cases. So the red curve is the same in all three plots. So this is the relative humidity, and this is precipitation. So obviously there is wintertime cooling, but as spring and summer arrive, typhoid cases increase, and then as rainfall kicks in, there is a bit of cooling and other factors play a role, and then cholera here drops a little. Then it has a second peak in the the stronger part of the monsoon season in July and August, and then it drops off. So this peak shows some relation with the increasing temperatures, but here the second peak seems to show a relation with increasing relative humidity. And the peak rainfall here is actually associated with the minimum in the normalized enteric fever or typhoid cases. So this tells you that there is a complex combination of temperatures, relative humidity, and precipitation that are playing a role. But when you look at Surat, it's again, the difference is quite stark here. It has only one peak, and that is in July or so, you can see. And the rise is here related more to the increase in the minimum temperature rather than the maximum temperature. And the peak is in fact happening when the maximum temperature is dropping and the rainfall is peaking. So relative humidity is of course maximum at the peak as well, but seems to be a combination of rainfall and relative humidity that is somehow controlling the cases over Surat in terms of when the seasonal peaks happen. So the distance between them is hardly a couple of 100 kilometers, but the El Nino and La Nina teleconnections are starkly different, which is apparently related to the outcome in enteric fever as well. But of course, you have to consider other factors. This is a summary that was nicely put together for by Times of India based on the paper we published this year, in fact, with Veena Iyer from Indian Institute of Public Health leading it, and there are a lot of people from Maryland involved and from IIPHG as well. So why Ahmedabad has more cases of enteric fever than Surat? We studied 20,544 cases in Ahmedabad, 6,092 cases in Surat. So already the base cases numbers were different. During warmer El Nino months, the risk of enteric fevers increased by 64% in Ahmedabad, but it actually reduced by 25% in Surat. Strong La Nina significantly reduced the risk of enteric fever in Ahmedabad by 31%, and moderate La Nina increased the risk in Surat by 21%. So we have to understand not only El Nino connections in terms of broad, drier monsoon and wetter monsoon, but local scale relative humidity, rainfall, and temperature changes and their evolution over the season for normal years, El Nino years, La Nina years, strong, weak cases, and so on. And there are other factors, other modes like the Indian Ocean dipole, Atlantic Nino as well. So obviously, one has to take the weather and climate forecasts, which are at various scales. For example, the deterministic weather forecast is being put out by IMD at 12 kilometers, sorry, and the climate forecasts are something at 36 kilometers. But one can use past data and AI and other statistical downscaling methods to produce local level information, and work has been done at IIT Bombay where we downscale to a farm scale and produce irrigation decision information. And this has been used by farmers from Sayagri farms and so on and so forth. Okay, so the low number of enteric fever cases in Surat was because of its unique cleanup strategies since 1994 when the plague scared them, and it's a business city, and the bad publicity they didn't like at all. So they have been focusing on improving the sewage treatment. Surat spent 65% of its budget allocation on water and sewerage, while Ahmedabad spent only 32% during 23 years. So you can see a stark difference. In fact, Surat has much more slum population than Ahmedabad. Ahmedabad is richer also per capita income. Surat is poorer, but it has managed its water better, and water quality has improved as well. Ahmedabad already had relatively many more human reservoirs of typhoid and salmonella bacteria than Surat historically, so that's another factor there. India accounts for the highest burden of enteric fever in the world, ranging between 377 to 550 cases per lakh people, and this must be reduced and can be reduced with the investment that India is making. Okay, so how to think about it? I already said that the forecast skills here, obviously, initial value problem when it comes to weather. It becomes chaotic very quickly. So after a few days, there is not much skill, but there is a skill at the so-called sub-seasonal to seasonal prediction, or the extended range prediction. Abhilash and several people at QSAT and at IMD and at IITM Pune are working on this. So there is various reasons why there is predictability here, but you can see that also drops off. And then we have seasonal outlooks. This is called predictability of the second kind, because here it is a boundary value problem where the slow variations in the ocean and slow variability of the sea surface temperatures because of the heat content and high heat capacity of the ocean begins to provide us predictability to multiple seasons like El Nino and related teleconnections. So the question is, how do we combine these to produce warning systems? There is something called Ready, Set, Go framework that is being run under the World Meteorological Organization, and India is a part of that, where you use these kind of seasonal outlooks to prepare what kind of a year we are going to have and what kind of impact it may have on agriculture, on water, on energy and health. And then you use extended range or S2S predictions to the set stage where maybe you want to assign resources, maybe you want to limit irrigation water use, energy use, and so on. So you set the system using a closer timescale information, which is now here to be more reliable. And then you go to the go stage, ready, set, go, where with the shorter weather forecast, which is reliable and is making good forecasts of extreme events and so on, you place rescue workers, disaster management, health workers, you distribute needed medications or access to hospitals, and various other decisions can be made. And you can create a lot of no regret decisions. For example, and for typhoid, there is a vaccine. People cannot be immune to it, so you can get sick and it can kill you in severe cases. Obviously, mortality is highest for India as well. But you can take no regret decisions like boiling the water, or if you can afford it, use bottled water, be careful about contamination with sewage and so on. So you don't have to close schools and do that, all those things. A lot of no regret decisions can be taken based on these kind of predictions. Why no regret decisions? Because till we can show that the skill is very high, you cannot close schools or close transportations or stop selling food and so on and so forth. So that's the case. The other thing that would be needed is to make risk maps. So using the detailed information on socioeconomics, because within a city, for example, a heat wave will have very different impacts on some neighborhoods than in other neighborhoods, in slums versus high rises where people have, for example, AC. So if there is a heat wave warning, they can wear masks, they can turn on the AC, they can travel in their cars, they don't have to take trains and buses and so on. So risk maps can be made at local neighborhood scales by using census data and other better organized data. Risk is defined as hazard times vulnerability times exposure. So hazard is, of course, sometimes not in our control because it is driven by El Nino or COVID or other extreme events and so on. vulnerability depends on per capita income, women's education, in what kind of building you live in, what kind of water supply you have, whether you have access to electricity, and so on. And exposure depends on infrastructure, how dense the population is, whether you have access to roads and hospitals and other things. So this is an example of a IIT Bombay group which made maps of coastal risks rankings for India. So you can see that there are places with high risks, and Gujarat is one of them. Parts of Maharashtra, Kerala is doing better, but we know that in the last few years, Kerala is getting hammered, not so much from coastal inundation and cyclones, but from Western Ghats rains and landslides and flooding and so on and so forth. And the eastern coast is also vulnerable. So once you know the risks at these scales, you can know the hazards and see where are the low-hanging fruits in terms of reducing vulnerability and reducing exposure. For example, reducing the, I don't know why my screen went blank, reducing exposure and vulnerability by educating women or giving better access to ambulance, hospitals, and so on, having better access to NGOs like ASHA, which do a lot of health work and so on, can actually reduce risk and make sure that the forecasts that are made at large scales actually get to the street level, to the last mile, so-called last mile, where people actually make decisions. Okay, so I will stop there. I think I took about 25 minutes as you ordered me to. So let me stop there and see if there are any questions. Okay.
There is one question from Umesh Prasad Verma from Amity University.
Yes, and do I have to read it? Or?
Despite having so great loss of life due to pollutants in the Indian region, COVID-19 had less effect. Reason for that?
Yeah, I mean, that is not a very simple question, in the sense that we don't know exactly how COVID is affecting different ethnic groups. For example, there is some evidence that children were not at all affected because they were, as children, when they play, go to daycare, go to schools, they get cold and cough a lot of times. So there is some evidence that maybe that builds immunity against COVID. So maybe dust and pollution has also made us, a lot of people in India actually go around with allergies. I mean, of course, serious cases of TB and so on exist, and so-called COPD, chronic obstructive pulmonary diseases and so on. So it is possible that the pollution is actually killing us in a slow time scale, but against COVID, it might have given us some short-term protection. But obviously, in the second wave, we had tremendous number of infections and deaths, and let's hope there won't be another wave. So COVID is a bit more complicated. It will be understood in the coming decades. There will be papers coming out for decades. So the simple answer is, I think respiratory ailments we have had probably provided some protection. Anything else?
Thank you, Professor Rekhu.
Yeah.
Oh, thank you.
Information, lot of information we could get from your talk, and I think there's serious concern of availability of daily data that is to be noted. I think.
Thank you.
I guess the bottom line is the more of the local conditions playing an important role than the correlation with the El Nino or La Nina, because the Surat case has shown. So maybe that's where we have to give the importance.
I think data is there. Many times hospitals and health agencies are collecting data, but they are very scared of sharing it. So even when there is data, they are scared of sharing it, and there is many times no data. But such studies can tell us how to translate improved prediction to the scales where health outcomes are determined by various socioeconomic factors and very local teleconnections from large-scale forcing. So the point is that in 5 years, we shouldn't be sitting in a meeting like this and arguing about the same things that data is not there. But we should be in a much better position in 5 years to say we have done better by learning from these examples. Thank you.
Also, more studies on the eastern coast may be required, as I have pointed out.
Everywhere, and
do
the connection between health institutes, hospitals, weather and climate people, biology people, instrumentation people, all that has to happen. And we need to bring tools like artificial intelligence and data analytics to understand the links, the patterns of weather and patterns of the health and so on. Such work is going on. IIT Bombay has a digital health center. There are other places doing this, but obviously we need many more such efforts.
Thank you.
Thank you.
Thank you, Professor Raghu, for a very interesting talk.
They're done, right?
Okay, and just now, I would like to, sir, whether I can, Vishwan sir, I can just brief that. Hello? Yeah. We would like to thank the 3 speakers of this session, Dr. Swadhin Bera, Dr. Tamban, and Dr. Raghu, Professor Raghu, was giving in some interesting and thought-provoking talks about the climate change and changing climate and its variability. Thank you all. Thank you for coming here and accepting our invitation and giving the good lectures. Thank you, each and every person. Now, Professor Dr. Vishwan sir and Leela Ram Kumar, I think you have chaired the session very well and kept the time. And also, we have now finished on time. Thanks, Vishwan
Thank you very much for relieving us.
Yeah, thanks, Vishwan sir and Leela Ram Kumar coming here. And Vishwan sir, I think you came much earlier.
No, I thought it was 9 o'clock.
Thanks a lot. Thanks a lot, sir. So,
bye-bye, everybody.
Thank you to all speakers. Thank you, Dr. Viswanathan, sir. Thank you, Professor Mohan Kumar. And I would like to thank all the organizers of this event. And I could see the other day's events also through YouTube channel. It was very well conducted and informative, and it's very apt on this scenario of changing climate. And it is good to have a very deep discussion on this topic. Thank you.
Thank you.
Thank you, Professor Mohan Kumar, for giving this opportunity. Thanks a lot. Bye.
Now we have come to the end of the plenary session. The next session will start at 11:25 a.m. after a short break. Thank you.
Good morning. Good morning.
Good morning, sir.
Morning. Full screen.
Where is Mohan Kumar?
Sir, excuse me, sir.
Please
We'll
let me know
start
when
the
we have to start.
we'll start the session at 11:25 a.m.
Okay. So we'll wait for some time.
Yeah. They have gone for a short break.
Okay, then you inform us, then we can start when Mohan Kumar comes.
Of course, sir. When he comes, I'll inform.
Okay.
Mute. আমার কোথায় camera? Where is camera? Mute and unmute button.
Subodh Kumar, how are you?
Yeah, I'm fine, sir. How are you?
Do you remember me?
Yeah, yes, of course. I came to IIT Kharagpur.
Yeah.
Yeah.
And when you had come back from Alfred Wegener, then you
Yeah.
went with me. You remember?
Yeah. I think it was
Long time back.
2006, I think.
Because I saw your name, so I was remembering whether you are the same person
Yeah.
who joined P.M. Goswami in IITM. So when I saw your face, so I thought he is the Subodh Kumar.
You remember? You have a very strong memory.
Yes. Still, it is okay. I will not say.
Where are you, sir? Now, where are you?
I am in Ahmedabad now.
Now in Ahmedabad. Oh.
Yeah. So I have joined IIT Gandhinagar as adjunct professor.
Okay. I see your affiliation in Kharagpur, still Kharagpur.
Also because they have, I thank these people, they have located my whereabouts. Good morning, Kumarji.
Please unmute it.
Can I mute it?
Sir, please unmute it so we can talk.
Yes, good morning.
Oh, morning, sir. Good morning. Yeah. Okay, sir. Now we are in 3 parallel sessions are going on. So we are moving here and there. Yeah. Okay, sir. Yeah. Now people are coming. First talk at you. Subodh Kumar. I think he's there. Okay. Okay, sir. I will see you.
Okay, then we can start, Mohan Kumar.
At what time? 11:25. 11:25 is the time.
Achha.
Another 2 minutes, sir.
Okay, better.
Okay. Thank you.
Yeah, I know him. Yeah. Is it on?
Yeah, it is also.
Oh.
Okay.
Good morning.
Good morning.
Good morning.
Good morning, Dr. Pandey.
Good morning.
Nice,
Sir. Good morning.
nice seeing you after many, many years.
Yes, yes.
I think now we are in IIT Kharagpur. I heard you.
I left Kharagpur about a year ago, but now I have come back to my original place, Ahmedabad, and I have joined IIT Gandhinagar as adjunct professor.
Okay. Okay then. I think it's about time we begin the session. You want to say something, Dr. Pandey?
Yes.
Yeah, please.
We can start then.
Yes. You want to make some opening comments? You can do it.
I will just, I think, let me speak 2 minutes, and then I will request you to conduct the proceedings.
Okay.
Yeah,
Okay.
yeah. So good morning to all of you. It is always a pleasure to meet our old friends and colleagues. The very senior Professor Ram Kumar, after a long time, I am seeing him, though not physically, but at least on the screen. And the first speaker is Mr. Subodh Kumar Saha, whom I know for a long time, because when he was working in Alfred Wegener Institute, he contacted me and then he showed his interest in joining the Indian Institute. Then I had suggested that it would be a good idea if you talk to the director of the IITM, and I am glad to see his name, that he is already in Indian Institute of Tropical Meteorology with a lot of experience. And in this session, we have the very interesting talks by different people from TUSAT, from IITM, and very interesting talks where they are trying to understand the interaction between the land, ocean, and atmosphere. And I think this is a golden opportunity or golden time in the history of the meteorology that you are having a lot of data from the space platform as well as from the in-situ observation to address this type of problem. So I will not take much time, and I will request Dr. Subodh Kumar to start and conduct the whole thing, and in the end, I will be with you. So thank you very much, Ramonji, for searching out me. I do not know how you got all the details about me. So this effort shows that people are really very serious in getting people who had been started this top med very beginning along with Kalla Saab, Doshi Saab, Rajkumar, Pal, and other my colleagues from Space Application Center, Ahmedabad. So thank you very much, Ram Mohanji, and I request you to kindly go ahead and start the proceedings of today.
Thank you, Dr. Pandey.
Good morning. Welcome to day 4, technical session TS7A of INTROMET-2021 on ocean land atmospheric interactions. In this session, we have 2 lead talks. First talk is delivered by Dr. Subodh Kumar Saha, scientist F, IITM Pune, and second one by Dr. S. Sijikumar, scientist F, Space Physics Laboratory, Trivandrum. The lead talks are followed by one invited talk, which is delivered by Dr. Dimitri Singh, scientist, Alfred Wegener Institute, Helmond Center for Polar and Marine Research. After the lead and invited talks, we have 4 short oral presentations. This session is chaired by Dr. P.C. Pandey, IIT Gandhinagar, and Professor H.S. Ramohan Kusat. Dr. P.C. Pandey, former director of NCPR, is an adjunct professor at the Department of Earth Sciences, IIT Gandhinagar, and holds immense research and teaching experience with specialization in space science, planetary science, climate satellites, polar remote sensing. Professor H.S. Ramohan is a retired professor, former dean, and director of Marine Sciences, CUSAT. During his teaching career, he molds the finest meteorologists and oceanographers produced by CUSAT with his specialization in Indian summer monsoon. The lead talk is for 20 minutes with 5 minutes for discussion. Invited talk is for 30 minutes and 2 minutes for discussion. And short oral presentations are for 9 minutes with 1 minute for discussion. We request the speakers to stick to the time allotted. Now may I request the Honorable Chairs to kindly take over the session. Thank you.
Okay. I think now may I invite Dr. Saha from IITM to give his lead talk for 20 minutes duration. You're all experienced campaigners, so you can, I know you'll stick to the time. 20 minutes plus 5 minutes of discussion. Dr. Saha, please.
Okay. Am I audible?
Yes, yes.
Thank you,
Please.
Professor Ramon and Professor P.C. Pandey. And good morning to all of you. I would like to thank the organizing committee and to my collaborator, Anupam, Samir, Hemant, Archana, Mahen, Hasibur Rahman, and Professor Goswami. Let me begin with this figure, which is estimate of hydrological cycle. What I want to highlight that about 65% of precipitation whichever falls over land is returned to atmosphere, and it is not only hydrology or water, it is also coupled with energy. Lots of energy is involved. It's partitioning in a sensible latent heat flux. Another important point is that whatever comes over land and goes to atmosphere through evapotranspiration, about 80 to 90% of that happens through transpiration. That is, vegetation is an important part. So this is a very important revealing, and land atmosphere interactions and variability depends much on this vegetations. Another important study done in 80s by Professor Sukla's group, they have shown that how the soil moisture, how the evapotranspiration affects the global climate. The first panel is a usual precipitation of usual model run. And when you cut up the evapotranspiration, that is a dry soil, you can see there is a dramatic decrease in rainfall except over India and Eastern Asian country. If you look at the pressure, surface pressure, the lower panel, you see there is a strong low pressure system developed over land region because of dry. So that indicates that evapotranspiration affects the global climate. Okay. And of course, it will have an effect on mean and variability. So the regional and remote land surface process
is not moving. Your PPT is not moving. You have only one PPT, first PPT.
Not moving? It's moving?
Your slides are not changing. You are still in the title. You are in the title page still.
I'm in title?
Yeah, you are not gone to the other slides.
Okay. So what to do now? Shall I stop share and then share?
Can you make it full screen? Yeah, but you have to shift the slides. Your slides are not moving. Can you press F5? Ask him to press F5.
Yeah. Now it's moving?
No, make it full screen.
Is it moving?
No, not yet. You're still on the title.
Still on the title? Okay.
Yeah.
Go
to the next slide. Yes. Yes, that's right.
No, it is coming. It's moving in the.
So could you please press F5?
F5?
Subodh.
Yes.
Hello. Yeah, Subodh, actually, you might have opened another tab in the same window where you have opened that in full screen. Can you close all PPT and open it again? Exactly. Whatever PPT open in your desktop. Using two monitors. Yeah.
Okay, just I have one PPT actually.
Yeah, close it and then open it.
Shall I close it? Okay.
Then share the screen and open it. And now the full screen.
Stop share.
Yeah. Now share the screen and then open the PPT.
share.
Yeah, go to presentation mode.
Presentation mode, full screen.
Yeah. Can you see moving? Shall I see, share the desktop?
Yeah, that is better. Yeah.
Share the desktop. Can you share the desktop?
Can you help with?
I think you can go ahead, but if you can make it full screen, that'll be nice.
That will be better.
Yeah, because otherwise it will be difficult to show.
Yeah.
Desktop share. How to share desktop? Close this one. Close this one. Not minimize. Just close it. Okay. Let me change. Okay. Okay. Leave and join. Sorry, where is the desktop sharing? No. Where is the file? No, where is the PPT? PPT? Where is PPT? Is it moving? Is it
not coming on the
desktop? You are not at.
Please open the file and
Open the file.
Your desktop is visible, but you open the file PPT.
Your desktop is visible. You have to open that Intromet the file.
Subodhji, do you
yeah.
have two monitors?
Actually, let me show. This is.
Yeah, sir, can we ask Sijikumar sir to start and then he will sort out and exactly.
Is Sijikumar ready?
Okay, then you go ahead, please. Let us not waste our time.
It's moving. It's moving.
No, 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 no.
Oh, okay. Okay, then maybe I'll sort out. Maybe next speaker can start. Then
I
I'll
think
start.
Yeah, okay. We'll go to Siji Kumar next.
Good morning, sir. I am available.
talk.
Yes, yes. No. This is both Kumar sir. I'm calling.
Please invite Sijil Kumar.
Yes. Siji Kumar, are you ready?
Good morning, sir. I am available.
Dr.
Morning,
Siji
sir.
Kumar?
I am available.
You're here. Can you begin your talk? Because there's some
Yeah.
issues with the Zaha's thing.
Okay.
Yeah.
Shall I share my screen?
Sure.
Yes, please. Sijil Kumar, please share the screen.
Is it viewable, sir? Full screen?
Yes, full screen.
Okay, very fine. So shall I start?
Yes, you can begin. Yeah.
Good morning, all. So I'll be very much thankful for the organizing committee for giving a lead talk in this prestigious international seminar. So I also glad to see Professor Sir and Professor B.C. Pandey. So today maybe I will be talking the regional estimates of greenhouse gas fluxes or using inverse modeling. So as we are aware of that greenhouse gases, sorry. Sorry, I'm actually button I pressed. So the greenhouse gas effect, we know that the radiativity, some gases which can absorb the radiation and re-emit the X along with the warm surface. Recently, the increase of these greenhouse gases create an additional warming. So this is termed as normally the enhanced greenhouse gas effect, which is contributed mainly from this carbon dioxide. The latest WMO greenhouse gas bulletin, if you are aware that 66% of this long-lived greenhouse gas warming, radiative warming is created by the carbon dioxide, and then followed by the methane emission, which creates almost 16%, and again, by the nitrous oxide, it creates 7%. If you see the atmospheric enhancement during the last 40 years, or from 1985 to 2000, you can see that the carbon dioxide globally average mole fraction is steadily increasing, and at present the mole fraction is around 413 ppm. It is about 150% more than the level of pre-industrial level. If you see the growth rate also, that the growth rate is also continuously increasing. At the recent years, the growth rate is more than 2 ppm per year. So this information is from the WMO greenhouse gas bulletin, the latest information. And for the case of methane, that increase is not like steadily increasing like carbon dioxide, but it is episodic. That means that near the beginning of the 21st century, the growth of methane is a little bit reduced, but again after some 5-6 years it's picked up, and now like that you can see from this the growth picture, you can see that around the 2000 to 2005 the increase is less, and after that again it started increasing. At present the mean global abundance of the methane is around 1890 ppb. This is almost 260% more than that of pre-industrial level. So if you see the emissions, mainly the carbon dioxide is emitted from the fossil fuel emissions. In that case also, the fossil fuel coal leads, recently the coal leads almost 14 gigatons per year. It is emitting total emission, then followed by oil and then natural gas and cement production. For the case of methane emission, the fossil fuel, 60% of the total methane emission is from the anthropogenic emissions, and in that 30% from the fossil fuels, and 40% from the agriculture, and agriculture mainly includes that livestock and or rice cultivation, and then 20% is from this waste management. So if you see the fluxes, how we can get the information, the emissions and the sinks of this CO2 and CH flux. Mainly, there are one approaches we are using is the bottom approach, in which we calculate the fluxes from the source specific regions, like for example, fossil fuel emission data and activity data from different countries. That is supported by the statistical modeling. At the end, we estimate the fluxes. This is called the bottom up method. But this approach has a main drawback, but it is mainly because of the poorly developed statistical methods and incomplete information about the activity and different emission sources. So recently, another method that is what we call this is called top-down method. This uses the information from the atmospheric mole fractions of greenhouse gases. That mole fractions contains the spatial and temporal temporal variation of the mole fraction contains the information of the surface fluxes. So this information embedded mole fraction can be reduced to use the information of the surface fluxes using a transport modeling. That is why from the observations we are again reducing the fluxes. That is why also called the inverse modeling. So this method is more reliable compared to the bottom-up method. This also has some drawback because this method also depends from the bottom-up inventory-based method. So that is the one drawback. In general, we can tell that the inverse modeling requires observations as well as a priori fluxes and transport model. Globally, this inverse modeling estimation of fluxes using the inverse modeling is increasing. Many countries are following. But unfortunately, in India, we don't have much groups working in the inverse modeling and to estimate the greenhouse fluxes. There are some few groups working in this. Recently, we have started working on this top-down method to estimate the carbon dioxide as well as the methane fluxes over the Indian region using regional estimation. We try to do. We use the Bayesian inversion method. In this Bayesian inversion method, the cost function you can use the cost function. This cost function mainly depends upon this unknown fluxes. There is unknown fluxes with the help of prior fluxes in combination with the atmospheric observations as well as the modeled concentrations of the greenhouse gases and uncertainties of observations and the uncertainties from the fluxes. So to minimize the cost function, this equation gives which gives the posterior flux information from the transport component as well as from the information from uncertainties. This inversion methodology also provides posterior uncertainty, which can be inferred from the both uncertainties of observation and prior fluxes as well as from the transport component. This, as we compare to the equation, we can see that the inversion method mainly depends upon the quality of the observations. So if you want a reasonably good inversion of estimation, we require a high resolution observations. So this uncertainty is the posterior flux can be used for define a network design for where we can capture these observations. So this the present work I tried to illustrate and design our optimal network which can measure the CO2 over the Indian region, and then we can use that then with the available observation how we try to estimate the CO2 fluxes using the inverse method as well as CHR fluxes. So these are the three main areas I am covering within this talk. So for the observational CO2 network, we normally use different areas. We are using the observation of CO2. This mainly to understand the seasonal or annual or long-term variation of CO2, or to study the local influence of the source of sinks of the over a particular region, or we can find out the source or sinks of the using the flux estimations. But these sessions mainly depends upon the logistical and
and may not be considering whether this particular location can add any other additional information to this biochemical system, or whether this information from this station can reduce an uncertainty in the estimation of the source of causing of CO2 in that region. So these questions we have to address before establishing a CO2 network stations. So there are some methodologies which can address these issues. One is that synthetic inversion that uses atmospheric transport model simulations and prior flux strength of the greenhouse gas. It is proposed by ending in, and another method is simulated annealing. This also mainly is using the seismological network, but the Rainer et al. Have proposed this can be used for the observational network for the carbon dioxide. They have found observations for Australia and Europe. And recently, not recently, but Patra and Mexico, they have proposed another computationally efficient methodology, that is the incremental optimization method, that uses the Bayesian inversion modeling and transport model for optimizing the network. We use this incremental optimization method for a design an optical network or carbon dioxide fluxes over Indian region. This incremental optimization method uses the uncertainty reduction by adding each one by one stations. Which station can reduce the maximum uncertainty? The uncertainty depends upon only the posterior uncertainty and the prior uncertainty. That this method doesn't depend on any observational data. For this work, what we have done is that we divided over the Indian region in a 2x2 grid resolution, 2x2 degree grid resolutions. Each grid we have assumed that it's a potential station which can measure CO2 stations, and then we try to rank this all these locations, these grids, in terms of its uncertainty reductions. For that we have used the flux path transport models. For the years 2012 to 2016, simulations are done for every 7 days. So total we have 17,000 simulations are done. The uncertainties we have taken from the fossil fuel uncertainties and biosphere uncertainties. And this, since Indian region is dominated by the seasonal wind reversal, especially from the strong monsoon system, so we have segregated our simulations in the seasonal basis. So seasonal basis, we have ranked each stations. For the seasons, we have divided the winter, January, February, pre-monsoon, March, April, May, monsoon season, June, July, August, September, and October, November, December as post-monsoon seasons. So if you see the ranking of each stations, at least minimum 12 stations are required to reduce, at least reduce around 50% uncertainty. The maximum reductions, uncertainty reductions we have seen during the post-monsoon season, the station could reduce about more than 50% uncertainty, but the lowest thing reduction with the pre-monsoon seasons. So based on this 12 stations, and the stations are different for different seasons. So we find out a optimized 70 locations which will be more adequate to observe the CO2 observations, which can capture the Indian footprints over the region. So these are the spread of the stations. The shaded regions are our proposed networks. The most of the networks we propose are over the Indo-Gangetic plain and the East India, and there are some stations over the southern region also there. These stations is able to capture more Indian emissions during combining all these seasons. So this work is published in 2019 atmospheric environment. So moving to the regional inversion methodology, what we have done is that we use we developed a inversion system using the flux path model. The flux path model is driven by the meteorological fields from the NSUP, and then from the meteorological flux path model output and the emission fields, we can calculate the enhancement due to the contribution from the fluxes, and then adding that enhancement to the background mixing ratio, we'll get that model mixing ratio by using inversion with reducing the mismatch between the observations and model mixing ratio, we can estimate the posterior fluxes. So for that, we have at present we have done the simulations. So for this 2018 and 17, using 2 observations from the Tumba and Senegat, we have taken the Senegat observation for the flash measurements of CO2, and Tumba is for the gravitating high resolution CO2 concentrations. Since the flash measurements are weekly, so we have segregated this Tumba also for the weekly emission, weekly data. With the weekly inversions we have done, the prior fluxes we are using the biosphere fluxes from the CASA, and the fossil fuel fluxes we are using from the ODIAC inventories. The inversion, after the inversion with 2 years inversion with the 2 stations, the first row shows that posterior flux derived from the inversions, and the second row we can see that what the difference between the posterior and the prior fluxes. With the 2 stations, the changes with the posterior fluxes is only over the mainly over that near to the locations over the observations. It's not covering all over the Indian region. The stations could not capture the emissions from the all over the Indian region. But there are October, November, the post-monsoon season, the reductions are more compared to other seasons. But still, these 2 stations are not enough to capture the posterior, correct the fluxes over the Indian region. So we are also looking at why this is there is some discrepancies in the Senegat and the Tumba region. Tumba region is always gives the positive values, and Senegat is negative values. Then we try to look in that the model and measured data mismatch. So the data mismatch is over Senegat because the RMSA is around 8 ppm. For Tumba, it's around 3.5 ppm. So this can be erased due to some prior fluxes, some biases in the prior fluxes. Mainly the prior fluxes, the largest values prior fluxes over the Indian region is from the biospheric contributions. So we try to look at the biospheric contributions. We use that from the CASA GFOT. So what we have done is that we have used another model, that vegetation photosynthesis model that's proposed by the Mahadevan et al. That this model is basically uses satellite data and from the meteorological data. The satellite data you can convert that enhanced vegetation index and the land surface index, and combining other these things, some scalar values, we can compute that gross primary productions. This is the light dependent part of the net ecosystem exchange, and then we can compute the respiration part from this meteorological data for surface temperature and consider this from these methodologies. We will get the net exhaust system between the exchange between the biosphere and atmosphere. So we derived this NE for this 2017 year. So we just compared for few slides. I am showing that we compared this for the June. The first row is called shows that VPRM derived biosphere net ecosystem exchange in the June, August, and October, and the second row shows that from the CASA GFOT biosphere. We can see that a lot of discrepancies. First of all, this VPRM gives a high resolution is around 0.05 degree resolutions, while the CASA GFOT is around 1 degree resolution. So, and also there is the values also underestimated in the CASA values, but in the biosphere, even the sink region over during the post-monsoon October months, also it's underestimated in this CASA. So these discrepancies may have some effect on deriving the model the carbon dioxide. So we have to validate this VPRM thoroughly or in the region. So we are doing this process with the observational data. So in that this VPRM fluxes we can maybe with the additional input from this additional station observation, we can derive more reliable posterior carbon dioxide flux over in Indian region. So for in the case of median estimation, we used this one more stations when we have got data from the Garangi, from the NARL data. So we have we used the observation from Senegat, Garangi, and Tumba for median observations. And And we have done this region inverse estimations. This figure, the shaded region shows that the footprint, integrated footprints from the transport simulations. We can see that mostly the footprints over the 2 years integrated region covers if we release particles from these stations, it covers mainly over the peninsular India. And also we can see that strong influence of the monsoon current. Even though it is the 2 years mean picture, but the influence from the monsoon current also we can see from the in southwest Indian Ocean to Indian land region, we can see that increase in the influence. So the fluxes we are using that from the anthropogenic and natural emissions from the different inventories for the EDGAR data and CAMS, Copernicus from the European Union data. And these flare fluxes and the transfer model simulation observations from the Tumba, we have calculated the model there and we can just model CO2 CH4 concentrations. The CH4 concentration, the model is shown for three stations are showing with observations. Sorry. The RMC is 0.03 ppm for Tumba and 0.05 for Garangi. And
you're completing your 20 minutes. Can you summarize?
Yeah.
Can you summarize?
2 more slides. So the RMC is lesser than this, or what we have shown from the carbon dioxide. So if you see the flux differences, you can see that mostly the first figure shows the prior flux and second is the posterior flux. The difference is in the last figure. It's mostly that peninsular India, the corrections are more than with the 3 stations. And the seasonal basis also we can see that during that winter season the corrections are more and compared to the other seasons. But there is a decrease in flux we can see during that post-monsoon seasons. But the less corrections are we can see only this monsoon season. But this peninsular Indian region, the fluxes are more. But still, if we see the prior flux information, lot of fluxes are from the Indo-Gangetic plains. So we may require further stations from this Indo-Gangetic or Northeast Indian region to quantify the posterior flux effectively over the Indian regions. More observations from that region are required. So when we corrected this fluxes, the uncertainty RMS is reduced. With that means that the fluxes could capture the corrected fluxes captured by the stations concentrations. So RMC is reduced over all the stations. So we summarized, we propose that 17 additional observational stations for a good regional estimation of the CO2 or CH4 fluxes over the Indian region. So that we can reduce our uncertainties in the prior fluxes, and it will be very good use for the national planning and mitigation for this greenhouse gas fluxes. Thank you, sir. This work is under the contribution from SPL as well as IITM and NAR. Thank you, sir.
Thank you, Sijikumar. That's a very interesting topic that you have chosen. I think if you have a better network of stations, I think we'll be able to estimate the greenhouse gases and all that much better. Thank you, Sijikumar. Thank you.
Okay.
Is Dr. Saha ready with this presentation? We can go back to that. He had some problem.
Yeah.
Dr. Saha, please.
Yeah.
Yes. Are you ready? Can you?
Yeah.
Go. Please.
Can you see it's moving? It's moving?
Yes, it is moving. Yes.
It's moving? Okay.
Yes.
Yeah. Yeah.
Okay. Yes. Okay, good morning to all of you. I would like to thank Chair and the organizing committee. And also I would like to thank my collaborator, Anupam, Samir, Hemant, Archana, Mahan, Hasibur Rahman, and Professor B.N. Goswami. Let me start with this estimate of hydrological cycle, which shows that about 65% precipitation on land is returned to the atmosphere, and the remaining 35% goes as a runoff. So this is a huge amount which is directly transferred from land to atmosphere through transpiration. One more important thing is that about 80 to 90% of the evapotranspiration happens through transpiration. That means vegetation. So vegetation plays a major role in partitioning this hydrological cycle, partitioning energy under that and sensible heat process. Another study done in 80s by Professor Sukla's group, which shows very important features of how the land and atmosphere interaction can be of global importance. They have done 2 experiments with wet soil, as usual land atmosphere interaction, and dry soil where land moisture is cut up, evapotranspiration is cut up completely. And you can see there is a dramatic decrease in rainfall everywhere except for India and some Asian countries. If you look surface pressure also there is a strong lows over land, and that indicates that there is a change in global circulation pattern. So regional and remote land surface processes are important for climate. Now these are all global things. Now moving to the monsoon. Monsoon we have different scales, different spatial and temporal scales. On diurnal scales, which happens in hourly time scale, we have thunderstorm. On days, we have a monsoon depressions. In week time scale, we have ISOs, all those things. And all they have some cascading effect from high frequency to low frequency. So, if someone thinks to predict some monsoon, seasonal monsoon or decadal monsoon, and then you must consider all the scales or high frequency scales. Otherwise, it may not be possible to succeed in skillful prediction. I'll show you some of the results. Another study based on a state-of-the-art global model, CMIP models, shown by Goswami and Goswami. It is rainfall distribution basically over different regions. This is the monsoon region, this is the Western Pacific region, this is Indo Sea and Amazon region. All regions are, and most of the models, almost all models shows that they cannot capture the heavy rain events. That indicates that there is a problem with subseasonal scales. For monsoon, we know the heavy rain comes from lows and depletion. So deficient rainfall and heavy rainfall means there is a problem with subseasonal scale model, and hence the problem may be with predictability with seasonal monsoon rainfall. So coming to ISMR prediction and predictability, the seasonal monsoon rainfall is nothing but a cumulative effect of all rain events on all time scale, synoptic or meso time scale. And the question is how much of the variability of rainfall, seasonal variability of rainfall, is anomaly is contributed by synoptic or interseasonal time scale, and are they predictable? In principle, any predictors who is affecting seasonal monsoon, they must modulate the subseasonal scale, because the subseasonal scale, they are the building block of the monsoon. Okay, but so far several studies shows that synoptic and interseasonal variability, they are noise. They have no contribution on seasonal anomaly of ISMR. But we believe this is the other way around. In this presentation, I so ISMR means all India average rainfall June to September. Okay. This is the figure which shows that how the subseasonal variance at defined band is related with ISMR anomaly. You can see the x-axis is periodicity. You can see the maximum correlation is in the synoptic band. That means synoptic variability is contributing maximum to the interannual variability of ISMR. And then it comes meso scale. Okay. And then the question is whether they are predictable. We correlated subseasonal variability with predictor ENSO to test it, and it also shows very strong negative correlation in subseasonal band, also meso band. So that shows that subseasonal components are not a noise; they have some predictive signal. Okay, this is the data for 30 years we have used. Now, what happened in the last decades or so, or 100 years? We have a long data and the observation. So here I am showing you the band, some specific band, 2 to 5 days, synoptic 10 to 20 and 20 to 60 days. Variances are correlated with ISMR on a 31 year moving window. So black line is for synoptic, blue line is for 10 to 20 days, and red is for 20 to 60 days. What you can see that synoptic has a very strong positive correlation throughout the last 100 years. It's very strong positive. but 10 to 20 days, you have a very strong positive in the 60s, but becomes negative. So what happens in these two phases, that the relationship completely change its phase. And meso, to see it is negative and increasing. So we looked at these two phases, the SST difference, and it is very interesting that we have a very strong video signal, AMS signal, and solar motion signal. So in nutshell, the seasonal and multi-decadal variability of and predictability of ISMR are closely related with signal subseasonal component, and as predictor modulates them through local as well as remote influences. In this talk, I will focus on predictors of land surface mainly. First, I'll show some example of remote influences of land surface on Indian summer monsoon. One of them is a Eurasian snow. The studies in 1976, again by Han and Shukla, shows that Eurasian snow cover, this was a satellite data, Eurasian snow cover is inversely related with Indian rainfall, summer monsoon rainfall. Similarly, our one study also shows that ISMR has a positive correlation over December, January, February snow over Eurasia and negative over Western Eurasia. Similarly for March, April, May. And there are several studies which is showing that there is a relation between Eurasian snow and ISMR. Another important features is that the first phase of the monsoon, from the beginning phase of the monsoon and or pre-onset and then post-onset, there is a lot of difference in land surface process. So first phase of monsoon is very critical. It may have a strong effect in land surface process. What I'm showing here is first UAF of May-June rainfall, and this is the second UAF. You can see the monopole structure over India, Indo-China Peninsula, and there is dipole structure, which explains 30% of variability, first UAF. And then if you correlate with the PC1 with temperature, surface temperature, 2 meter temperature for April and May, what you can see that there is a very strong correlation over Western Tibetan Plateau region. The contour, if you can see, this is the 1.5 kilometer height contour. And if you look for May, same correlation, this is very strong signal. This is a 119-year data and correlation goes up to 0.5 to 0.6. It's very quite strong signal. Not only that, northwest part of this region, actually the temperature of this region is strongly influenced by snow. The snow water equivalent x-axis and y-axis temperature. It has a very strong correlation of -0.68. And apart from that, the onset of Kerala also is related with temperature of our northwest region. So this region, a land surface anomaly, may be induced from some atmospheric phenomena or some predictors, and it has an effect on first phase of monsoon, and which may have an effect also in the seasonal anomaly. Now coming to local land atmosphere interaction, which can affect monsoon. One example would be the climatological interseasonal oscillation, which is basically phase lock. This is I'm showing the observed CISO pattern. You have a phase lock pattern. May you have a negative anomaly, then June positive anomaly, and then negative. Okay. So in May it is a pre-onset time. There might be some variability in soil moisture due to pre-monsoon rainfall, so which may affect the amplitude of CISO. So we tested in a very controlled model experiment, and what we found that when the model generates internally its own variability in pre-onset, we made a composite of years where you have a dry condition in May, okay, and then we have a wet condition. What we see that there is an enhancement of first phase of positive phase of CISO in June rainfall when we have a dry condition here. And if you like to see the numbers, so wet year and dry year, there we already see over central near 10 millimeter of rainfall difference. But if you see in the June, there is a dramatic change of about 90 millimeter of rainfall, and other months we don't have change because this is a control experiment. So this clearly shows that pre-onset time is very crucial. It can modulate the CISO, and which can have an impact on seasonal anomaly also. Now coming to the ISOs, what happened on the other time? Okay, this is also observation. The composite of a strong and weak ISO, and what is important here that there is a strong difference between lead-like composite, of course, there is a strong difference between weak and strong ISO. So our hypothesis was that an increase in rainfall during a break phase is followed by a weaker active phase and vice versa. And what we found that there is also a very strong instability before a strong active phase. This is the vertical gradient of equivalent potential temperature before the active phase, and then again it becomes a stable condition. So again we tested in model in a very controlled experiment, and what I am showing here that this is the time, and you have block a strong negative anomaly followed by positive anomaly and negative anomaly. So model also shows that there is some interaction going on with ISOs. Of course, it affects the amplitude of ISO, and which have effect on seasonal anomaly too. And we propose the feedback like this during break to active phase. Our soil moisture memory, which is on the time scale of ISO, modulate sensible latency flux and modulate the low level atmosphere stability, which again affect the coming phase of ISO, and then rainfall, and this goes like this. Another way of looking into land atmosphere interaction would be recycling. What is recycling? Recycling is nothing but a part of local evaporation is converted into rainfall in the same region. Okay, and recycling ratio is defined as a recycled rainfall by total rainfall. So once we can estimate the recycling ratio, and we have observed rainfall, total rainfall, we can get what is the amount of recycled rainfall. This is done with some diagnostic model. It is used as Gallon Blast model. It is based on soil moisture budget equation and use some analysis data, and then use observed rainfall data to partition it in recycled rainfall. What I am showing here that mean recycled rainfall during JJS, you can see there is a strong recycle in over North India and that part of Tibet. And if you like to see the recycling ratio number is about 15 to 20% for this region. And interestingly, you don't have much recycling over southern part of India. So this recycling may have also an implication in terms of changing climate or changing land atmospheric interaction. Also some evidence here. Here you have a trend in rainfall, JJS trend 1900 to 2015, and same thing for 79 to 2015. We have a drying in North India, and then everywhere it is increasing. So what could be the contribution from land surface? So this is the recycling rainfall trend. We have a decreasing trend over North India too, which is around 50 to 60 millimeter, okay, during this same period. And at the same time, we have got IMD observations, very good IMD observations of pan evaporation as well as evapotranspiration, which shows a very steady declining. And the pan evaporation decreases as a global phenomena. Atmospheric water demand is decreasing everywhere. Some places it is reason as a solar dimming or decreasing wind speed. And if you like to see the number, pan evaporation has decreased in the last 30 years about 100 millimeter. Evapotranspiration is decreased 150 millimeter, but rainfall is a 70 millimeter. So who is driving what? Also at the same time we have a global warming. All models suggest that monsoon will be enhanced in the future. We are already in a global warming phase. So probably it is the competing effect between global warming and the local feedback. That's why you see some places decreasing, but many places increasing rainfall. Now moving to the main part of the talk, seasonal predictability, smart predictability and prediction. We know several earlier studies, Kumar et al., they have shown at that time the model was very poor, they did not have any skill, and they estimated potential predictability. Predictability ISM is that the ability of it to be predicted, how much you can predict ISM, that is the limit, maximum limit. So they have estimated for Western model is 0.65. Now next generation model by Rajiv et al., they have shown that the model improved, but predictability limit is remain 0.6. Now also we have a skill of model close to 0.6, but predictability limit is also like this. So it looks like a paradox. So what is the limit of smart predictability? We used our CFS for hindcast. We have 4 versions of model. I will not go in detail. And each model has 16 ensemble for 30 years. We have total 1920 years of simulation. Okay, I'll come to results. What I'm showing here, the actual skill and potential skill. We have used two measures of predictivity. One is perfect model measure, where each ensemble member is correlated with others, and is an ANOVA method. There's a blue one ANOVA method, and red dot shows the actual skill. What you see here, what at least three model, actual skill is more than potential skill. How it is possible? Is it a paradox? So there might be some issue with the estimates. Let me brief you slightly on the method. The perfect perfect correlation method is based on the assumption that model is perfect and the error in forecast is due to initial conditions. But this is not true. Models are also imperfect because of physics and numerics. So all this contributes to this. So the assumption is itself not very adequate, or the method is not adequate to estimate the predictivity. So that's why we see the actual skill is higher than ANOVA method. So what could be the actual potential skill? How to estimate it? So basis is we have tried to give some estimate, and basis is that when you have some forecast system with some initial conditions, when you use some set of initial conditions, you end up with a one skill. If you use a different initial condition, you end up with a different skill. So skill depends on ICs. So one forecaster using one set of IC, other is using one set of IC, they will have a different skill. Why don't you estimate this very systematic way? How to do that? So what we have done, that we have a 16 ensemble member, and we have made a subset of this 16 ensembles. For example, if we make a subset of 8 ensembles, we can have thousands of subsets, and then each subset is ensemble average is correlated with actual observation. So we get a distribution of correlation. Now recall that in earlier perfect model method or ANOVA method, the predictability has no binding relation with observation. But here we are trying to make this predictability binding with observation. So once we have a distribution of all this correlation, we can get what is the maximum and minimum limit. So what I am showing here, this dot line is the minimum and the solid line is the maximum skill. These are actual skill. For an MPHY model, you can see it goes up to 0.82 for 7 ensemble member. So these are actual skill. So we can consider this as a maximum limit at the time the model is able to get. And these are the actual correlations. So this can be considered as a predictability limit, which is around 0.82 or 0.8. Now these are all model estimates. Now can we do it same from observation? We have tried this one. Our hypothesis is that all predictors are not known. Okay, some predictors we know, but we also same time we predictor we define by indices. They are also not perfect. So we cannot relate all predictors because they are not known with ISMR and do some kind of regression. Okay, and also we know that predictors first modulate subseasonal component and they have a projection on seasonal anomaly, right? So in the absence of complete understanding of predictor, can this linear projection of subseasonal component define the upper limit of predictability? So what we have done here, that has shown just 3 bands, 2 to 5, 10 to 20 and 26, 60 days band, and done multiple correlation with only 4 predictors, IMO, PDO, IOD and NINO3. So this is a multiple correlation of 2 to 5 days subseasonal variance, which explain almost 20 to 25% variance. For 10 to 20 days, it goes up to 40, for 50 also. For 20 to 60 days, it also goes 50 to 20%. So only with these 4 predictors. Okay. So can this subseasonal variance project onto seasonal anomaly, and what is the projection? So this is a projection of all the subseasonal component, blue line, on the seasonal anomaly, and which comes about maximum up to 0.9, and then recent decades. This is of course in a sliding window, 31-year sliding window, and then recent decade comes around 0.8. So this can be the limit, which is linearly projected. Subseasonal components are linearly projected on seasonal anomaly. And here red line showing here that these are the contribution by only 4 predictors, NINO3, IOD, AMO, which is contributing to ISMR anomaly. Okay, since we don't know all the predictors and only 4 predictors, of course it will be below this the blue line. Once we add one by one contributions of other predictors, they are supposed to go up. So this is maybe considered one limit based on observation, which is also comes 0.8. And also I would like to point because some earlier study has shown that in 1960s, 70s, ISMR predictability about prediction speed was more than 7 decade. This is also supporting this one. So finally, so what we have concluded that through this.
Dr. Saha, you have completed your summarize.
Yeah,
Dr. Saha, can you summarize?
So we have concluded that all this we can summarize through this cartoon. The giant octopus, intelligent guy, which has all information of these predictors, and then it is modulating the subsignal component and then ISMR. So conclude that it appears that ISM is a highly predictable system which has a predictability of 0.8, and numerical closure as I mentioned. I leave it there. Thank you very much. I will be happy to take any question.
Thank you, Dr. Saha. There are no questions in the chat box. No questions. If anyone wants to ask a question, right directly, you can. Anyone who's Dr. Pandey, any comments from your side?
I think it is very interesting work, and a lot more needs to be done further to firm up the predictability of this seasonal and various stage monsoon, reasonable monsoon. Very interesting work.
Yeah, thank you.
Let us thank Dr. Saha for a very informative and useful talk. The next invited talk is by Dr. Dimitri Sain. I think he's not yet joined anywhere. He's not seen. Perhaps in that case, we'll go on to the oral presentations, and if any joins in, we can always go back to the invited talk. So I now request Mr. Amal Joy to give his presentation, 9 minutes presentation on soil moisture temperature coupling over India. Mr. Amal Joy, please.
Okay, thank you. Am I audible?
Yes.
Yes, very much.
Okay.
Yes, go ahead.
Are my slides moving? Is it all right?
We are not able to see your slides.
Okay, you are not able to see my slides, right?
Yes.
Yeah.
Is it okay now?
You have to share the. No, not yet.
Okay. Yeah. Inshallah, I will share.
You have to screen share.
Yeah. Okay. Yeah. Okay.
Yes.
Is it visible now? Full screen, right? Is it all right?
Yes.
No. Please convert it into presentation mode.
Yeah. It's in presentation mode.
Yes. Okay. Now.
Okay.
Yes.
Is it audible? Is it moving?
It's full screen.
No.
Okay.
No, it's not. You first make it full screen.
Yeah, it's full screen.
Change to next, then we will know whether it is changing or not.
Not full screen. It's not moving.
Now?
No.
We are still on the title page.
Okay.
Still on the title page.
Is it moving now?
Yes.
Yes, now it's moving. Yeah. But make it full screen.
Okay, now it's okay.
But it's not at full screen. Yes.
Okay.
Make it full screen now. Now you are not sharing the screen now. Please make it go back to screen share. Make it full screen.
Okay.
Oh, yes, no, it's not.
Yes, yeah, that's right. Go ahead.
Is it moving?
Yes.
Yes, yes. Yes, go ahead.
Okay. Okay, yeah. My work focuses on the soil moisture temperature coupling over India. And land atmosphere interactions play a very critical role in climatic variability of a region. And the soil moisture is the most important land variable, and it partitions the next solar radiation to sensible and light and heat. And soil moisture can alter the thermal properties and have a control on albedo and cloud formation. And the soil moisture anomalies can remember the precipitation anomalies up to weeks. So it has a kind of memory like ocean. And many global studies like GLACE has focused on soil moisture atmospheric interactions, and much of the focus were given to the summer periods, especially the June, July, and October, November, December, corresponding to southern hemisphere. And these studies has identified some very important hotspots where we can expect a strong land atmospheric interaction. And these studies have shown that the strong land atmospheric interaction always occur along the transition zone between the dry and wet climate. And interestingly, the north and central India were identified as hotspots in this various experiments. After that, numerous experiments and works are conducted around soil moisture and monsoon onset and monsoon variability. But only a few studies have been done in the direction of the surface temperature relationship coupling and its seasonal nature. So here we explore the seasonality of soil moisture temperature coupling using physical and statistical metrics. And understanding of this interaction will help into the forecast, to improve the forecast skill of extreme events like heat waves and droughts over regions of strong coupling. Here is the theoretical background of the study. We have three soil moisture regimes called dry, transitional, and wet. In a dry transitional or in a dry area, below a particular value of soil moisture, that is below wilting point, evaporation doesn't happen. And above a particular threshold soil moisture, that is the critical soil moisture, the evaporation is independent of soil moisture. So between these two levels, there's a sweet spot where soil moisture is always depend on evaporation. And hence in a dry region the evaporation is strongly controlled by soil moisture, but its variations are too low to affect climatic variability. So in a very wet region the evapotranspiration is large, but is not controlled by soil moisture. So in between the transitional region both these factors meet, and we have a strong dependency on evaporation on soil moisture, and large evaporation variability is observed. And coming to the data and methodology, our first we use the pi coupling matrix. This uses the evaporation and potential evaporation from GLEAM data. GLEAM is a model comprised of a model which has algorithm which uses multiple satellite observations like soil moisture, vegetation, optical depth to estimate the terrestrial component of evapotranspiration. This matrix was firstly proposed by Mirals in 2012, and it's an energy balance method. We use evaporation and potential evaporation to calculate the sensible and saturated sensible heat, H and HP. So the effect of soil moisture is indirectly included in as the difference of sensible heat and saturated sensible heat. Then the pi matrix is calculated as correlation between sensible heat and temperature, and the saturated difference of sensible heat and temperature, and correlation of saturated sensible heat. And the net radiation used for calculation comes from ERA, and the higher values of pi denotes more coupling, negative value means no coupling. Next is the Notaros feedback parameter, which uses, contrary to the other method, this uses the subsurface soil moisture directly, and we have taken that from the GLADS NOFA model. And we have used IMD observational temperature to calculate the coupling. And the monthly anomalies of soil moisture and temperature were constructed, followed by linear retending. And the feedback parameter is calculated as the covariance, the ratio of lagged covariance between soil moisture and temperature, and the lagged autocovariance of soil moisture itself. Thus, the feedback parameter can be viewed as an instantaneous temperature response to the monthly variations of soil moisture, since both the numerator and denominator are lagged covariance. And we also calculate the correlation coefficient between soil moisture evapotranspiration and evapotranspiration temperature. A positive soil moisture evapotranspiration suggests that the evapotranspiration changes are primarily controlled by soil and happen in arid regions under water limited conditions. Whereas a negative soil moisture evapotranspiration implies that the evapotranspiration is controlled by atmospheric variable rather than soil moisture, and the evapotranspiration controls the soil moisture and occurs in energy limited conditions. And similar things happen for correlation between surface temperature and evapotranspiration. It is negative, and under water limited conditions, the ET increase in evapotranspiration resulting lower temperature, and this relation is positive under energy limited conditions. Coming to the results, we see the results of pi coupling between soil moisture and temperature during all seasons. We see that over central and north India during pre-monsoon, we have got a strong region of coupling of surface temperature with soil moisture. Also, the strong moisture is found over northwest India during the summer monsoon months, and these results are consistent with the previous identified hotspots of land atmospheric coupling. We also find that the weak coupling is found over central India during other seasons, and we also see weak coupling for west coast and northeast India during all seasons. During pre-monsoon, North India and Central India is mainly arid and semi-arid, so the contribution to evapotranspiration is mainly limited by water, hence we observe high coupling. Whereas during monsoon season, it is a humid, so it's mostly dominated by energy limited conditions, hence weaker coupling. We also see density scatter plots of soil moisture coupling strength. We see that in pre-monsoon season, we have a lot of grid points have soil moisture between 1.5 and 3. It's an intermediate soil moisture, so we observe high coupling. And if we look into the case of monsoon, we see that lot of points are very saturated, so we observe very low values of coupling. Yes. And for other seasons, if soil moisture is below a particular limit, for example 0.1, then we see very low values of coupling. Next, we look at the Notaros feedback parameter, where we see the surface soil moisture. We use subsurface soil moisture to incorporate the memory of deep soil ice. The same, we see higher coupling over North India, and West India during pre-monsoon, and a strong coupling over Central India is also observed in monsoon season. A similar pattern is observed for maximum temperature and minimum temperature, which is that soil moisture, subsurface soil moisture can impact maximum temperature more. And this is very important for the prediction of extreme even slight heat waves. Next, we analyze the correlation coefficient between soil moisture and evapotranspiration, and we see that during pre-monsoon one, we generally have a high correlation, and for northwest and west coast of central India, for all season, we have a positive correlation, and seasonal variations are correlation is stronger for central India, west coast, and northeast India. Next, we look at the correlation coefficient for soil moisture and evapotranspiration. We see higher values for pre-monsoon, especially over north and central India. And for monsoon season, we also see a peak on correlation over northwest and North India. To conclude, the strong coupling only exists under conditions with positive soil moisture evapotranspiration and negative soil temperature evapotranspiration. Soil surface temperature evapotranspiration. So we multiply positive soil moisture evapotranspiration and negative correlation of soil evapotranspiration and temperature, and we see hotspots over northern and central India very prominent in the pre-monsoon season, and hotspots over North India are very visible in monsoon season too. So, and land atmosphere coupling barely exists in winter. To see how soil moisture influences the different correlations, we draw scatter plots for correlations occurring in different soil moisture condition, and we see that under dry soil condition, especially in the pre-monsoon months, the grid points with positive soil moisture evapotranspiration are accompanied by negative soil temperature and evapotranspiration, which implies that soil moisture affect evapotranspiration and surface temperature, and hence a strong land atmospheric coupling exists over this area. As soil moisture increases, especially in the blue and green color, we see that soil moisture evapotranspiration relation is reduced, and soil temperature evapotranspiration even becomes positive. We see monthly variations of soil moisture. Okay. Yeah. Okay.
Ramaljoy, you must summarize, your time is. Yeah.
Okay. Yeah. We examine we use statistical and physical metrics to explore the seasonal nature of soil moisture temperature interactions, and we see that under soil moisture limited conditions, especially in pre-monsoon, we observe a greater coupling. Even though these statistical metrics has limitations, they all agree to a point that under pre-monsoon there is a strong soil moisture coupling, and this can amplify the heat waves events and drought through various feedback mechanisms. So a proper representation of soil moisture and their interaction is can increase the accuracy and prediction associated with these events. Thank you.
Yeah, that was a good presentation. I have one question.
Yes, sir.
You said that when the soil is very dry, or when the soil is very wet, the coupling is low. Is it right? Is that what you said?
Yeah. Yes.
When the soil is very dry or very wet, both cases the coupling is very low.
Yeah.
Why is that?
Because under very low soil moisture conditions, the plants cannot, the evapotranspiration generally decreases or no evaporation takes place. And in under very wet condition, even though if evapotranspiration takes place, its variability is very low to affect climate.
Okay. Thank you very much for the presentation. Any questions? Any other questions? Nothing in the text, right?
Nothing.
Okay. In that case, we'll go to the next talk by Archana Rai from IITM on evaluation of energy fluxes in the NCEP CFS B2.
Yes, sir. Full screen is visible, sir?
Are you ready? Yes, you can.
Yeah.
Yes.
Yeah. May I start?
9 minutes of presentation. Yeah.
Okay.
9 minutes
Thank you, sir.
Yes, go ahead.
Yeah. Good afternoon to all of you, and thanks all the chair and committee members. I'm going to give a talk on evaluation of energy fluxes in the CFS V2. This will be the outline of my talk. As we know, many regional and global climate models suffers from systematic biases in individual as well as individual components of energy fluxes and at the top of the atmosphere and surface. Regional climate models reported errors in the radiation budget component due to the uncertainty in the surface albedo. Many of the CME5 models also reported overestimation in surface albedo in most of the models and highlighted the need of refining the snow-covered albedo, and also suggest the reduction in albedo biases expected to improve by improving the temperature simulation. In CFS V2, the 2-meter air temperature is also underestimated, and overestimation of snow depth and delay in snow melt is observed over a large part of Eurasia, and that may be related to the biases in the surface energy fluxes. So in view of all this, we have evaluated the energy fluxes at the surface and top of the atmosphere from a long free run by CFS-V2, and we try to link it with the cold biases in 2-meter air temperature, particularly observed over the land. These are the data set we have used. We have used CERES data for the top of the atmosphere and surface radiation fluxes, 2-meter air temperature, and other reanalysis data and CFS-V2 runs, model runs. Now coming to the results, this figure shows the observed climatological annual mean from the observation, that is 2-meter temperature over land and SST over the ocean, and this is from CFS-V2 and CFSR, and this panel shows the corresponding biases with respect to observation. As we can see that a large cold bias exists over the European and Asian continents by about 8 degrees centigrade in CFS-V2, as well as over the North America. But in CFSR, the biases are not so much low. So to link it with the, maybe it is related with the surface energy fluxes, we have evaluated the surface energy fluxes in CFS-V2 at the top and surface. This is the energy balance equation in the surface, and there is a different components such as short wave radiation and long wave up, sensible and latent heat flux. So we have evaluated each components in the models. This figure shows the observed climatological annual mean for the net shortwave radiation at surface from observation, that is CERES data, satellite data means, and this is from model CFS-V2. This is the reanalysis, other reanalysis, CFSR, NCEP, and ERA M3. This panel shows the corresponding biases in CFS-V2 and other reanalysis in respect to with the observation. As we can see that a positive bias in shortwave radiation over the western coast of North America, South America, Africa region in CFS-V2, and it may be related with the underestimation of cloud over these regions, and similar type of biases is also observed in other reanalysis as well. And a latitudinal band of 40 to 60 degree around the coast of Antarctica also shows positive bias, and that may be related with the sea ice albedo over that region. And we can see that CFS-V2 underestimates the net shortwave radiation over the continental area of North and South America, Australia, and 40 degree north of Eurasia, that is over this region, where we have also seen the negative biases in 2-meter air temperature in CFS-V2. So we have also seen the annual cycle of global mean of all the components that is at the surface, that is net shortwave radiation, net long wave radiation, sensible heat flux, and latent heat flux. And we can see that CFS-V2 overestimates the net shortwave radiation at the surface, and the reanalysis underestimate as compared to observation, that is the black line. And in the case of long wave radiation, a large spread among models, reanalysis, and CERES data is seen in both the magnitude as well as the shape of the annual cycle. And CFS-V2 overestimates CERES throughout the year. All the reanalysis closely lies in the similar range. And in case of sensible and latent heat flux itself, in the reanalysis, there is a large variation in the components. So apart from the large variation in the components, a global annual mean picture and the imbalance at the surface is a good measure to see how the imbalance in the energy fluxes. And we can see then CFS-V2, the imbalance at surface is very less as compared to the other reanalysis. That means that it evaluated the energy flux equation at the surface very well. And now coming to the top of the atmosphere fluxes. This figure shows the annual cycle of global mean at the top of the atmosphere for the net shortwave radiation and long wave radiation. And CFS-V2 underestimates the net long wave radiation throughout the year at the top of the atmosphere, where the reanalysis data overestimates the net long wave at the top of the atmosphere. This is the global annual mean and an imbalance at the top of atmosphere. And we can see, as compared to observation, that is the satellite CERES data, CFS V2 has a large imbalance, about 6 watts per 6 watt per meter square at the top of the atmosphere, whereas other analysis also shows imbalance at the top of the atmosphere. Now, the cold, we have seen that the cold bias in 2-meter air temperature by CFS V2 over mid and high latitude of the Asian and European continents, and that is associated with the negative bias, as we have seen in the net shortwave radiation at surface. So maybe this bias is linked with this inaccurate surface albedo representation in the models. So we have evaluated the surface albedo in the CFS V2 and other analysis, and this figure shows that the climatological annual mean of albedo from observation, CFS V2, CFS-R, and other analysis, and this corresponding panel shows the biases with respect to observation. And the oceanic regions has a low values of albedo, whereas the albedo values are higher over the desert regions and over the snow-covered region mostly. And we can see that in CFS V2, the large overestimation is observed over the European and Asian continents. That is the mostly the snow-covered regions. And in other analysis, it is not so much high. And a negative albedo biases is also seen over the Antarctica region. So, in a nutshell, what is we have evaluated that the regions where the albedo values are overestimated shows an underestimated of net shortwave radiation, and that is exactly and that is also shows a 2-meter air temperature biases. Therefore, the overestimation of albedo causes over this region the negative biases in the net shortwave radiation that may be related with the negative biases, that is the low temperature over that regions. So this areas is the snow covered region. So the maybe the model representation of snow albedo is not accurate in the model. So these biases shows that the needs for highlighting the needs for modification of parameterization of snow albedo in the models. So the main outcome of the studies is that the CFS V2 shows a good imbalance at the surface, but a large imbalance of 6 watt at the top of the atmosphere. And CFS V2 overestimates the land surface albedo, particularly over the snow regions, which in turn contributes to the cold biases in 2-meter air temperature and highlights the need for improvement in the parameterization of snow albedo scheme for a realistic simulation of surface temperatures. Thank you.
Thank you, Archana, for sticking to the time and presenting your. Dr. Pandey, any comments on that you want to make?
Continue, sir.
Okay, thank you then. We'll go to the next presentation by. Thank you, Archana. Thank you.
Yeah, thank you, sir.
Thank you. Next presentation will be by Dr. Libby Thomas on the sensitivity of SST on the prediction of August 2018 flood event over Kerala.
Am I audible, sir?
Libby Thomas.
Am I audible, sir?
Yes, you are. You have 9 minutes. Yeah, you have 9 minutes from now on. Go ahead. Share your screen.
Is it visible now?
Yes, it is. But make it full screen. Yes, very good. Carry on.
The main objective of this study is to find the impact of sea surface temperature on prediction of August 2018 flood event over Kerala. For this, we extensively utilized the weather research and forecasting model. Sea surface temperature is the critical variable which determines the moisture content of atmosphere. It also affects the large scale circulation of the atmosphere. The model domain used for the study is shown here. Left side is the peninsular India and adjoining ocean. That is the outer domain. The resolution of the outer domain is 15 kilometer. On the right side, you can see the inner domain, which is having a 5 kilometer resolution. The specifications of WRF used for this study. We used the Grell-Devani ensemble scheme for cumulus parameterization. Used the RUC land surface model, and number of grid points for outer domain and indoor domain given here. And model is configured at 32 vertical levels. The data used are 0.25 degree NSUB FNL data is used to create initial and boundary conditions. And the USGS 30-second data is used as terrain data. Again, the land use in USGS data is replaced by the advanced wide field sensor data during the year 2018. This EVIPS data is latest data. This NRC EVIPS data is available from IRS Physics resource set. Then sea surface temperature from observations and forecast are updated in the model. For that, we used 0.25 degree OISST data. And this OISST data is analysis constructed by the observations from ships, buoys, and Argo floats. Again, the SST from CFS climate forecast system is used to run the WRF. These are the figures of OISST and CFS SST used in model integrations. And coming to the experiments done, first we have done sensitivity experiments to find the suitable combination of parameterization scheme for this particular heavy rainfall event. After doing some sensitivity experiments, we after getting the best suitable combination of parameterization schemes, we kept that experiment as a control experiment. Again, these set of experiments are repeated by updating the OISST. As a third set of experiment, the CFS SST is updated during the integration. Coming to the results, these are the 24-hour accumulated rainfall from India Meteorological Department gridded data. And the second row is the model simulations, which start from August 11. Third row is model simulation starting from August 12. This is the control simulation. The maximum rainfall occurred on August 14th and 15th of August. You can see the rainfall along the west coast and the Western Ghats region is over-predicted in control simulations. The right side figure shows the control minus observations. On August 14 and 15, the rainfall is over-predicted in control model simulations. Next set of experiments we conducted by updating OISST. When we updated the OISST, the over-prediction of rainfall along the west coast and the northern Kerala region is decreased when we updated the OISST. Right side, we can see the OISST minus observations where we can see the decrease in overestimation of rainfall when we updated the sea surface temperature. Again, we updated the CFS SST for the same set of experiments. And here you can see the location of a maximum rainfall. The central part of Kerala is captured by the model when we use the CFS SST and when we use one-day lead in simulations. You can clearly see the overestimation of rainfall is decreased when we use the CFS SST in simulations. These are the area averaged rainfall over Kerala region from control OISST and the CFS SST. In control simulations, the rainfall amounts are overestimated. When we updated, the overestimation of rainfall became less. The daily mean of 850 HPA wind from ERA 5 data and model simulations with 4-day lead, 3-day lead, 2-day lead, and 1-day lead is shown here. This wind is for August 14th. So you can see the wind intensity is with 1-day lead is close to the observations. Similar type of observations results we are getting from when we use YSST and CFSSST. Again, the 850 HPA wind on August 15. This day, the maximum rainfall occurred. The wind is over predicted over peninsular India and Bay of Bengal when we are using more the 5-day lead, 4-day lead, 3-day lead, and 2-day lead. When we are using the 1-day lead, the wind intensity and direction are coming close to the observed ERA 5 data. When the forecast lead days are increasing, the wind become more strong. And when the lead time decreases, we are getting more accurate intensity of wind. So the conclusions are the rainfall is over predicted in control simulation along the coastal region, Western Ghat region, Northern Kerala. Location and intensity of maximum rainfall is captured in model simulations while using CFSSST and using 1-day lead. The daily mean of 850 HPA wind is over predicted with simulation using a 4-day lead, 3-day lead, 2-day lead over Bay of Bengal or peninsular India. But 850 HPA wind intensity with 1-day lead simulation is similar to the observed ERA 5 data. The simulated rainfall pattern over Kerala is improved when SST is updated. Further improvements in SST, further improvements in rainfall can be obtained by the bias correction of SST. These results can be used for the better prediction of extreme rainfall events. Thank you.
Yes, you're finished before time. It's good. I have one comment to make. I think your presentation is more about predicting extreme rainfall event than floods. Extreme rainfall doesn't necessarily mean a flood, right?
Okay.
So when you talked about August or something, I was thinking that you're going to talk about the flood. You weren't talking about any extreme rainfall event. SST sensitivity to extreme rainfall. Rainfall itself doesn't mean a flood. This happened in August. Suppose same thing had happened in June, you wouldn't have had a flood at all. So I think your title is a little misleading to me.
Okay, I will change.
Comment that I have.
I will change.
So that's my comment. I mean, you can answer if you want. Otherwise, the work is good. There are no questions in the chat box either. So thank you, Dr. David Thomas. Thank you very much. We'll go on to the last talk of this session, presentation by Dr. Smita. She'll be talking on warming in the Arabian Sea during the recent decades and its impact on surface concentration. No. Dr. Smita, are you ready? Yes, Smita, you can begin.
I think she's not audible. I think she's not audible. Her audio is not.
Smita, I think you're muted. You're unmute and make the presentation.
She's not unmute, but she doesn't have a audio. She's panelist, right?
Yeah, I think that was the problem.
Yeah, she's panelist, but she actually doesn't have volume. Smita, can you begin?
Can you up the volume?
Increase the volume if you are. Or you're muted.
മൈക്രോഫോൺ മോളിൽ വെച്ചിട്ടുണ്ടാവില്ല അല്ലെങ്കിൽ ഇതിന് എന്തെങ്കിലും പ്രശ്നം ഉണ്ടാവും ഹെഡ്സെറ്റ് കൊടുത്ത് നോക്ക് ഒരു ഹെഡ്സെറ്റ് കൊടുക്കുക
Headset. Smita, we can't hear anything so far.
Headset മാറ്റി. Sir, hello sir.
Smita, you can begin.
Can you hear me now? Can you hear me, sir?
Go ahead.
Okay,
yes,
sir.
I can hear you. Yes.
Okay, sir.
Yes, you can begin. Go ahead.
Hello, I'm Smita from Kochi University. My topic is warming in the Arabian Sea during the recent decades and its impact on surface chlorophyll distribution. So we know that the tropical Indian Ocean warm is experienced a rapid increase in the sea surface temperature during the last few decades. And this Arabian Sea is one of the highly productive regions of the world ocean, and so it is influenced by summer monsoon phenomena, and which brings about changing current patterns and also some wind patterns. So this causes considerable change in the upper ocean dynamics. So this warming usually increases the surface stratification. So what happens is when stratification is high, it suppresses the vertical mixing from the deeper ocean, and it adversely affect the biological productivity. Usually in the upper ocean is nutrient deficient. So when there is some vertical mixing happening, it brings the nutrient rich subsurface water to the ocean surface and increases the production. So when there is a warming in the ocean happening, it increases the stratification and reduces this biological productivity. So I have just analyzed how much there is a change in XST has occurred during the last few decades of 50 years. I have taken 50 years data from Hadley SST 1971 to 2020, and it is available at 1 degree spatial resolution. And this data uses SST from Marine Data Bank and ICORS, and also from 1982 onwards, a blend of in situ and satellite-derived SSTs are used in this. Along with this SST, I have analyzed how the surface chlorophyll concentration has changed in the Arabian Sea. For this, I used Ocean Color Climate Change Initiative data, which is a merged data set using input from MERIS, MODIS, VAERS, and CDIS data. It is available at 4-kilometer resolution, and from 1998 to 2020, I used the entire period of 23 years. This is one of the best data set available with the minimum, with the least cloud data gap. So this is the SST distribution over the North Indian Ocean during the 50-year period. And this is one is the annual SST, and this right side is the summer monsoon period. So in this, we can see that in the northwestern sea, Arabian Sea, the SST is less compared to southeastern Arabian Sea, and during the summer monsoon period, the gradient across these two regions has increased, with SST further decreasing in the northwestern Arabian Sea. And for this period, I have calculated the trend for both the annual and summer monsoon period, and we can see that the trend is shows a positive. The trend is positive in the northwestern Arabian Sea, and in the seas it is less. And the entire Arabian Sea shows a positive trend, except for a small region near Somali coast. And during the June to September period, that positive trend, the increase in SST is very high near the northwestern Arabian Sea. So I have chosen two regions to compare. One is in the southeastern Arabian Sea from 72 to 76 east and 8 to 12 degree north, 4 degree by 4 degree box, and another region is in the northwestern Arabian Sea where high positive trend is observed. It is from 58 to 62 degree east and 18 to 22 degree north. So this is the average SST during these two regions, and on the left side it is annual SST, and you can see that in the southeastern Arabian Sea SST is higher by about 2 degrees compared to the northwestern Arabian Sea. And during the June to September period, there is a decrease in both these regions. And the SST trend, what we observed is, what I calculated is, for the seas, box 1 in the southeastern Arabian Sea, an annual increasing trend of 0.63 degrees Celsius is observed over 50 years. And in the northwestern Arabian Sea, the trend is much higher. It is about 1.02 degrees Celsius. And during the June to September summer monsoon period, for the southeastern Arabian Sea, the trend is 0.634. There is no much difference from the annual, but for the northwestern Arabian Sea, the trend is showing about 1.58 degree Celsius over 50 years. So there is an increase in SST of 1.58 in the northwestern Arabian Sea during the last 50 years. Along with this, I analyzed the chlorophyll, how the chlorophyll distribution has changed over from 1998 to 2020, and this is the annual mean and summer monsoon period mean of the chlorophyll concentration. And we can see that in the open ocean, the chlorophyll is value is very less than 0.2 to 0.3 milligrams per meter cube. And towards the coastal regions, the values are getting high. It's about 1 to 1 milligram per meter cube is seen. And you can say that on the northwestern Arabian Sea, that chlorophyll is comparatively high when we look at the values southeastern Arabian Sea. But during June, the summer monsoon period, the chlorophyll has increased substantially in the northwestern Arabian Sea to more than 3 milligrams per meter cube, and also along in the entire southwest coast of India, chlorophyll is showing an increase. So this chlorophyll increase in the chlorophyll, it is caused by many physical functions like coastal upwelling, lateral advection by currents, open ocean upwelling by Ekman pumping, and wind-to-wind mixing. These are some processes that leads to high chlorophyll. So I have computed the chlorophyll trend in chlorophyll, and these are the images for annual trend and for June to September trend. And in the annual trend, we don't see much. The trend is very negligible. And for the June to September period, We can see that in the southeastern Arabian Sea, along the coast, there's a negative trend is observed. But away from the coast, a patch of positive trend is observed. And in the northwestern Arabian Sea, near the coast, the trend is negative. That means the chlorophyll concentration has reduced over the 23 years. But patches of region where chlorophyll trend is increasing also is observed in this region. So I have taken the same two boxes where same as the SST analysis, and this is the average chlorophyll in these regions for both annual and June to September period. And you can see that for the southeastern Arabian Sea, the chlorophyll concentration is less compared to the northwestern Arabian Sea. And during the June to September period, in both the values has increased. And the trend what I observed in this region is for the average chlorophyll, there is a decrease in chlorophyll is observed about minus 0.092 milligrams per meter cube over 23 years. And for northwestern Arabian Sea, it is about 0.047. And for the June to September period, for the southeastern Arabian Sea, the trend is negative minus 0.3 milligrams per meter cube. And in the surfacely on the northwestern side, we see an increase in the chlorophyll concentration, which is about 0.64 milligrams per meter cube. This is the SST chlorophyll variability I analyzed using the SST and chlorophyll anomalies. And you can see that SST is increasing. Yes, sir. Yes, sir. This is one northwestern Arabian Sea. What I have seen is even though in the June to September period SST is increasing, but at the same time what I have observed is the chlorophyll value is also increasing. One reason for this is the increase in the intensification of wind in the northwestern Arabian Sea, which counteracts the stratification. So even when the SST is increasing, the strengthening of wind counteracts this stratification and still brings about the upwelling, intensify the upwelling and bring increase chlorophyll concentration in this region. And for this southeastern Arabian Sea, I have analyzed two different patches where high and positive and negative trends are seen. And we can see that along the entire Kerala coast, there is a decrease in the chlorophyll concentration along with an increase in SST. So for this 23-year period, chlorophyll has decreased by minus 1.75 milligrams per meter cube. And during the same time, SST has increased by 1.61 degrees Celsius. And the correlation between both is 0.52, and we can still can say that chlorophyll changes in chlorophyll is not entirely dependent on SST. There are other physical parameters like wind and sea level anomaly, currents, all playing an important role in the modification of chlorophyll concentration. And for this increasing trend, what I observed, this usually in this region, chlorophyll is there is not much change in the chlorophyll, but the increasing trend maybe is caused by a high which is observed during 2016, and at the same place also SST is also increasing in this region 1.54 degrees Celsius over this region, but the chlorophyll it doesn't change much in the region except for 2016. So for summary, I observed increase in SST in the northwestern Arabian Sea by 1.58 degree in during June to September period, and and in the seas it is about 0.63 degrees Celsius, and chlorophyll concentration in the sea is decreased by 0.3 milligrams per meter cube, whereas on the northwestern Arabian Sea an increase in trend of 0.64 milligram per meter cube is observed. So the influence of increased wind stress along the coast, it is a factor that leads to a positive trend in chlorophyll in the northwestern Arabian Sea despite the increasing SST. And along the Kerala coast, SST showed a positive trend of 1.61 degrees Celsius, and along with a negative trend of minus 1.75 milligrams per meter cube for chlorophyll concentration. Thank you.
Thank you, Dr. Smita.
Thanks, sir.
Pandey, you would like to comment? Pandey?
Number one.
What is the last presentation of this session? Dr. Pandey, would you like to conclude?
Are you able to hear me, Smita?
Make your comments.
Yes, sir.
Are you able to hear me? Are you able to hear me?
Yes, sir. Yes, sir. Yes, sir.
You use the data which is away from the coastal region are chlorophyll A measurement and surface temperature measurement. If I want to use data that are contaminated, so the response may not be very accurate. Okay? And then
Sir, pardon me, sir. Could you please repeat again?
I am suggesting you take the data which is away from the coast, let's say around 50 kilometers away from the coast.
Okay.
Yeah, otherwise what will happen? These sea surface temperature and chlorophyll will be contaminated by the land. Okay? Are you able to hear me, Smita?
Yes, sir.
Are you able to hear me, Smita?
Dr. Pandey, actually we couldn't hear you properly.
Yes, sir.
And
we could hear you properly.
Also, check what is the accuracy with which this chlorophyll.
We can't hear you. Dr. Pandey, we can't hear you.
Not coming come here. Our marketing has come here. So I have to. Okay, you go ahead there, sir. Okay, I am not getting it, and something else has come here. So something is wrong. Now you are able to hear me?
Yes, sir.
So I was suggesting.
Not yet, not properly.
It is not coming properly. Now you are able to see? Hear me?
Yes, sir.
Yeah. You use the data.
When it is breaking.
You use the data.
Sound is breaking, sir. Yes, sir.
You use the data which is away from the coast, number one, and you must track what is the accuracy with the measured. Okay, that is the two important things you have to take care.
Oh, okay, sir.
Yeah, in future studies, so you take care of these things. Okay, yeah, good.
Okay. Okay. Thank you, sir.
Thank you, Dr. Pandey. I think we now come to the end of this session on ocean-land atmosphere interactions. We had 6 presentations. Unfortunately, we couldn't get Dr. Dimitri Sen. He didn't join us. Otherwise, all the other presentations were well presented and very interesting. The Sahas and Sijikumar's in particular, very informative. The other presentations also were good and very interesting results have come out. I think a lot more work has to be done on this. Thank you very much to the organizers for giving me the opportunity to be here today as a chairman for this session. Thank you very much.
Now we have come to the end of this session, TS7A.
Thank you, sir. Thank you
Next
very
session
much.
will
It
start
was a
at
pleasure seeing
2:15
you after a
p.m.
long time.
after the lunch
Rammohan
break.
ji.
Thank you.
Thank you, Ramon. Thank you.
Can keep the bag somewhere here. Go for the photo session. Have lunch and then come. I'll just come in 2 minutes. During validatory session, I have presented PPT, player PPT. Okay. You can have it in the podium using the laptop. You will be speaking from the podium. Can I play it from that page? That screen, on the that monitor. Whatever name by which you will log in, will give you the panelist and then screen sharing becomes that you can okay.
Thank you, Chair, and a very good morning to everybody. It is a pleasure and honor for me to present this talk at the INTROMET 2021. I thank the organizers for giving me this opportunity. In recent years, we have seen many extreme events all over the world. The forest fires, floods, mudslides, droughts are widely reported in the global news media. The frequency and intensities of these extremes are likely to increase in the future under the global warming stress. These are affecting the global economy and sustainability, especially for developing and underdeveloped economies. For example, one of the estimates suggests that by 2030, we'll have a loss of close to 17 trillion worldwide due to river inundations and floods, half of which will be in Asia. And I guess half of that, like about 3 to 4 trillions, will be in India. Cities like Mumbai, with a population of 18 million and with a net worth of today about 1 trillion, is very much vulnerable to sea level rise, floods, and coastal inundations. We see that every year during monsoon time. Human population is also getting more vulnerable to infectious diseases, like what you have seen in case of COVID. And extreme events under the global warming, I think, will make the pandemic-like situation even worse. In addition to that, in oceans, we have seen marine heat waves, ocean acidifications, and marine litters. Now, these extreme events are being shown to be linked to global warming, but I think there is a missing link here. The global warming and extreme events are linked through the climate phenomena, such as the El Nino, the La Nina, the Indian Ocean Dipole, and many such climate phenomena. I'll give here a few examples. Like we found that the heat stroke related deaths in Kanto region of Japan, I think in several parts of Japan, are related to La Nina and the Indian Ocean Dipole. And that will, of course, be increased due to global warming in recent times and in the future. Similarly, for India, I think the heat waves are also linked to what is happening in the tropical Pacific, tropical Indian Ocean, and the tropical Atlantic. Those climate phenomena are rooted in the oceans, and a sustained network of ocean observations, especially the Argo floats, which came in recent times, are helping and will continue to help us in developing our understanding and improving our predictions. Talking about the predictions, we have a remarkable progress in climate modeling and predictions in the last few decades, starting from the toy model of Manabe and Bryan. I'll give you full mark if you recognize them on the left photographs here, together with Smagorowski, who was the architecture of that climate modeling at GFDL. Starting from that toy model they developed at that time, which was very much close to observations, which was actually giving very much the results close to observations, are now improved to be global climate model with 10-kilometer resolutions. And that kind of thing, I think, is recognized by the Nobel Prize in Physics given to Professor Manabe this year. I'm sure Cork's contribution was hidden in that. At Jamstack, we have been working on these climate informatics, climate predictions since 2000, together with several centers like CMCC in Italy, Lausanne in France, and Max Planck in Germany. We developed this Syntex Frontier Climate Prediction System, which is one of the leading climate models in the world to predict El Nino, the Indian Ocean Dipole, the monsoon, and several climate phenomena. It's a remarkable success in predicting El Nino, and IOD is well known. I'll give you here one or two examples. One example is the 2015 El Nino predicted from February 2015. And the predictions were very accurate, both for El Nino as well as the below normal rainfall for India, and also droughts in Southern Africa. The second example here is about the 2000 positive IOD event, which was predicted well in advance. Like in November of 2018, we have started predicting the 2019 positive IOD and its impact in Australia and several other parts of the world, which was later came out to be true. This is the latest prediction of Syntex initiated on 1st November 2021. I'm sticking my neck out here. You can see that unlike several other models, the syntax F is predicting a La Nina Modoki-like condition in the tropical Pacific, whereas many other models are predicting a La Nina state in the tropical Pacific. However, the impact on, especially in East Asia and Southeast Asia, could be very similar because the impact of the impact of La Nina and La Nina Modoki are not very different in those parts of the world. We are also doing a lot of predictions for the sea ice and polar climate, in addition to subtropical climates, as the research community is very busy predicting and understanding tropical climate variations. So it's getting traffic jams. So we are moving to other regions. Also, the Arctic is getting crowded now. So we choose to do some experiments for the Antarctic region, especially the Weddell Sea, as Ross Sea is also very busy with the climate community. So we find that the sea ice thickness is a very important factor in predicting sea ice. So we need to initialize accurate sea ice thickness in addition to subsurface temperature, because subsurface temperature is very important for prediction in polar latitudes, especially the upwelling of warm waters will kind of influence the sea ice extent. And we are quite successful in that, and we hope to continue to develop our predictions for the polar regions. We know that the model is doing quite well, but we also have failures in several years. And also the model has difficulties to predict climate in subtropical and mid-latitude regions as like any other models. So we are continuing to improve. We have improved from F1 to F2, and now we are trying to develop the F3 model with better physics, better resolution, and more number of layers in the vertical, and also included the subsurface initializations and increased the number of ensemble from tens of members to hundreds of members now. Each of them provided some good results. In this case, I'm showing you the improvement from F1 to F2, which the F2 has a sea ice model, also a better ocean model with better resolution. And by including subsurface initialization, we also find that the model has improved predictability not only in the tropical regions but also in the subtropical and higher latitude regions. We have also included some of the other kind of assimilations, like data taken from sea turtles, and it showed some improvement in the prediction, especially in the Arafura Sea. And we are continuing to increase the number of ensemble members because we don't know whether by increasing the members we can improve the predictions. So we attempted to predict with more than 100 ensemble members. And we found that the larger ensemble system is able to predict some of the extreme events better than before. Nevertheless, the improvement is not that remarkable. Just for the deterministic forecast, if you're just taking the ensemble average, maybe the difference is not so big. However, when you go into the probabilistic forecast, like how many times you can predict and the
Good afternoon. Welcome to technical session TS8A of INTROMET 2021 on coastal and marine ecosystems in changing climate. In this session, we have one lead talk by Dr. Smita Bia, Scientist E, Center for Marine Living Resources and Ecology, Kochi. The lead talk is followed by an invited talk by Dr. Justin Centane, Faculty of Science and Natural Resources, University of Malaysia Sabah. After the lead and invited talk, we have 7 short oral presentations. This session is chaired by Dr. Balakrishnan Nair, International Center for Ocean Information Service in INCOIS. Dr. Balakrishnan Nair is Scientist G and Group Director of Operational Ocean Services and Applied Research Group in INCOIS. He holds immense research experience with specialization in ocean nowcasting and forecasting, real-time observation systems, and marine biogeochemistry. He has his expertise in biogeochemical processes in Indian Ocean and innovated for establishing a coastal biogeochemical observation and forecast system. Furthermore, he developed and implemented an operational ocean forecast and information system for India. The lead talk is for 20 minutes with 5 minutes for discussion. Invited talk is for 13 minutes with 2 minutes for discussion, and short oral presentation are for 9 minutes with 1 minute for discussion. We request the speakers to adhere to the time allotted. Now, may I request the honorable chairs to kindly take over the session. Thank you.
Okay. Thank you very much. Roxy also available now. Roxy?
Roxy sir is not available, sir.
Okay. Okay.
He is not attending the conference.
Okay. I think then I have to manage the things. So today we have got 9 presentations. Out of that, 2 are the one lead lead talk, and the other is one invited talk, and there is 7 oral presentations. So this session is very important and very relevant because the coastal and marine ecosystem in changing climate is really affecting the coastal areas. Also, it is affecting the life of many coastal population. And more important is we are going for a blue economic growth. So for that, our coastal areas and sustainable keeping the sustainability of the coastal areas are very important. So all these talks are very relevant to this changing scenario. So let me first call for Dr. Smita for her lead talk. Smita is from CMLRE, and she will be giving a key talk on key drivers that regulate the upper layer production in the northeastern Arabian Sea. So Smita doesn't want much introduction. She is a leading physical oceanographer. I can say that fishery oceanographer, done very remarkable work in the area of fishery oceanography, and she is a very valuable collaborators for many of the services that is actually going from INCOIS. So let me call Dr. Smita for her lead talk. The time I feel it is 15 minutes, correct, Smita?
It's 20 minutes.
Yeah, 20, yeah. Smita, please.
Thank you, Dr. Bala, for a nice introduction. And thank you for the organizers, CUSAT and IMS, for giving such an opportunity. I'm sharing my screen.
Balakrishnan sir, hello.
Yeah. Yes.
Yeah, sir. Roxy is not joined. I think you can manage, right, for the entire session.
Manage.
Yeah, and there are two dropouts. Two dropouts from the list. So Smita Madam can take maybe 5 minutes more. There is no. Yeah. Okay, sir. Thank you.
Okay. One rapporteur for this session.
Yes, sir. I am the rapporteur for this session.
Okay, please take the note.
Hope my presentation is visible.
Smita, please carry on.
Yeah, and I hope this is in screen mode, presentation mode.
Yeah, it is in presentation mode.
Yeah. So very good afternoon to all of you. As introduced, I'm Dr. Smita from Center for Marine Living Resources and Ecology. From the name itself, it is understandable that the mandate with the CMLRE is to address the marine living resources of the oceans from the coastal to the deep and distant water area, starting from physics to chemistry to biology. And our main focus is on linking the environment and the living resources and the resource assessment. Rather than we are looking into the biodiversity aspects also. So more details on the institute is available in www.cmlre.gov.in. And today, the title for my talk is Key Drivers that Regulate the Upper Layer Biological Production in the Northeastern Arabian Sea. So even the main content of the talk is for the Northeastern Arabian Sea. First of all, I would like to introduce what is MLR is or MLRE is, and what is India's stand in that. Sorry. Yeah, and further I will be fine-tuning the discussions on the Northeastern Arabian Sea part with the impact of warming in the chlorophyll variability. So as we know earlier, the ecosystems and all the resources were managed in a silo-structured manner differently. Like as put it in the left hand box, it is species level management was made, very narrow perspective, resource management by sectors, and the scientific monitoring program mainly were focused in single issues, and human interference evaluated for individual activities only. But later, as actually in the introductory remarks itself, Dr. Bala suggested that our resources are very important because our population is increasing. More pressure is on the marine ecosystems. We have a lot of mission programs as part of blue economy, like deep ocean mission, etc. And now we are the dependency on the marine living resources or exclusively on the fishery part. It is fishery also for the other resources. It is on the hike. So worldwide, these issues are being continuing, and scientists from NOVA and certain studies from the ecologists like Long et al. 2015, they have framed a lot of theories and adaptive strategies to make a sustainable management of the resources. So the concept is ecosystem based management strategies, and here it's totally integrated, focused on ecosystem relationships, processes, and trade-offs. Multi-species will be taken care of, and scale is very broad. Integrated resource management, adaptive management based on scientific monitoring, participatory management plans, shared and standardized observations along with purpose observations, and humans are integral to ecosystems.
So in nutshell, we need actually for the sustainable management of the resources, we need continuous monitoring of the system, continuous understanding, our understanding in the oceans to be strengthened. The key indicators of pressure on ecosystems to be identified in terms of forcing or response. And integration means all the relevant aspects like physical, chemical, biological, and ocean atmospheric links, fishery, socioeconomic data, all to be considered in appropriate geographic scales. Also, ecosystem-based research plans, it has to be joined effort with the support of research institutes, a network of research institutes, universities, and stakeholders in various fields. And more importantly, the approach of research, it should be like integration of experimental ecology modeling linked with observation system to support the adaptive approaches for effective and sustainable utilization and management of ecosystem and resources. So in the context, Indian context, we know we have main studies regard to the ocean. I mean, the biological explorations started with IIOE. Before also there were number of studies, but as a mission mode or project-based exploratory survey started with IIOE, then Jacobs in Arabian Sea, then Bay of Bengal process studies, etc. made our understanding quite strong, especially on the physical dynamics, biology, ecology, and interaction within the systems. Later, by the Minister for Sciences, MLR program is implemented through CMLR Kochi. And from 1998 onwards, we have been in the field continuously monitoring the marine ecosystems. And the main mandate is correlate the fishery with its environment, resource assessment, mapping the deep sea demersal. Actually, now also for the commercial aspects, we are exploring up to 100 meters only. So we are seeking the possibilities or trying for the possibilities to go beyond in the deep and in distant waters. Also, vulnerable ecosystems, seamounts, islands, etc. are of importance. Then we have our biodiversity records are continuously being added, and science for the society through MLR technology. So when coming into the subject, we know solar system, solar radiation, then nutrients through mixing river runoff, and then small phytoplankton, then smaller organisms like zooplankton or microzooplankton, then it is taken by fishes, and then higher organisms like mammals, and then its decomposition, detritus matters, again it's feeding by the bottom dwelling organisms like prawns, crabs, or some benthic organisms. So the nutrient cycles and the life cycles in the ocean is keeping on going on, doing having a main role in carbon sequestration, etc. And we have a well-defined food web system in the land terrigenous ecosystem. So here in the ocean, the classical food web is starting from the base of the food web is phytoplankton. Most of you all will be knowing. Then zooplankton. Then it is going to fish. The energy transfer flow is like this. But when actually the dissolved organic carbon decomposition is happening, there is bacteria abundance, then flagellates, ciliates, and then it is again supported to the zooplankton community and then to fish. So there are two types of classical and microbial food web within the system. All these are the basic concept when we take up surveys and the ecosystem regular observations in the Indian waters. So the photo shown here is Sagar Sampada, FORV Sagar Sampada. It's a unique facility of the country, which is which can be like fishery observations and oceanographic observations can be done in a single platform. And we have the facilities like CTD, all of us knows, then current profiler, Then primary productivity measurements, zooplankton or plankton collection method facilities like MPN and Bongo like nets. Then fish egg collection facility, KUFES. Then there are mammal watching facility, Big Eye. Then grab dredge for bendy collections. Then we have deep trawl operation facilities. And we have state-of-the-art facilities like scientific echo sounder, sonar, etc. All these actually, the observations, the main studies happening in CMLRE with regard to the MLRE is based on the observations on board FRV Sagar Sampada. Plus, we are extensively using the satellite information and the buoy and Argo profiles, which we are getting from INCOIS and NIOT, our sister institutes. So based on the understanding, actually, all our observations are categorized into, we do seasonal observations, especially in ocean sector, we do like summer monsoon, spring in the monsoon, fall in the monsoon, and winter monsoon. Again, I'm coming to the food web structure. I have shown it before also. So from primary to secondary level, for the resource assessment, we need to know how much energy is transferring from one, or how much carbon is transferring from one level to another level. So all our effort, observational effort, are towards this, for the identification of these trophic level changes, or how much carbon is transferring from one level to the another level, to estimate actually ultimately living resources. Most demanded resource assessment is for the fishery. So being the upper level organism or high trophic level organism, fishery estimation is done basically based on this. And I have already told the approach is ecosystem based. And in all the aspects, we do follow the ecosystem based approach, because the transfer efficiencies varies from system to system, because it has got different processes and chemical and biological responses. So the food web structure and the life diversity and the composition, everything is changing from space, I mean in time and space. So with all the compiling all the information which we have collected so far from 1998, we have redefined the transfer efficiencies. I'm saying redefined because there are conventional available transfer efficiencies based on theoretical knowledge or some experimental studies, that it is 10% or in the higher level 1%. So here we have for each ecosystem, for each season, we have derived the transfer efficiencies, and that is that carbon flow from one level to the other. It is varying from almost 5 to 18.1627. So this is the estimation, actually how much sustainable yield we are having for India to explore. Actually, ICAR, the Agriculture Ministry, is having regular assessment programs. In 10 years, they are assessing the Indian EZ yield, which is sustainable. How much we can explore, or how much we can take from the system, keeping the sustainability of the or sustainably how much we can explore. So we are a part of that assessment group, and the method actually we have implemented is trophodynamic, as I mentioned, using the carbon transfer models. So the total we have done it twice, and in 2009 estimate it is 4.32 million ton, and in 2018 it is 5.12 million ton, and it is well agreeing with the other estimates, and this is well accepted by the ICER also. So for this, other than the Saga Sampada derived in situ datasets, we have used the satellite datasets, aqua modis and bioagro profiles, in situ data available, then model outputs. Many of the satellite datasets validated as much as we can do, and biological information from different sources. So this is actually a product or a reach of MLR, and as I have mentioned, actually the ecosystems are very complex. The changes in the small scale variations in rainfall or wind or the mixing or currents can influence the biology. So further, I am focusing into the northeastern Arabian Sea, which is peculiar. All ecosystems are peculiar, complex, chaotic, but while considering northeastern Arabian Sea, it's an all-time productive season, except during April and May. The upper layer part of the area is productive, and we know actually most of the atmospheric people are familiar with the northeastern winds, and during November to February we are receiving northeasterly winds, bringing cold, dry continental air to the northern Arabian Sea, which results in evaporation and salinity increase, which ultimately results in convective mixing. And there is, as a result, there is a mixing of subsurface layer to the surface. So the nutrient availability would be high during this period, and with the available light, the figure in the left-hand panel shows the satellite imagery showing the chlorophyll, and the green color image. It's not a pond; it's ocean. Actually, it's like we can see like a green mat of bloom, algal bloom. This species is called Noctiluca, and this phenomena is seen every year during this period. So, and one peculiarity of this observation is that this was not that much regular before 2000, or its intensity and spread is increasing as years are going by. And all these scientific explanations so far were explaining this high production during the winter due to the convective mixing happening in the area. That is a completely wind-driven process. But we could see some pockets of production even after the withdrawal of this wind or convective mixing process. That is reflected in the biochemistry or the type of production that is happening. I have told you there are two types of production, new production, simulating the nitrate and major nutrients in the column. And there is regenerated production where bacteria is active in the lobe. So this type of production can be will be indicated in the measurements we do while doing the primary production experiments. So we got indications of new production even after the bloom is, even after the wind is or convective mixing was withdrawn. Then seeing the Sisyphus height anomaly data from the pressure gradient information from the surface, we could find out that there are a lot of cold core eddies present, as I have shown in the right-hand side figure. All the markings are on the eddies. These are recurring eddies happening or observed during October to March. And we have gone into the details of these eddies, confirmed it's a confirmation was done based on Okubo's parameterization. And we could see a lot of cyclonic and anticyclonic eddies present in the region. So to know to explore what is triggering these eddies, we have taken the right-hand side figure, and one circle I have shown is a chlorophyll patch, and that is an eddy area. So we have taken the ship there and have a cross-diagonal transect to see what is happening in the column associated with the eddy and how it is triggered. So the left one is a CTD profile, one is temperature, salinity, and density. So we can see actually cyclonic eddies are often associated with divergence. There will be upliftment or upwelling in the center, and corresponding to that, we can see a upliftment in the temperature profiles and even in the density profiles. And the right hand side is the ADCP current profiler, where we will get 16-meter interval current profiles for the column. This is, I have told you that this is across the diameter of the eddy, and you can see northward currents in the eastern flank, right side, and downward currents, southward currents in the west side, indicating that the flow is cyclonic. And also one more difference is the eastern side is more strong. The currents are well organized and it is more strong, and the western side is little bit weak. And along with the observations, we have taken the biology also. So found that there are like mat-like, I have shown you the photo earlier, a green mat-like phenomena of Noctiluca bloom in the western flank, where the mixing obviously would be less. Available, the eddy kinetic energy is weak, and available potential on energy also is weak. But also, the area was more stable. So in the eastern side, the mixing was more, and there we could see abundance of phytoplankton, but of a different category. Actually, there are two major types of phytoplanktons observed in the ocean. One is diatom type, and the other one is dinoflagellates. So diatom actually consumes, like to thrive in nutrient-rich waters where active pumping is going on, and it also survives in turbulent areas, while the other one, Noctiluca, is a little bit like it is larger in size. It has a buoyancy control to maintain in the surface, even actually only during stable stratified conditions. So during stable stratified conditions, it will form as a mat-like harmful algal bloom. And these observations, from these observations, we could reach to the we have concluded that the biological implications, actually the wind is not having any role in triggering the these disturbances here. Wind stress curl is giving negative values for the region. So the baroclinic instability in the column is a factor to trigger such a eddy-like feature. And this was evident in a smaller Rossby radius of deformation rather than the lesser to the diameter of the eddy. Also, we could see that the cold core eddy regions column productivity was multiple times higher than normal area, where only convective mixing activity was persistent. Then actually extensive blooms of Noctiluca, like green Noctiluca, contributed to the cell density in the periphery. I have seen the figure. Periphery means where the water column was stable and the current was comparatively weak. And also active mixing is associated with the, actually well-mixed area was associated with diatoms, which was supported by the new nutrients available due to the mixing, and Noctiluca mostly was supported with the regenerated production. And after this, actually, after the convective mixing, then eddy pumping activities, by March, it will get, all this forcing will get weaker. The area would be more calm. Then there is another fellow, like Trichodesmium. It's a nitrogen fixing organism. It's all again a phytoplankton, but it can fix nitrogen from atmosphere, and it actually it can survive in even nutrient-less waters, but it should be warm, abundant sunlight should be available, and stratified. So after the
another 3
huh?
minutes. Another
Okay.
3 minutes.
Okay, thank you. So after this trichodesmium gets abundance in the region, and it flows towards southeastern Arabian Sea. So this is in nutshell what I have explained till now. The northeastern Arabian Sea, we know, like Arabian Sea high saline water is formed there, then Persian Gulf water, then there is OMZ happening. So during the active phase or the initial phase, nitrates will be more, but then during the peak phase, there will be little bit ammonia concentration will be more because of the microbial activity. And eddies and mixer layer thinning will be happening during the late phase of the bloom. So when we speak regarding, when we see regarding the climate change impact, we know like in ocean, circulation patterns, stratification, convective mixing, sea level, etc. changes in regard to the changes in temperature, salinity, etc. And in biology, the production pattern, HAPs, and microbial loop and reproductive cycles will impact due to this. So this is one of the observation we have seen when we took the long-term data. The bloom formation, it is getting earlier. One thing is that it was not so intense before 200, and now the second observation is that it is actually the onset is little early. Earlier it was observed during March only, February and March. Now it is getting earlier, by February mid also we are getting, and actually the sea level rise is observed in the area. So a clear evidence of warming and stratification and hike in the primary production during the season. So these are the tasks we are ahead with us when we consider this ecosystem, impact of the bloom and change in production pattern in the fishery. We haven't attempted what is the fishery and its impact in that area, and the impact in the biochemistry and greenhouse gas emissions to be addressed in detail. Then predictive capability of the bloom formation and spread to be developed. Then we have a lot of models actually from IITM also we have collaboration, and successfully they have fine-tuned the processes there, biochemistry there. But still more improvement is needed for capturing this fine scale minute details where the carbon contribution or ecosystem dynamics is making into more complex or more chaotic. Thank you.
Thank you, Smita, for a very nice presentation. So I really enjoyed the presentation, and it was a lot of work you have done actually to making not just understanding, but this understanding to use for our enhance our predictive capability of many of the biogeochemical process and the fisheries, especially the harmful algal blooms, and then the fisheries. So any questions to Smita? I couldn't see any question in the chat box, but audience have any questions, please. Yeah.
So there are no questions from the audience.
Some problem. Yeah. Smita, I have a question. Mainly, you are telling about the harmful algal blooms and it's a triggering mechanisms. So we also have similar studies actually conducted, me and late Dr. Satya Prakash. So we also publish in that thing.
So, according to you, is it actually possible to predict this thing, the harmful algal blooms in Arabian Sea or Bengal, using some of the indicative parameters, for example, nutrients or the oxygen content?
Actually, we can, but I will not say like we can have it a uniform prediction system for the Arabian Sea and Bay of Bengal. We have to treat the two systems separately because two entities, as you know, and the processes or dynamics that is triggering the bloom in the northeastern Arabian Sea is entirely different. And um, it's when we see the chaos, actually one of my student is working on it. It's really chaotic, the prediction is. And one key element or key parameter which we have identified is actually there is a fluid dynamics part in it. So the organism to bloom, it has to be and to stay it there as a mat like or in a stable condition. It has to the buoyancy control is the main factor. So the density of the water column is density as it's not as such density gradient is one of the main factor which we can use as a key controlling factor. That is what we have identified recently. And plus there are a lot of things. Temperature, of course, is an identification. Then chlorophyll variability, that also is there. And there are few like interesting observations we can see in the interaction between surface and subsurface also. So there are quite a lot of interesting things which we can use as used to predict the system. But lot of detailing is needed on that.
Okay. Yeah. One more question I have. So you are talking about the transfer efficiencies. So
Yeah.
this transfer efficiencies actually can the change because of the changing the sea conditions, the climate change, temperature, or that kind of things. And there is an other area there is an overfishing also. So what is your projection on the change in this transfer efficiencies and its effect on fisheries?
Actually, this method is completely fishery independent. We are not considering fishery at all. Rather, for validation in the second exercise, we have taken actually a back calculation also was done, taking the fishery. But the trophodynamic approach is mainly fishery independent. We have considered only the primary consumers, secondary consumers, and using the conceptual model, we have reached to the fishery. So fishery is not coming into factor as a factor there.
Thank you, Smita.
Thank you, Samit.
Thank you.
Thank you, Dr. Abhilash too, and all the organizers for a nice time. Thank you.
Now we'll go to the next invited talk by Dr. Justin Sentian. He's from University of Malaysia, Sabah, and he'll be talking on future projection of surface temperature and total precipitation over Southeast Asia under climate change scenario. Dr. Justin Sentian, please.
Yeah, thank you. Can you hear me? Thank you, Dr. Balan. You're chairing this afternoon sessions. Can you hear me now?
Yeah, I can hear you.
That's great. And first and foremost, yeah, Justin here from University Malaysia Sabah, Malaysia, and I'm very much thanks to the INTROMET-2021 for inviting me to share some of our works that related to climate change. And one thing that I really noticed this afternoon is that looking at the issue in coastal and marine ecosystem that has just presented. And I think this is also very much relevant to Southeast Asia, not just probably in Indian coastal region, but I think it's go beyond. And today I give you a snapshot of a number of work that we are doing. I just select a few modeling results that we have done related to the climate change in this region. Yeah, so let me share with you the my screen and hope that should be fine. I think still somebody are still sharing the screen. I am unable to share. Is that
yeah, I think nobody's sharing.
Nobody's okay. Let me try again. Yeah. Okay, now I can share now. Yes. Can you see this screen now?
Yeah, you can
Okay.
see. Please make it screen mode.
Yeah.
Screen
Can you see?
mode. Yeah,
Can you see that? Oh,
yes,
okay, that's good.
Perfect.
Right. Because the time's limitations. Yeah, I'm going to give a snapshot of what we are doing here. Some of our work that's related to climate change in this region. I'm referring to surface temperature and the total precipitations for now. And this is the regions, the domain of the study area for the investigations that covering mostly in the continental Southeast Asia, as well as the insular region or the maritime continental, region, which is a lot of islands in here. And I think this is where the coastal environment, the marine environment is very important. Now, as reported officially or in a lot of papers have been saying, yeah, that Southeast Asia is one of the world's most vulnerable region due to climate change. Yeah, and also it's been observed that this region has the biggest jump in terms of greenhouse gas emission from various sectors. And again, if you're looking at Southeast Asia's map, it's there's some thousands of small islands, and it has a long coastline, and most of the populations are mostly residing at the coastal area. Yeah, in Indonesia, Vietnam, Thailand, Philippines, and even Malaysia. Yeah, and because of this, any eventualities of future extreme climate in the future, it will be a big disaster for this region. And one of the important thing is the sea level rise. But of course, today I'm not going to present the sea level rise impact due to the climate change. But this is the consequences of the climate change. And based on the Paris Agreement, the revisions of that, 1.5 degrees Celsius that we need to achieve. And it actually shows that this particular region is also quite interesting to observe, which I'm going to show you in a while. Now, I think one point that I would like to show before I'm going into the point is that some studies actually shown that in the last 20 years or so, some countries in this region are actually already experiencing a number of climate-related anomaly or something like extreme conditions. So even under this ASEAN Development Bank report, that this region could have a shift in terms of weather or climate. There is a new climate regime. For example, that the coolest month, which is during the winter monsoon, like December, January, or February, it's going to be warmer. And the warmer, which is June, July, August, is going to be the hottest, something like that. And in the past, Singapore has been saying that the 80% has been warmer, and even the rising of sea level rise is also affecting a number of coastal region, especially in Indochina, like Vietnam. Yeah, right. And under this modeling result, the simulations Codex Southeast Asia projected that this region will reach the 1.5 threshold even as early as this year, or even up to 2050 under RCP 4.5. Under the business as usual scenario like RCP 8.5, is going to be even already been achieved or reached in the last 5 years and until 2040. Yeah, same thing with the total precipitations too. Yeah, so what is this information are saying is that actually we're already experiencing this change of climate, and that's why I think that's the reason why these regions are considered as one of the most vulnerable region in the planet. Now, this one is a result from some other studies, but just a quick one. Yeah, just showing you the 1.5 degrees Celsius on the right side here. And the bottom here is 2 degrees Celsius. This global warming limit by the Paris Agreement. So you will see that most of the region is actually warming. Yeah, with a 95% confidence level. Yeah, so it's not a surprise that from our result that I'm going to show you later is also showing almost similar with the precipitation as well. Yeah. Now, a quick one that because of the time limitations, I'll show you some of the results that we have for the climate change projections that we have using WRF model. Yeah, for the 3 scenarios, RCP 4.5, 6, and 8.5. Now, and we use the present day like 2013 because that's the what we call it neutral year. Yeah, we didn't really have the extreme like El Nino or things like that. Yeah. Now, just a quick, this is the baseline, yeah, that we are referring to for the whole year. So this is the map of Southeast Asia that actually you can actually more or less like split that into 2 regions. Most of the warmer, especially in the Western Pacific or even in the Southern Indian Oceans, yeah, mostly Indonesia are warmer. Yeah, and this is a lot of islands over here. Yeah, and we are going to use this as a comparison with what we are projecting for the future for the 3 scenario. Now, this one is 2013 and this one is 2030. So, well, the color, it doesn't really show you much, but just look at the dotted line that I just uploaded here. So it's almost showing that it's shifting to the north. Yeah, that means the area is going to be warmer, it's going to be larger relatively. And the one that I highlighted with a white color here is showing you that it's actually exceeded like more than 30 degrees Celsius, more like that. Yeah, you can see that one is the RCP 4.5, 6, and 8.5. 8.5 is a worst scenario with a lot of greenhouse gases, for example. So you're expecting that it's going to be a larger area of Southeast Asia to be warmer. And beyond 2050, even larger area that is going to be hotter or warmer. Yeah, and mostly in a sea. And this one is going to be affecting the what do you call it? Small island, especially in Indonesian region here. Borneo is here, Sumatra and Peninsula Malaysia. But look at this, the most beyond at the end of this century, 2000. Even the warmer area is going to be larger with a larger magnitude value here. And what we are concerned, I mean, if you're talking about the coastal just now and the marine ecosystem, what if you couple this one with the El Nino phenomenon? That it's going to be much, the impact of this region is going to be much critical for this region. Yeah, for the aquatic life, the marine life, for the coral reef, and all sorts of things, the marine productivity. And that is interesting for us to go to investigate it further. Right, that's surface temperature. I mean, this is a summary of the temperatures of change. The red color here is a change. The blue one is just like there is a decrease in terms of temperature. But in general, from 2013, the present day, to 2100, you will see that the temperature average, monthly average, is as high as 2.5 degrees Celsius, and that's beyond the Paris Agreement of 2. Yeah, or even 1.5. Yeah. Now, a quick one on the precipitation. Yeah, this one is the present day. Yeah, so most of the in this one's not well. Most of the precipitations are also in the insular region or in the maritime here. It's a sporadic. Yeah, that's why this precipitations, total precipitation, actually there's huge variability actually. Yeah, huge. We didn't really see a good patterns like the temperature, but it's a huge variability. In 2030, you will see this increase of precipitations over this particular region, and you will see that there's a lot of rain, and it could be associated with tropical storm and other things in the Western Pacific, closer to the Philippines, for example. And this is the area that we're expecting a lot of rain, and you know the consequences of a lot of precipitations is the flooding, which is actually a problem in many parts of this region, including Malaysia, Indonesia, and even in Indochina at certain months. Yeah, and well, you can see that even the RCP 4.5 and 8.5 in between, yeah, there's a lot of a huge variability. You don't really see a increasing trend. Yeah, but this is the problem. I mean, this is quite difficulties of what I can estimate. I mean, forecasting, simulating of precipitations, and this is going to be a real problem. And looking at 2050, you will see the same, like in the island, in the maritime environment here, you will expecting a lot of rain here compared to those in the continental region. And this is also, when you're talking about La Nina, for example, then it's going to be another couple of problem too in this region when it's happened. Now, this one is at the end of the century. If you're talking about probably about 80 years from now, so you will see almost the same pattern. It's just that looking at the magnitude is even larger here, even up to 520 millimeter per day, and that is quite. And the spatial distribution is also enlarging. Yeah, we're expecting a lot of rain, and it's going to be a problem. So many consequences to this one: flooding, and soil erosions, water qualities, and of course, not forgetting the other type of disaster, especially in the lowland area. Right, and to the summary of the precipitation, and I think this is my last slide. Yeah, if there is anyone interested to ask, then you have plenty of time to ask after this. But if you're looking at the range of change of total precipitation in this region, there is a huge variations of precipitation, as I mentioned earlier on. So this is the one of the indicating that precipitation is really challenging issue in this particular region, and dealing with it is something that the government of each country in this region is really need to look at, yeah, to reduce the greenhouse emissions, to curb the climate change, for example. Right, and as a conclusion, so I would say a summary like here, it is expected, like the other models that we have run and other study, yeah, climate Southeast Asia is indeed we are expecting to have a warming atmosphere at the end of this century, and a significant variation of precipitation pattern. Yeah, that's what we that's what I have shown you. And on top of that one, from our other study that we have done, there is also a severe weather events like flooding and sea level rise in some areas in Southeast Asia. And certainly these changes, whatever the magnitude is, it will be negatively affect the various facets of ecological and economic system of this region, the highly populated region. And this one is what ASEAN Development Bank forecasted about the impact of that climate change. It's going to be a huge impact on the economic, and it's endangering the livelihood of the millions of people in this region. And towards the end, by understanding the more like consensus forecast simulations of climate change in this region, as I said, each country has, should show a concrete response to this the alarming consequences of the climate change, and that's include a pragmatic decisions on their climate change policy, of course. And I think all countries are doing that, but what we are looking at is the real implementation of that, and of course the technology options that can be applied in those affected areas. Of course, the financial innovations and the public awareness are still relevant to mitigate the greenhouse gas emissions. And those who are affected in other regions, how are we going to adapt with this future climate change? With that, Mr. Chairman, Dr. Bala, I would like to thanks again for giving me an opportunity to give me a slot of a very short presentations on Southeast Asia and the climate change scenario for your information and for the audience knowledge. Thank you very much.
Thank you, Professor, for an excellent presentation. So it is also very much important to be viewed by our policy makers, because it has got a lot of implication about the preparing our coastal areas for the coastal areas and as such the country itself for the climate change scenarios. So is any questions to Professor? I couldn't see anything in the chat box also. I have a question. See, you are telling about different the RCP scenarios for 0.5 to 8.5. So for the policy maker, the precipitation change, which scenario you will be recommending, I think, to take a kind of action?
Right. That's the scenario that the, what we call it, let's say we put on the table on the policymakers, and we give them the, the most likely, the lowest scenario, like the impact is not that much. But what I'm thinking people are interested is in case it's a very extreme scenario, then people go for the worst case scenario like RCP 8.5, and then that will be a point to start off, I think. I mean, for my personal thing, I think they should look for the worst scenario to cover the whole other scenario.
Yeah, I think I understand, but one or two lectures what I have seen day for yesterday, one of the plenary talk, they are telling it is better not to go for the 8.5 scenario, which is the worst scenario, because the investment on the preparedness will be much higher. But of course, this is actually
exactly.
Yeah,
that's why I think the interesting of why the IPCC give you a scenario is that, okay, the government, you have this even now there's more scenario in upcoming 6th assessment report of the IPCC. I put you on the table with all the detailed assessment for each of that one. You just make your mind, which one do you want? Okay. Yeah. So, but I think what I mean, I think that's the best thing that we can do, because we are not really sure what is actually happening in the future.
Okay.
Per se, yeah.
Yeah. There is one more layman question. I think, see, you are told about this different the rainfall scenarios. So the extremes, according to your projections, the extremes are going to increase in the southwest monsoon time or northeast monsoon time?
Yes, the one that actually, yes, the one that you're right. Which I haven't shown it here, but that is the average of the monthly variations. But during the we call it winter monsoon, or which is actually a wet season here, something like in November, December, or January. That is during the northeast monsoon. I mean, in this particular region, and that is where you have the more or less like very highly varied precipitation, and most of that is in the insular region, or in the what I call it, on the Indonesian side, things like in the island, in the maritime environment. Yeah, so yeah, that's what from one observation that we are noting. Yeah.
Okay. Thank you, Professor. Thank you very much.
Yeah, thank you, Dr. Bala, and thank you everyone for watching. Thank you for listening too.
Yeah. I think we'll go to the next presentation by Dr. Joshi K. from Utkal University. He will be presenting on monitoring of Gulf of Kutch coastal zone with a reference to land use, land cover changes using geospatial technology. Over to Dr. Joshi, please.
Hello, good afternoon, all of you. May I audible to everyone?
Yeah, you are audible. You can share your presentation.
Yeah. Is it visible to all?
It's visible. Can you make it in full screen mode?
Yes. Okay, now may I start?
Yeah, proceed, please.
Yeah, myself, good afternoon, all of you. Myself, Dr. Kajal Joshi. I'm working as a postdoctoral fellow at Center of Environment, Climate Change and Public Health, Utkal University. Today, I'm going to present my research work on monitoring of Gulf of Kutch coastal zone with a reference to land use, land cover change using geospatial technologies. Human activities bring the change in the land use, which affects all the component of the environment. And the land use, land cover change is a very important factor. And to understand the relation between the human activities and the environment, generally, the development of any region is dependent on the urbanization and industrialization, but sometimes the development shows the adverse impact on the environment, resulting in loss of biological wealth and of the ecosystem. Coastal zones are very high biological productive regions and important component of a global ecosystem. Gulf of Kutch, Gujarat is under increasing anthropogenic stress due to the industrialization and urbanization in last 25 years. So there is an urgent need to evaluate land use, land cover changes to develop efficient coastal zone management strategies. Accurate assessment of coastal land use, land cover changes will help in framing better management strategies for future. And remote sensing and GIS is a very effective tool for analysis of land use, land cover change at the regional level, and satellite data provides an synoptic view of the coastal zones. The main objective of my study is to measure and analyze land use, land cover change process along the coast of Gulf of Kutch using remote sensing technique. The study area I have selected is the area of interest is in the Gulf of Kutch area, 20 kilometers from the coastline to the land side and up to the mangrove plantation in sea water I have selected. And this Gulf of southern part of this Gulf of Kutch area is the Saurashtra region or Kathiawar region. It is rich in mangroves and coral reef. The Marine National Park Jamnagar is there, and at the northern part there is Kutch district of Gujarat, and there are mangrove habitat at certain locations are there. Coral reef are not there, and west side it opens to the Arabian Sea. General methodology I have followed is first of all I have collected the data, satellite data as well as the ancillary data. This satellite data I have collected least 3 data and pre-processed that data by image stacking, image mosaicing, and image subsetting. Then after I classified that data using the supervised classification method. In that maximum likelihood classifier I have applied, and then ground truth and accuracy assessment I have done, and at last the final land use land cover map of the study area were prepared. And for the last 25 years, at the gap period of 5 years, I have taken the images, and land use land cover map I have prepared for all the years, and then after I have done the chain detection. For these tools and techniques, I have applied remote sensing and GIS, and softwares I have used ADAS and ArcGIS. I have used the images for 1997, 2002, 2007, 2012, 2016, and 21. So in past 25 years, I have used the data at the gap period of 5 years. And for 1997, 2002, and 2007, I have used the data of IRS-1C, and 2012, 16, and 21. Resource set 2 data, least 3 data I have used, and the spatial resolution of this data is 23.5 meter. And I have acquired this data from the NRSC. The image pre-processing steps I have applied layer stack by the image stacking, then image mosaicing, and the area of interest clip by the image subsetting, and the false color composition I have. Then as per the NNRMS standards, I have classified these all images in 9 particular classes: agriculture land, built-up area, industries, mangrove, mining area, mud flats, salt pan, wasteland, and water bodies. These are the chain detection steps I have followed. First of all, development of classification scheme, then signature creation, then a supervised classification. In this maximum likelihood classification algorithm I have applied. And then I have done the accuracy assessment. In that, user's accuracy and producer's accuracy I have calculated. And depending on these 2, overall accuracy I have calculated, and kappa coefficient also measured. And then after post classification, chain matrix I have done. This is the false color composition of the study area. This is the land use identification by the visual interpretation. Here we can see that in 2000, this is the agriculture land, and in 2006, here the industry developed. Here the industry is already present, but it expand, and this area is near to Jamnagar area. This is here we can see the at the this mud flats are converted to port. This area is Mundra, and it is in Kutch district. In 2000 and 2013, here we can see that salt pan that increases. From 2000 to 2013, this area is in Kutch district, Pandro region. This is the barren land, and it's converted to mining area, lignite mining area. Here we can see the mud flats are converted to the mangroves. So from 2000 to 2013, here this area is near to Maria and Jodia Taluka of Jamnagar district. Here we can see this city area in 2000 is the city expand. In 2013, this is the Jamnagar city. Here from 2000 to 2013, we can see the salt pan increases, and here the mud flats converted to the industries. So these are few just images, and here I pointed out on the map locations with major changes in land use land cover. The green points are showing that changes from 1997 to 2007, and blue color shows the changes from the 2007 to 2021. This is the supervised classification of the study area of the image 1997. I have classified it in 9 classes. Here blue color, pink color shows the built-up area brown color industries, green color mangroves likewise. This is the supervised classification of the study area for the year 2002. This is for 2007, 2012, 2016, and 2021. Here we can see that this in classified image, near the Jamnagar area, agricultural land is converted to industries. This is near to Mundra port. So this water bodies is converted to the industry port. Salt pan increases here. Mud flats are converted to salt pan. This is the mining area.
I have another 3 minutes for you.
Okay, okay, sir. This is the lignite mining area. This open land is converted to lignite mining area at Pandro region. Here the mud flats converted to mangroves. This is the built up area, this increase, and salt pan here increases. And this is the industries, port developed. So for this all images, I have, after the supervised classification, I have done the accuracy assessment. In this producer's accuracy and user's accuracy, both I have calculated, and error of omission and error of commission. And depending on this all accuracies, I have calculated the overall accuracy and kappa coefficient for all the images. And then after post classification, classification change statistics were done. I have calculated the area for each class for each particular year from 1997 to 2021. And then after I have calculated the change in hectare in each particular class from 1997 to 2002, likewise at the interval of each 5 years. And then at last change in hectare from 1997 to 2021. Here we can see that agriculture land, the area, agriculture land, mud flats, water bodies and wasteland, they decreases, but the area of built up area, industries, mangrove, mining and the salt pan, they increases from the last 25 years. Here we can see that mangroves, they decreased from 1997 to 2002 because of the development of the industries. They started to cut down the mangroves, but after that, after some time, because of the plantation of the mangrove, industries and people and government also, they do the plantation, and for that reason mangrove total cover area increases. This is the land use land cover change from 1997 to 2021 in the study area. And
try to conclude.
Yes, sir. This I think last slide. Agricultural land, mudflat and water bodies, they decreased, and mangrove, salt pan, built up area, industries and mining, they increased. And salt pan and mangroves were increased at the place of mudflat, and as a result of port activity, mudflats were decreased, and it may affect to the marine fauna and the dependent organism. And agricultural land were reduced because of the industrialization and rapid human settlement. This may cause the adverse effect to the associated environment. Therefore, an effective sustainable land management policies and practices are required to avoid the endangering of the environment and maintain the sustainable development. Thank you, sir.
Thank you for a good presentation. So any questions to Dr. Joshi? Thank you, Dr. Joshi. Thank you very much.
Thank you, sir.
Please unshare your presentation.
Yes.
We will go to the next presentation by Dr. Sudeep Kumar Kundu from NIAS, Bangalore. He will be presenting on investigating the role of marine fishery advisories in the reduction of carbon dioxide under varying climatic change scenario for the Bay of Bengal. Dr. Sudeep Kumar Kundu, please.
Hello everyone. I am Sudeep Kumar Kundu. I am from National Institute of Advanced Studies, Bangalore. Today I am going to present the role of marine fishery advisories in the reduction of anthropogenic carbon dioxide emissions on the Bay of Bengal. In case of marine ecosystem services, the total value of this marine ecosystem services in India, it is about 1.5 trillion rupees. But it is well known that the global warming due to the anthropogenic greenhouse gases such as carbon dioxide, it impacts the marine environment by the sea level rise and natural flooding, all these things. And 1/4 of the total anthropogenic CO2 emissions that has been emitted from the transportational as well as industrial sectors from the industrial evolution since. However, the less attention has been paid in the diesel-based marine fishing craft, especially the mechanized crafts. But without the known and the predicted location of the fish accumulation zones in the open sea, it takes the lengthy search time, hence the more diesel consumption and henceforth the more CO2 emissions. In this context, the potential fishing zone advisories that's provided by the Indian National Center for Ocean Information Services in India is very useful in order to locate fish shoals in very short time. The main goal is in the coming decades, like 2030 targets, by the intended nationally determined contribution is increase the share of non-fossil fuels as per the capacity set. So it is projected that the total carbon emissions by 2030 it will be 1 billion tons by this INDC, and it should reduce the carbon intensity by 45% by 2030. The previously target was 33% set in 2016. This 2015 and 2030 goals with the reference to marine ecosystem services need to be managed in the correct context. And by the 2017, the net zero emission should be promised. This is the overview of the marine fishery in case of India. India has more than 2 million square kilometers of exclusive economic zones across its 9 maritime states and 4 union territories. And presently, as per the present global scenario, India stands 6th largest marine fish production, and it has more than 1,537 marine fish landing centers across more than 8,000 kilometer long coastline. And significant foreign exchange earnings from this fishery export, which is 10% of the overall export and nearly 20% of the total agricultural export. And presently in the year 2019-20, fishery sector also accounted 1.24% of the total gross domestic product and 7.28% of the agricultural sector GDP. And in case of Odisha, total number of marine fishing community is about 5 lakhs. The marine fishery advisory is potential fishing zone. Potential fishing zone is a reliable and short-term forecast on the fish aggregation zones in the open sea. To prepare the potential fishing zone advisories, the basic inputs are the chlorophyll concentration and the sea surface temperature. These advisories potential fishing zone and these basic inputs like chlorophyll and sea surface temperature are being taken from the IRSP for OCM, MODIS aqua data, and the thermal infrared channels of NOAA AVHRR over the Arabian Sea as well as Bay of Bengal. Now, INCOIS provided this potential fishing zone advisories to all the 9 maritime states and 4 union territories at daily basis, except these extreme weather conditions. This identification of these potential fishing zone advisories, it improves the catch per unit effort, that means the total catch sizes, and also reduce the fuel consumption by minimizing the searching time. This is the PFG advisory services lab to land. The left-hand side image, it shows the raw data of sea surface temperature and chlorophyll concentration over the Indian region. And the middle side, this is the key indicators of this SST and chlorophyll concentration. And right-hand image, it shows, it is one of the potential fishing zone map for the Odisha. Is dated 22nd September 2019. And this red box, within the red box, this black color line, it shows the potential fishing zone advisories. And this is valid for 1 day from this particular date. Now coming to the benefit of this potential fishing zone advisories for the marine environment. It has been it has been assessed that the low search time for using, but due to the usages of this potential fishing zone advisory, it reduced the diesel consumption. Due to the reduction in the diesel consumption, it minimized the carbon dioxide emissions. The survey, which made by National Council of Applied Economic Research, it has been predicted that 1 liter saving in the diesel consumption can reduce the 2.63 kilograms of CO2 emissions that can positively impact the marine environment. In this context, India's CO2 emissions for the year 2012, it is like more likely 1.97 billion tons, which is 5.7% share of the global annual emissions. And the per capita consumption emissions for CO2 is 1.6 tons per person as per the 2012 data. But it is but the data related to the coastal and marine ecosystems related to the CO2 emission for India yet not fully investigated or represented. Using this current SIMI-5 models, we are going to compare the anthropogenic CO2 emission data over the Bay of Bengal under two scenarios, which is RCP 4.5, moderate emissions with mitigation policies. This is the most probable baseline scenario. The restrict to the temperature, rising temperature by 2 degrees Celsius, and the worst scenario, which is RCP 8.5, this high emission and absence of coherent management. Under this scenario, the global temperature can rise up to 2.6 degrees Celsius. Here we considered the decade-wise and year-wise, the last decade and the current decade, as well as the last year 2020 and the current year we consider to show the anthropogenic CO2 emissions. This is the last decade. The left-hand side image, it shows the CO2 emissions in ppmb under RCP 4.85 scenarios, and the right-hand side image, it shows the CO2 emissions in ppmb under RCP 8.5. In case of RCP 4.5,
you have got 3 minutes now.
Okay, sir. In case of RCP 4.5, there is very negligible changes is observed. However, in case of RCP 8.5, the changes is more. The same scenario also we found in case of 2020, the last year 2020. Here in case of RCP 4.5, very less changes observed. In case of RCP 8.5, the changes are very significant. In case of the current year 2021, this is also the same thing we found, that under RCP 4.5, the changes is very insignificant, which is means 0.001 changes we found. And in case of RCP 4.5, the changes is mostly 7 ppmb. In case of the current decade, which is 2021 to 2030, that is also we found a similar situation where the emissions is insignificant in case of RCP 4.5, but in case of RCP 8.5, changes are very high, mostly higher, which is 446 to 453 is ppmb range. So coming to the conclusion, we found that this anthropogenic CO2 emission is projected to be higher under the RCP 8.5 scenario, but the present scenario for the fishing operation need to be assessed in details in the contribution to the emissions. In case of how many more specifically for the mechanized traps, which needs the lengthier trips operated in the Bay of Bengal, which can result in the more CO2 emissions. But under the usages of these PFG advisories, which significantly reduce the searching time, hence for the lengthier trip can be reduced, and henceforth this fuel consumption can be reduced. That's why we can say that the CO2 emissions will also be reduced under if the PFG advisories can be utilized and can be implemented successfully. So it is very important to properly use these PFG advisories across all fish landing centers in the India for the reduction of these CO2 emissions in the current or future decades. So it is needed to make the proper policy frameworks which can be available to each all the fish landing centers in India. And thank you so much. I wish to thank Dr. Bala for chairing this session, and also on behalf of my co-author, supervisor, Dr. Harini Santana, who is also present here, we want to thank to the Intromet organizers for providing us such an opportunity to present this work. And thank you so much.
Thank you very much, Sandeep. It was a very relevant presentation because we know that there is a lot of reduction in the carbon dioxide due to our PFZ advisories. So, what is actually your suggestion for the future? Because I'm not sure that whether when you are making these projections, whether you are included the number of crabs, increase in the number of crabs in future.
Sir, actually, we just got this kind of idea that we came to know from the different literature survey as well as when we also went to the field that reduction of CO2 that can affect the marine environment in very positive way. So now we have started projections based scenarios, but we are also looking forward this total number of crabs which can be operated from the coast, from the fish landing center to the ocean, how much time they can sustain in the oceans, and how much fuel can be saved from the PFG advisories, and that we are looking for, and we are on the way to look this. So I think it will take a little bit time, and we are also on the way to do that from our field data. How much means if there is a higher number of mechanized crabs operated in the Bay of Bengal, and then how much time should or how much fuel consumption should be reduced to for the positive impact on the ocean.
Okay. Okay. Thank you, Sandeep. Thank you. Thank you very much.
Thank you so much, sir.
We'll go to next presentation by Dr. Lindsay Davies from KU Thrissur, and the presentation on assessing above ground carbon sequestration potential of coconut plantation at CRS Aliya Nagar in Coimbatore. Dr. Lindsay, please.
Hello, sir. Good afternoon.
Good afternoon.
Am I audible, sir?
Yes, you are.
Am
audible.
I audible, sir?
Yeah, you are.
Let
audible.
me share the screen.
Yeah, you can share the screen, but I think your video has some problem, light problem. Yeah, please make it a full screen mode. Yeah, proceed, please.
Good afternoon to everybody. Today, I am going to present a topic assessing above ground carbon sequestration potential of coconut plantation at the Coconut Research Station, Aliya Nagar in Coimbatore. And Dr. Paneerselvam, Dr. Subramanian, Dr. Balaji Kannan, Dr. Maheshwarappa, and Dr. Shobha ma'am were the co-workers of this research project. And here, there are different types of carbon sequestration techniques. Abiotic sequestration, under that oceanic injection, geological injection comes under that, and biotic sequestration like oceanic sequestration and terrestrial sequestration, and secondary carbonate deposition. So in this, I'm concentrating on terrestrial sequestration, biotic sequestration by terrestrial sequestration method. So in this terrestrial sequestration, above ground and below ground carbon sequestration are included. Example is forest ecosystem. Coconut is a perennial tree with a woody strong stem like forest trees, having lifespan of 50 to 60 years and have potential to sequester atmospheric carbon dioxide into plant and soil carbon. Coconut plantations are capable for regulating atmospheric carbon by storing as above and below ground biomass for a longer period of time and also as lignin content in their stem. They can reduce global warming to some extent and thereby extreme weather events. So in this background, I have made a survey for finding the area of coconut plantation. So India stands third in coconut area, that is after Indonesia and Philippines, and Tamil Nadu stands third after Kerala and Karnataka on all India basis, and Coimbatore stands first in Tamil Nadu in area as well as production. So you can see the area and productivity of coconut in Tamil Nadu here. So in this, Coimbatore stands first. So that's why I have taken study in Coimbatore area. And the objective of the study is to assess above ground carbon sequestration potential of coconut plantation with a different type, age, and management. So the experimental location taken is Coconut Research Station, Aliyar Nagar, Pollachi. And this is the Aliyar Nagar station, Coconut Research Station situated in Coimbatore, Pollachi area in Aliyar Nagar is a location. And this is the Meteorological Observatory situated in this particular research station. And these are the coconut gardens are there. And data required for this study is meteorological data, which was collected from this observatory, and phenological data was collected from the field. And details of field experiment, the location is Yaras Aliyar Nagar, and the design chosen is completely randomized design. And I have taken different categories of age group of coconut farms, that is below 10 year, above 10 year age group of coconut plantations were selected. In Ciaras Aliyar Nagar, I got 6-year coconut plantation, a 12-year coconut plantation, and 18-year-old coconut plantations. And 6 treatments were laid out. From each treatment, 5 palms were taken for observation, selected for observation. So there are 2 types of varieties I have chosen, that is tall, that is West Coast tall, and dwarf, that is Chaukat orange dwarf. These are the 2 types of coconut plantation, and I want to study how these 2 types of coconut plantation sequester carbon and carbon dioxide in different stage. So these are the treatments. Details of treatments followed in the experiment are 6 treatments were laid out. First treatment, dwarf type, 6 years, 5 trees were selected. Like that, 12 years, 5 trees, and tall type. Like that, this is the treatment selected from conventionally cultivated plantation. And I got one organic plot that is about 18 years, around 18 years old, and 5 trees were selected. And control plot where an open area without coconut trees was selected as control plot. And observations taken during the 4 seasons, southwest monsoon, northeast monsoon, winter, and summer. 4 observations were taken. 4 times observations were taken. And this is the weather prevailed in Ciaras, Aliyar Nagar, Pollachi, Coimbatore from 2016 to 17 during the experimentation period. This is the field of conventionally managed plantation. This is a treatment 1, where dwarf variety of 6 years old is selected here. And treatment 2, dwarf type of coconut plantation of 12 years was selected. And treatment 3, that is West Coast tall, 6 years plot were selected. Treatment 4, West Coast tall, 12 years age group coconut plantation was selected. Then this is the organically managed plot I got around 18 years old. They have used purely organic management is carried out. No chemicals were applied. And you can see the organic materials are kept here, leaves, everything will be put into this pit so that it will be absorbed. This dange and all organic manures are used here, no chemicals. And these are the 5 plots I have chosen for the study. Then I have studied the season observation. 4 season observations were taken with the help of a climber, and it is seen that the leaf number of all the treatments will change or vary during different seasons. This is one seasonal variation for this organic plot, and the seasonal variation for the first treatment, second, third, fourth, like that. And the punch production also, they are showing a variation, and number of spate emergence are also noticed in this 4 seasonal observation. It also vary. Then enter net production were collected, and mature net production were also noted. Then total net production were noted, and nuts harvested during different harvests were also recorded. So it is seen that there is a great variation among the season as well as type of the variety and age group, the production of leaves, nuts, and all these things. Then the important part for this carbon sequestration is stem height and stem width. And it was stem height means height of the stem from the bottom or ground level to the top of the stem is taken as the total stem height of coconut palm. So for 25 palms, is total stem height were recorded for 4 seasons, and stem girth were recorded at 1.5 meter from the ground. This is the standard height for taking the girth of coconut palm. And methodology used is assessment of wood biomass. Wood biomass is equal to volume of tree into specific gravity into form factor. So volume of tree is equal to pi r square h, and radius and height. And above ground by carbon sequestration by a tree can be estimated by multiplying this wood biomass with 50%. Or half of that you can take as carbon sequestered by a tree generally. And above carbon dioxide sequestration by a tree means this value should be multiplied with 3.67 to convert 1 kg carbon to 3.67 kg carbon dioxide. This is a general methodology for finding the carbon sequestered by any tree and carbon dioxide sequestered by any tree. And here I have followed non-destructive method for estimating carbon sequestration. And destructive methods are also available. Here I have chosen non-destructive method. So here I have chosen 2 methods developed by the CPCRI, Center for Plantation Crop Research Institute, Kasaragod, by Naresh Kumar et al. So then he has developed 2 methods. And another method I have chosen is non-destructive method is Alexander Clark et al. Method. So let us see each method individually.
Another 2 minutes for you, please.
Okay. Okay, sir. So this is the CPCRI method, first method. In this stem dry weight was estimated using this equation. And second method 2, the stem volume was estimated, then it is converted into dry weight of stem. And here, in case of finding the density, the 2 density, there is great variation in the density of the stem of coconut in the top portion, bottom portion, this top and bottom. So from that, there's a bottom and this top. So from that, we are taking an average density for calculating the stem dry weight, wood biomass. And we got the result like this. That is, this is the dry stem weight or kg per palm of coconut palm from using the first method, CPCRI method obtained for all the treatments. This is the result. So for organic managed, the carbon dry stem weight was higher compared to the dwarf variety of 6-year-old. Then you can see the graph here drawn using same table. And then we are finding the stem carbon stock of coconut palm. Here we are multiplying this carbon dry stem weight with the 44%, because in coconut 44% will be carbon stock will be available. Then stem carbon stock of carbon tons per hectare can be calculated. That means 1 hectare 175 plants will be there. So into 175 by 1000 will gives you tons per hectare. So many tons per hectare. It's the same graph for that. And stem volume method also we are getting similar trend. Second method was CPCRI method. And why we are multiplying with the tree factor. This is the reason so much is the ratio of carbon dioxide to C is 3.663. And then after that, for finding the sequestration rate, we have to divide that by each of the tree. Then we will get so much carbon dioxide sequestration per year. And then stem carbon dioxide stock can be found out. Then stem carbon dioxide stock tons per hectare for coconut can be calculated from that.
Please try to conclude.
Tons per hectare per year, that is the sequestration rate is given here. And this is the third month by Alexander. And here we are getting this wood biomass in pounds. And this is the formula for diameter less than 11 trees, diameter more than 11 trees. And finally, the same method is used. And this is a comparison of a stem carbon stock of coconut from three methods. That are three methods: method 1, CPCRA 1, 2, and Alexander method. So you can see Alexander method estimation was a little bit less, whereas the other two methods are what going on par. And this is comparison of stem carbon stock also. The similar trend was followed. This is treatments wise, and this is season wise. These two graphs. Comparison of stem carbon stock is given here, and comparison of carbon dioxide stock is given here in this graph. So finally, this is the carbon above ground stem carbon dioxide of coconut palm estimated using method 1. Because method 1 is a standardized one, so we have selected that. Based on that, we have estimated for the carbon sequestration rate of each type of coconut palm, that is less than 10 years, that's 6 years, 0.442, and carbon dioxide 1.617, and T2 0.413, and T3 0.74, and T4 1.839, and T5 1.854. Similarly, this will be multiplied by 3.667, so that we will get corresponding carbon dioxide to sequestration. And finally, coconut plantation play a major role as a source of revenue to the country and also provide livelihood to millions of people. The present study has demonstrated the intrinsic potential of coconut plantation in reducing the global warming by carbon sequestration, which differs with the age, type, and management. The carbon sequestration by coconut ecosystem can further be studied to provide financial incentives to coconut farmers. By this, I thank you to the INTROMET organizers and all the persons participated in this seminar. Thank you.
Thank you very much. It's a nice presentation. So I have a question. Actually, you are telling about two kind of this coconut. One is that green one, and other is yellow one. So this sequestration efficiencies are different in two types of this coconut.
Different, sir. Different, sir. That's why we have taken different treatments to study that. Okay. It's different, sir. Quite different. So great variation, sir.
Yeah, why that difference? Any idea why that difference is?
It's a varietal character only, sir.
Okay.
It's a genetic character only.
Genetic character.
Genetic character.
Okay. Thank you very much. If there is no other questions, we thank her for a nice presentation. It's a very innovative kind of work. Good.
Very much, sir.
Yeah. Thank you. Thank you very much. So we'll go to the next presentation by Krishna Kumar Sinha on integration of human active and ecological restoration on climate change. Dr. Krishna Kumar Sinha, please.
Good evening, sirs. We are thankful to.
Good evening,
Doctor. It is audible, sir?
It is audible. It is audible.
And you can share your also? Slide is visible?
No, not visible. Please share it.
Okay, fine. Now it is visible. Is it visible, sir?
Yeah, it is visible, but it's a blank screen I am seeing. I don't know what about others. I'm seeing a blank screen.
I can share.
Yeah. Yeah. Now it is visible. Make it a full screen mode.
It is in the full screen mode, sir.
Yeah. Okay. You can proceed. Thank you.
Good evening, Dr. Bala Sahab, and all the respected audience and speakers. There was a very good presentation I heard from the last morning. And today's my topic is integration of human activities and ecological restoration on climate change. Myself, Krishna Kumar Sinha, PhD scholar from Suresh Gyan Bihar University, Jaipur. My co-worker, Dr. Sanjay Anil Saw, he is the scientist E, RMC Guwahati, and my guide, Dr. Mukesh Kumar Gupta, Professor Suresh Gyan Bihar University, Jaipur. So, what is our need? Our need is clean environment, means clean air, clean water, uncontaminated soil, flora and fauna, green belt, forest and wild animal. Due to these human activities, it leads to climate change. Human activities results in emission of greenhouse gases like carbon dioxide, methane, nitrous oxide, halocarbons, etc. Carbon dioxide is generated from use of fossil fuel, deforestation, decay of plant matter. Again, methane is being generated from agriculture activities, landfill emissions, natural process in the wetland. Nitrous oxide is being generated due to the use of fertilizer, burning of fossil fuels in the different area of automobiles in the urban sectors, etc. And halocarbons, which are normally we are using in the refrigeration system. And this, all the halocarbons and other GHG, what we have discussed, leads to ozone depletion too. As per the total total warming effect to the Earth atmosphere from the rise in the concentration of GHG by human from 1990 to 2019 has increased by 45%. It is being estimated by the UNEP. Human activities which leads to pollution growth, industrialization, population growth, industrialization, urbanization, which ultimately leads to our environmental pollution. Means what do we mean by the environmental pollution here? The impurities present in the atmosphere or water bodies or marine, it exceeds the limits. Means exceeded the assimilating capacity or self-purification capacity of the air and water environment respectively. This damage to the ecology and leads to climate change. Our government has put up all the regulatory norms and started from 1974 from Water Pollution and Control of Pollution Act, Air Prevention and Control of Pollution Act in 1981, Environmental Protection Act, EIA notification for all the new and existing big projects. And recently, there is a 6 waste management rules stipulated by the government to control the pollution. So major 6 waste management rules, it covers the solid waste, construction and demolition waste, plastic waste, e-waste, biomedical waste, and hazardous waste. So all these waste, one or the other, leads to the pollution, and ultimately it changes the atmosphere and leads to climate change.
Dr. Krishna Kumar, you have got 4 minutes. Please make it.
Yes. So this is the consequences of non-compliance is continuous degradation in the environment, a scarcity of clean air and water, effect on crop yield and crop pattern, health impact, generation of greenhouse gases, global warming, and leads to disasters also. So what is the solution? A strict compliance of the environmental laws and related laws, awareness of the environmental pollution, prevention and control of pollution, convert waste to wealth, like for the circular economy, cleaner production approach in the industrial process, water conservation, recycling and reuse, and ecological restoration. It is very, very important these days. Recently, as you know, that the Swachh Bharat mission has come up in 2014, and the second phase also for the means cleaning of the garbages has been started in 2021 also for the 5 years. So its main focus is what are the dump waste are there, which creates methane and all the greenhouse gas emissions and if affect the climate is being taken care under this Swachh Bharat Mission Urban 2. Some of the efforts has been made by our partners in the different India. Like we have constructed or installed a 12 megawatt waste to energy plant for this waste handling. Similarly, under the Namami Ganga project, we have done a lot of efforts for installation of sewage plant, enforcement of all the industrial activities, improved wood waste crematorium, riverfront development, massive afforestation, treatment of drains, and river surface cleaning. For the example of one recycling of the wastewater, Nagpur has set up 130 MLD sewage treatment plant, which after treatment, the treated water being utilized by the thermal power station. This is a very good example of the recycling of water, which reduces the fresh water consumption. Similarly, the biomedical waste should not be thrown in indiscriminately, and it should be collected in a proper way, and it should be treated in a common biomedical waste facility to avoid generation of carcinogenic gases as well as the effect on the human. Similarly, the debris, construction and demolition waste should be utilized as a resource, and a lot of plants has been installed for the utilization of construction and demolition waste. So ecological restoration is very, very important also, which have a very wide scope here. And there is a need of ecological restoration to get fresh air, clean and drinking water, green earth, flora and fauna for environmental sustainability. Mahatma Gandhi has given the word that we can no more gain God's blessing with an unclean body than with an unclean mind. A clean body cannot reside in an unclean city. So long as you do not take the broom and the bucket in your hands, you cannot make your towns and cities clean. So everybody has to start with the broom and the bucket to clean the city. So thank you so much. And I hope I have met the timeline. Thank you so much, Dr. Balasab. Thank you, audience.
Thank you, Krishna Kumar Sinhaji. It was a nice presentation. It's a very good message. So your research have a lot of implication in our Swachh Bharat mission, Navami Ganga mission, and our Swachh Samudra missions. Thank you very much. Thank you very much for a nice presentation. So we will move to the next presentation. That's the last presentation by V. Seelanki from IIT Delhi. She will be presenting on chlorophyll distribution over the Indian Ocean from CMI P5 model and a regional ecosystem model. Over to V. Seelanki, please.
Okay, sir.
You can share your presentation, please.
Sir, 1 minute.
Yeah, no problem. Don't be tension.
It's audible? Sorry, visible?
It's visible. It's visible. I think it's in full screen mode, no?
Yes, sir.
Yeah, yeah. Yeah, proceed.
So this is Vivek Selanki. I'm from Center for Atmospheric Science, Indian Institute of Technology, Delhi. Today's my topic is chlorophyll distribution over the Indian Ocean from SIMIFY system models. So this is my basic introduction. We all know very well about the Indian Ocean. So Indian Ocean is the different circulations than other oceans, as well as the phytoplankton distributions also different from the other oceans. So there is the main reason is the reversal of monsoon winds. There is two types of monsoon winds. There is during winter and summer. Besides the summer and winter monsoon winds, there is the two transition periods, that is spring and fall seasons. During the spring and fall season, there is a weak wind stress. Because of that, there is a weakening of the mixed layer there. So in a basic physical process like these circulations impact the biological activity over the Indian Ocean. There is namely in the near surface process as well as the subsurface circulations. So North Indian Ocean is not in the North Indian Ocean. There is a two seasonal phytoplankton blooms during the 2 seasons. During the southwest monsoon, combination of coastal outfilling and lateral advection transport and offshore Ekman pumping. So it induced the phytoplankton, strong phytoplankton blooms over the coastal regions. And during the northeast monsoon, due to the convective mixing, it will be entrains the nutrients from the subsurface to surface layers. It will be bring the more chlorophyll concentration over the northern and central Arabian Sea. So study of the Arabian Sea is more important because of the biological productivity is very high compared to the Bay of Bengal. At the same time, due to the presence of press water in the Bay of Bengal plays an important role in the study of salinity and mixed layer dynamics over the ocean subsurface. From the previous studies, we all know that the freshwater flux also plays an important role in the phytoplankton blooms over the Bay of Bengal as well as the Arabian Sea. During the summer monsoon, Bay of Bengal releases a large amount of freshwater. Due to freshwater, it will follow the surface salinity as well as the stratified within the upper layer. So it leading to the formation of berry layers. This berry layer inhibits the entrainment of the subsurface nutrients to the surface. That is like from apotic zone to the surface. So it will be restrict the productivity. So due to that, Bay of Bengal shows a very less productivity. So importance of the biogeochemistry, it is the phytoplankton plays an essential role in the global carbon cycle via photosynthetic carbon fixations as well as the regulate the near half of the world oxygen via photosynthesis. There are also known that possibly regulate the atmospheric CO2 by controlling the injection of deep ocean CO2 and the uptake of the atmospheric CO2. So there is a lack of observational data for the studying of the biogeochemistry. So particularly in situ measurements like biogeographical parameters as well as there is a data gaps in the satellite data due to the cloud presence. So for understanding of the long-term variability of the biogeochemistry, we need long-term data to study the study the biological process. We need the physical biological parameters at the multiple vertical levels. So in this regard, climate models that simulate the both physical and biological parameters were beneficial. So in this present study, we analyzing the performance of the that SIMIFY system models capturing the biogeochemistry of the Indian Ocean, particularly the CHLA concentration and its variability over the prominent upwelling zones.
You got 5 minutes. It is better if you go directly to the your results and the discussions.
So this is the my study region. The red box represents the region of interest. So this is the over the Indian Ocean, the 16 semi-5 models, and the final panel. This is the major product satellite data. So when you see the 16 semi-5 models, that had group models and Max Planck group models are overestimated over the prominent phytoplankton constant product with zones, and the rest of the models are underestimate the chlorophyll concentration over the Indian Ocean region. This time period from 98 to 2005 from historical, because the satellite data available from in historical period 98 to 2005. So we are taking the semi-5 historical data 98 to 2005. This is the model against which the observation we calculate the bias. So we can see these had group models, both models and the Max Planck group model. These models are only these 4 models. They're showing the positive bias over the Arabian Sea as well as the Bay of Bengal and the Equator Indian Ocean. The rest of models are the negative bias, and it is a negative bias. So this is that in the left hand side diagram represents the Tyler diagram. So this Tyler diagram, the standard deviation as well as the correlation. In the table form, we calculate the correlation with respect to the satellite data. You can see the GFDL EM2Z and had group models and a Max Planck median range model showing the good correlation above 0.5, and rest of the models showing the below 5 correlations. So based upon the correlation coefficient, we are categorized into these 16 models into 3 groups. So group A models we consider as a what are the models showing above 5 correlation, 0.5 correlation we consider as a group A models, and 0.5 to 0.3 in between the models we consider the group B, and below 0.3 correlation we consider the group C models. So models from group A shows relatively better correlation with observations compared to the group A and group C models. So here left panel is showing the composites of group A models, and with respect to the OCSA, if you see the group A composite of group A models in the Western Arabian Sea, it's showing the pattern of what showing the pattern in the satellite. The group A model showing the pattern. At the same time, it is overestimated the bloom. If you see the group B and group C models, it will be unable to showing the pattern as well as the signals. If you're coming for the right hand side figure, we are showing the seasonal variations in the chlorophyll concentration from the 98 to 2005. The first panel, the first column is showing the satellite data and group A with respective group models. In the upper top row showing the DGF, that is winter monsoon. So in the DGF season, southern Western Arabian Sea is showing that same pattern, but it is underestimated. In the equatorial Indian Ocean, the group A models are showing the overestimate the bias, and the group B and group C models is unable to show it. As well as followed by the seasons in the summer as well as October, November in the IOD time periods. It is also showing the group A models is capturing the pattern, but it is overestimated that bloom. If you see the Sumatra coast, it is also overestimated the group A models, but group B group models is unable to show the patterns. So now we are going for the monthly variations from the respected boxes. So if you see that this is the head of the Arabian Sea, in the left hand side is the respected with respect to groups, and the right hand side figure show the individual models. If you see the head of the Bible, the left hand figure, so the black curve represents the satellite, and red is the group A, and green is group B, and blue is the group C. So if you see in the Jan to June, the group A and group models patterns are following the pattern, but in the peak monsoon time, that group B models are unable to capture in the head of the Arabian Sea. If you see the Western Arabian Sea, the group A models is able to capture the pattern during the monthly variations, but in the peak monsoon, group A models is overestimated. The respected boxes is like that only. So if you see the individual models, none of the models is unable to capture the patterns except in the head of the vehicle, that GFDL model only they capture the pattern in the monsoon time, but in the winter monsoon time it will be overestimated. But rest of model series not following the pattern. So this is
try to conclude.
Last figure, sir. This is last figure. So this is internal variations. It will be same as like previous figure. So up to 2002, the all models are structuring. So, but in the after 2002, that what are the enhancement you see on the observations, we can't see in the simplified models as well as in the group individual models. This is the respected groups with matrices. We see the standard deviation and over the Indian Ocean and boxes that group A models be able to capture the near the OCC. So this is my conclusion. Models in group A better perform than the group A and group C from the biological simulations. The high CHA content found in the summer monsoon season or the regions dominated by the coastal plains, the productive zones mostly found in the Western Indian Ocean and along the Sri Lankan Dome. Group A models missed the phytoplankton boom in the coastal waters off of the northeastern coast of India and the northern limits of the Bay of Bengal. So this study highlights the regional deficiency of the simplified climate models in the simulating CHLA. So need to improve the coupled biogeochemical models in over the tropical environment. In this regard, we set up we implemented the regional ocean modeling coupled with the biogeochemistry is a biofinal model. So we are working on the biochemical model. So further results we are showing the couple of days. So this work is we published in the Marine Geodesy. Thank you.
Yeah, thank you very much. Nice presentation. So I have one question. You are told about mainly the Western Arabian Sea. So in the Eastern Arabian Sea, mainly the southwest coast of India, which is the model which is doing a better comparison with the observation?
Max Planck, the medium range model is a better simulation showing actually here when you say the spatial map, that Max Planck's medium range model is overestimated, sir. But if you go for the matrices and the matrices, then Max Planck medium range model showing the nice results, sir.
Okay.
But if you go for the spatial, it's overestimated, sir.
Okay, thank you very much. So thank you very much. And this marks the last presentation over. So this is the entire this session was a kind of a miscellaneous kind of discipline. So it's a kind of a interdisciplinary kind of session, starting from the process which controls the productivity to the ecosystem, also to the integration of human activities and ecological restoration on climate change. So we have got a kind of a glimpse where the entire interdisciplinary science is actually working towards putting a one goal of climate change and its coastal impact. So with this entire presentation was of high standard, and on behalf of organizers and on my personal capacity, I thank all the speakers, including the lead speaker and invited speakers. So I also express my sincere thanks to INTROMET and the local organizing committee of India Meteorological Society for inviting me as a chair for this session. And thank you very much. And thank you very much.
Now we have come to the end of this technical session. I would like to express our gratitude to Honorable Chair Dr. Balakrishna sir, speakers, audience who joined online and offline modes. Validatory session will start at 4:30 p.m. in Hall 1, Pampa. Thank you.
Thank you.
ശ്യാമേട്ട കേൾക്കുന്നുണ്ടോ? കേൾക്കുന്നുണ്ട്. കേൾക്കുന്നുണ്ട്. ക്ലിയർ ആണ്.
ക്ലിയർ ആണോ പറയുന്നത്?
അത്ര ക്ലിയർ ഇപ്പൊ അത്ര ക്ലിയർ അല്ല. എന്തെങ്കിലും സംസാരിച്ച കണ്ടിന്യൂസ് ആയിട്ട് ഡിസ്റ്റർബൻസ് ഉണ്ട്. ഇത്ര ക്ലിയർ അല്ല. കണ്ടിന്യൂസ് ആയിട്ട് എന്തെങ്കിലും സംസാരിക്കുമോ? ക്ലിയർ അല്ല.
ഹലോ ശ്യാമേ,
ക്ലിയർ അല്ല. ഈ രാകേഷ് ക്ലിയർ അല്ലാത്ത
അവിടെ സൗണ്ട്
അവിടുത്തെ ശബ്ദം ഇങ്ങോട്ട് വരുന്നു. അവിടെ സംസാരിക്കാൻ പറ. ഞാൻ ഇവിടുത്തെ എവിടെയാ? ഞാനാണോ? നിങ്ങളുടെ വോയിസും ക്ലിയർ ആയി. നിങ്ങളുടെ വോയിസ് ഇപ്പൊ ക്ലിയർ ആണ്.
ക്ലിയർ ആണ് സാർ, ക്ലിയർ ആണ്.
ആ
Manager to the first
Sir.
Abhilash, so should we start or we are waiting for some people?
We are waiting for you. Your last stream Patnaik sir, shall we start? Patnaik sir.
Yes, yeah. So should we start or we are waiting for our people to join?
No, we are about to start the. Can we start? We are waiting for your confirmation from there.
Oh, yeah, we're ready. So let us start it.
Yeah, we are starting with the prayer. So we are.
Okay, sure.
Yeah.
Good evening and welcome to the valedictory function of INTROMET 2021. Let's observe a minute of silence for silent prayer. Now I would like to invite Professor K. Mohan Kumar, Chairman LOC INTROMET 2021 for the welcome address.
Now today, I think towards the last session of the INTROMET 2021. Last 2 days, we have got an excellent sessions and paper presentations and lead talk, but everything has been very well. Many eminent scientists are presented their results. In this INTROMET 2021, we had about nearly 20 these excellent talks, I think, by the morning. Then we have followed by the lead talk, then invited talk, then the contributed papers. Then finally, I think we are having the public lectures also we had. Last 2 days, I think, fully packed. And also we had the poster presentations, mainly by students, and a lot of interactions between the students and the students and the scientists. I think they have participated here. I think this INTROMET 2021 is given us a very excellent opportunity for all the people to interact with each other. I think this today, even though it is in the virtual mode, we have got most of the papers, about 90, not more than 90, 98% of all the abstract presented were presented, and it all went on in time, and everything has been very well. And we have got very good result also came out in this last 4 days deliberations. And the media also have given good coverage about what are the action or the major results. They put in all type of newspapers, and some of them are in the national level also. The news has given a good coverage. And in brief, I think we have the results. Some outcome of the conference is very, very interesting, and a lot of informations are available. And we will prepare it in an excellent report, and then we will circulate to all the members. And today, now my duty of the welcoming the gathering today. First, I would like to welcome the Chairman LOC, Dr. Mahapatra, Chairman and President of Indian Meteorological Society. Sir, on the behalf of the Cochin IMS chapter and Cochin University of Science and Technology, would like to have a warm welcome to this plenary function. Next, I would like to invite the remarks from delegates on the dais. I think Dr. M.N. Rajivan, former Secretary of MOES, I think he informed that he has due to some urgent commitments, he is not able to come. Then okay, for even then he is also then Dr. L.S. Rathore, former DG IMD. Sir, welcome you, sir, to this program of voluntary function. And of course, Dr. Ajit Tyagi, former DG of IMD. Sir, we welcome on the behalf of the IMS, the whole community and as well as CUSAT, and welcome to this function. Then Dr. D.R. Patnaik, the convener of NOC and secretary of IMS. Sir, on the behalf of the IM, the Cochin chapter and the CUSAT, and on my own behalf, I want to welcome you. Then Dr. Ramesh Kumar is the chairman, scientific and technical committee of INTROMET-21. So also I would like to welcome Dr. Ramesh here to this function. Of course, our vice registrar, Dr. Meera, she could not attend due to some other commitments. Some minister is coming, she is not able to come. She informed that she is not in a position to attend this function. And the secretary, local organizing committee, Dr. Sabilash, is also, he has done all the work from here. I think last, everybody is worked hard, and I'm very happy that all of them are get together, work together. Dr. Sabilash also I would like to welcome. And also the board of Dr. N.G. Manoj, I am welcoming you to this function. Of course, our senior professors, Professor Ramavan, Professor C.K. Rajan, and yes, and Dr. Sandosh, and other people are personally, they are here to attend this function. Everybody and the students and research scholars, our team, the entire ACA team, and also Department of Atmospheric Science, the faculty, they are all here. And personally, they attended here the last 4 days. I all welcome you to attend this function. Thank you.
Thank you, sir. I would like to invite Dr. S. Abhilash, Secretary, LOC Intromet 2021, for presenting summary report of Intromet 2021.
Good evening to all. Actually, today we are coming to the towards the end of this Intromet 2021 4 days of program. So let me present some of brief summary, because we have got a lot of feedback and elaborate report from all the halls during all these 4 days from 3 parallel halls. So we will compare everything, and maybe will submit as a detailed report later. I will begin with this because this Intromet, the team has been selected like changing climate consequences and challenges. Then this one logo competition was there, and Mr. Arun K, who had made this logo for the Intromet 2021. That was the beginning of our program. I invite Arun to collect a token of appreciation from our LOC chairman, Mohan Kumar sir.
Congratulations.
Thank you. Well done. So now, then after that, we have designed the web portal, all abstract, extended abstract, registration, all everything is collected through this web portal. That is designed by Raffles Technology, and later this backend process, everything is controlled by one of our students, Mr. Abhiram, and it went well. And we had almost like 17 teams as the sub teams, and in all sub teams we got good response from all many participants, and the minimum number of talks were from because here based on this all sub teams, we have conducted almost like in oral presentation mode. We have conducted 3 memorial lecture, 12 plenary talks, 36 lead talk, 27 invited talk, and 124 oral presentation. All together, we have made around 204 presentation in oral mode. Out of that, most of the lectures were given by very eminent scientists all around the world. And then number of abstracts received, we got good distribution of abstract from all sub themes. Though we have got minimum from AMS, adaptation, mitigation, and sustainable development. That part we got only less than. That is the only theme, we got less than 10 abstract. Otherwise, almost all sub-themes, we got good response, and maybe maximum response we got from 75, that CVE, climate variability and extreme weather events, and then followed by 71 from climate change and then monsoon prediction predictability 61. So we got a nice distribution of abstract. And then the posters, we have given almost like 403 poster option, because we got all together, we got around 604 abstract, and out of that 208 was in oral, and another 400, around 400 was given posters. But all the posters didn't come due to many technical issues, because we have given, I would like to, I am very sorry for that, because some of the posters we received late, because we put last date for receiving the posters as 15th November, but after that also many posters received, and frankly speaking, we have placed all the posters, even received till 23rd and even 24th. So that much we have done from our side. I know that this is the only drawback we had seen from this conference, but we are saying extremely sorry for that if some of the posters were not properly placed in the poster presentation room. So this is the status of the delegates in the conference from India, abroad and total. So means category wise, I am not going through each and every part, but this is the overall statistics as chairs, co-chairs, plenary talk, lead talk, invited talk, oral presentation, poster presentation, memorial talk, and then a very important session we have conducted on national weather services. We had a very good panel discussion, and many of the stakeholders and media persons were actively participated in that discussion, and that went well. And this is the lobby design of our conference. This is the virtual lobby, and we had main programs happened in Hall A, Pampa, and then the two parallel sessions is being conducted in Periyar, Hall B, and Nila, Hall C. These were the three main halls we had during the last 4 days. And according to this, because since we are conducting the decided to go for virtual or online mode, but based on these 3 halls, we have made we have made 3 halls in our department. So all these 3 halls were virtually, there were another type of virtual hall, or we can say that physical hall in our department, and from Advanced Center for Atmospheric Science, all near to Cochin area who have registered as delegates. Around more than 100 participants were physically present during all these 4 days, especially students, because we are conducting this whole program and putting all effort for the students. So we asked the students to come physically and attend the program. So we here made 3 physical halls and there were a lot of good participation in that. And this was the inaugural ceremony that happened in Seminar Hall of Akkar Kusat and Mahika Hall of Prithvi Bhavan MOES. So on the right side, I am not reading out everything. This is inaugurated by our Honorable Ministry of Air Science Secretary, and it went well without any much hassles. And this is being viewed by almost 1,500 viewers through YouTube channel, and along with that there is another parallel channel through the web conference platform, that also we had almost like 400 to 500 participants. Altogether 2,000 viewers were there for the inaugural program, and the main attraction of this program was the conducting of memorial lectures in the name of Professor Anandakrishnan, Professor Annamani, and Professor Pisharadi. So all these memorial lectures were chaired and given by eminent scientists from what we can say the second generation or contemporary scientists in the field. And we have released 3 special postal covers in their name, and that also received well received, and we are receiving a lot of inquiry regarding this postal cover. Many are interested to buy this postal cover. And then we have got good coverage of the media, and thanks to Dr. Manoj was coordinating this media, and we got very good response through media, especially in the print media, both in national and local level. And then followed by the plenary talk, there were 12, total together 12 plenary talks. All plenary talks were well received and appropriate for Indian context and the context of climate change. I'm not going to read out all these things, but it is given as a poster here. And then these are some of the snapshots of the event during all day happened in CUSAT. We had a real physical conference feeling here, and almost like 100, more than 40 students and another 60 participants were regularly actively participating in the conference physically. And these are some of the snapshots, and these were some of our coordinators. Those were behind the scene. They were working hard throughout the night, day and night, and even during last 2 months, that I would say. So they are behind the scene. And this is how we manage the program. We had 3 different halls, but all halls are physically managed from the same place. And there were 3 technical teams headed by Mr. Ragesh, then Rijoy and Sharath. And after that, there are 3 hall managers, separate hall managers for all 3 halls. Dr. Shyam, Dr. Vijay, and Dr. Srikumar and Dr. Manoj. They were managing the all 3 halls, and under them, every day there were different rapporteurs and assistants for making the everyday hall-wise report. And then every day evening, we were getting reports from all different halls. And now itself, we are ready with all up to yesterday. All reports have been updated. Maybe in another 2-3 days, we will compare all this report and make it and communicate to the National Council. And this is how it works: report preparation, rapporteurs giving the detailed report of the session, day-wise report to the hall managers. Then the hall managers will transfer to LOC, and LOC will be circulating to the Meteorological Society National Council. So there was one virtual selfie booth. So this also has got a very good response, because there are a lot of people came and took a selfie in that virtual booth. And this is the e-poster design, and this is the media room. We were very well coordinated with the media, and there were good coverage we got in media. These are some of the recommendations. I think I am not reading out, but this will be communicated as a detailed report, maybe in another, maybe within 1 week. Thank you very much.
Thank you, sir. Now I would like to invite Dr. M. Mohapatra, Chairman and President, IMS, to address the gathering.
Namaskar, good evening to all of you. Respected Tyagi Saab and Rathore Saab, Professor Mohan Kumar, Dr. Patnaik, and Dr. Abhilash, all distinguished members of Indian Meteorological Society, distinguished delegates for INTROMET 2021, distinguished chairs, co-chairs, rapporteurs, members of LOC, NOC, and IOC, ladies and gentlemen. At the outset, I congratulate IMS local chapter, Professor Mohan Kumar, Dr. Abhilash, and the entire team for a huge success in conducting INTROMET 2021. It has clearly demonstrated, even in the threat of COVID-19, how successful we can be utilizing the tools and technology to reach out and spread the message of science and technology. I feel proud to be associated with Indian Meteorological Society, which has continuously contributed towards the development of research in the field of meteorology and allied sciences, and hence nurtured the ambitions of the young scientists and researchers, provided a platform for presentation of the new findings by these young scientists, and also help them with the blessings of the senior scientists. At the same time, there has been a forum for exchange of knowledge, experience, and expertise in this field. And by that way, India has progressed well over the years in terms of understanding of the science of meteorology and allied sciences and its application in terms of monitoring and forecasting of severe weather, and also the sectoral applications. There is no such sector in the society which is not affected by weather and climate. So IMS and ProfMet or INTROMET has contributed immensely towards this direction. Especially this particular INTROMET has served its purpose, as we have seen that there has been more than 600 abstracts. There has been quite a large amount of participation from different countries outside India. There has been young personalities participating in the program, and it has covered all fields of sciences associated with meteorology. So I express my deep gratitude and appreciation to all those behind the screen for making it a huge success. Today, we are fortunate enough that we have blessings of two eminent scientists and former Director General of Meteorology, Dr. Elias Rathore Sahab and Dr. Tyagi Sahab. And also we have the fellows and honorary fellows of Indian Meteorological Society. So during this valedictory function, as we evaluate the report presented by Dr. Abhilash, we can realize that there has been a number of recommendations and suggestions coming out from this INTROMET 2021. So before we proceed further, to invite the comments and suggestions further, not only with respect to conduct of INTROMET and ProfMet, but also the future activities of Indian Meteorological Society, we will have the expert opinion from the chief guest and also the fellows of Indian Meteorological Society. And I hope that there is enough scope further to improve the activities of Indian Meteorological Society by expanding the membership, by expanding our activities, and by expanding our collaboration with other societies, other related societies within India and outside. I hope the enthusiasm and the encouragement which we have received during this INTROMET 2021 will help us to further move ahead and achieve the goal of serving the society in a better manner, and especially in view of the climate change. And as we have seen from various presentations, special lectures, memorial lectures, that climate change certainly is a threat, and the scientific community has to come up to address the gaps and provide the judicious recommendations for the future. Indian Meteorological Society can play a dominant role in these directions by bringing out the facts about the detection with respect to climate change, the facts about the attribution towards the various detected changes, and also the projections and the impacts with respect to different strata of the society, including the impact of extreme weather events. Indian Meteorological Society can also have a role with respect to various adaptations and mitigation measures, which can be based on the scientific approaches and scientific principles. So I will stop here. Let us have the discussions and the comments and guidance from our chief guest of this evening, Dr. Rathore Saab, Dr. Tyagi Saab, and also the fellows and honorary fellows of Indian Meteorological Society. Thank you very much.
Thank you, sir. The next speaker was Dr. M.N. Rajeevan, former Secretary MOES, but due to some official commitments, he is not able to join. So now I would like to invite Dr. L.S. Rathore, former DG IMD, to address the gathering.
Thank you very much. Honorable President, Indian Meteorological Society, Dr. Mohapatra, DGM, Dr. Ajit Tyagi, former DG, Professor Mohan Kumar, Dr. Ramesh, Dr. Patnaik, Dr. Joshi, Dr. Keshav Murthy, other fellows, and distinguished members, ladies and gentlemen. I join our president in conveying my best wishes and congratulations to the organizers for conducting such a very well laid out Intromet, and with a very interesting topic of climate change. And as was told by Dr. Mohapatra, that as Met Society, what role we can play to further the issue related to adaptation, mitigation, and alleviating the impacts, etc. We have learned many things during this Intromet and even before that, and we know very well that our climate is changing, and we have thus far experienced warming of atmosphere, warming of ocean, sea level has risen, sea has become more acidic, the sea temperature has increased, and sea ice area has shrunk, and glaciers have shrunk, and so on and so forth. A lot of things. And things are not going to stop here. And one worrying cause of concern is that we have seen that during lockdown period, the atmosphere was pretty clean. But despite of pandemic shutdowns, we have also noticed that the concentration of carbon dioxide and methane in particular have surged in year 2020 to 2021. Now, this underlines a few things. And one important thing is that until and unless we change our energy sources and the way we utilize our energy, consume our energy, things are not going to stop here. Subject, as was told by President, is very complex, and the impacts are far more complex. And the impact of climate change on different sectors of society are again very interrelated, and it's a very, very, I would call it a very closed web. When we look at that, the drought can harm food production and human health. On one hand, the floods can lead to disease spread and damage to ecosystems and infrastructure on the other hand. Human health issues are increasing, mortality impacting food availability and limiting water availability also. And so point I want to say is that impacts are seen throughout every aspect of the world and sphere we live in. However, these are very uneven across the different segments of the society and different geographical areas. And even within a community or within a region, the climate change impacts can differ between the individuals and neighborhoods. The reducing our emissions of greenhouse gases, as we have fixed a lot of goals for producing energy through green means, need a lot of investments in new technologies, and a lot of new infrastructure are to be created. That will also have a positive side that may spur new job growth, etc. One interesting aspect is that as a meteorological fraternity and as a meteorological society, we need to play a more active role in our preparation of national communication and biannual reports, which are submitted by Ministry of Environment, Forest and Climate Change to the UNFCCC. Currently, there are many aspects which, right from the observations to the scientific issues to the impacts of vulnerability assessment, adaptation, mitigations. There are so many things, and we are now moving towards zero carbon emission. But roadmap has been casted out by Ministry of Environment, Forest and Climate Change. But our participation, I think, need to be escalated. That is one aspect. Aspect number two is that the subject of climate change, which has now drawn the attention of the global community, and need to be connected to our educational system. And teaching about climate change can be a daunting challenge, no doubt about it, but it is a critical field and need to be handled, and this is the right time. The essential principles of climate literacy, though we know that every individual, he could be a rickshaw puller, he could be a farmer, he could be a laborer, everyone is aware of the issue of climate change. Notwithstanding that, we really need to create a framework for teaching issues which are related to climate and climate change. This is very important. And as a meteorological community, the onus falls on us that we prepare toolboxes which are needed for teaching climate and energy explorer, a kind of facilitate the learning process to help the students engage themselves in climate action in their own communities. And that will really be a very, very, I would call it, fruit-bearing, because if you look at the cross-section of broader impacts, when we look at the water, there are many issues because water resources are impacted very severely because of the climate change. On one hand, as I mentioned, flooding is an increasing issue. And on the other hand, conversely, the drought is also becoming more common. And when there is a flood, the water requirement, though water is available, but we can't make use of it. And but during drought season, the water requirement is also increasing. So, of course, there is overall increment in the water requirement, but in extreme situations, the requirements are also exacerbating. And therefore, there is a need for more water-related climate literacy, and not only that tells about the water use, but the prudent water use, and particularly agricultural sector, which is consuming almost 75% of the total water consumption, rather 80%. The food security is again a big concern, and because of fortunately, Government of India launched very good scheme through Indian Council of Agricultural Research under Climate Action Plan, where we try to address and develop the climate resilient agriculture. And almost all the sector of agriculture, horticulture, livestock, poultry, they are being addressed, including fish, both the mainland fish and oceanic fishes, freshwater fishes and oceanic fishes. And we are confident that we will be able to mount a good resistance to the changing climate from the food production point of view in agriculture, be it cereals, be it pulses, be it oilseed crops and other crops, and also milk, meat, and egg production. So far, we have been able to handle it, and I'm sure we will be able to handle through these climate resilient agricultural practices, where we are trying to address, on one hand, by genetically modifying our germplasm, both crops and flora and fauna, to circumvent the negative impact of the rising temperature and other climate change issues. But the issues which are related to human health are really a cause of worry. We have seen the COVID situation, but not only COVID, the viruses, by and large, to the best of my understanding, are becoming more virulent. And for each category of viruses, we are seeing that new strains are popping up here and there, and they are causing a lot of injuries, airborne diseases, waterborne diseases, and the infectious diseases, etc., vector-borne diseases. And because vector they themselves are very sensitive to the changing climate, unfortunately, we have noticed that those vectors which are so-called as dangerous vectors, or those plant species which are bad, I would call, they thrive better in the changing climate. So therefore, there is a task for us, and not only to handle these issues, but also to protect our environment, which is degrading very fast. Biodiversity is really at the danger, and we need to really help the environmental conservationists as to give them a good guidance as to how the geographically the changes are likely to be encountered. So also there is another area like infrastructure, be it roads, bridges, electrical grids, and broadband internet and things like that, all communication systems. We have seen that especially the coastal lines, when the cyclones are coming now, these days cyclones are much more fearful, and a lot of damage to these infrastructures are occurring, including the damages to roads and rails and bridges, ports. Under these circumstances, we really need to redefine our thresholds, because for different types of infrastructure, we put different wind load or water level consideration, etc., while preparing those infrastructure, which are based on the long-term observations, past 100 years or so. But the past extreme epochs are now changing. I mean, in future, they are surpassing the past epochs, and therefore, we need to redefine the new requirements which are for the new infrastructure. And a lot of infrastructure are now coming, because we are now a fast-growing country, and therefore putting up a lot of infrastructure, new infrastructure. And this is all the role where meteorological community can assist public at large, administrators, and also disaster managers. I would thank all the organizers to inviting me to talk to all of you. Thank you very much. Jai Hind, Jai Bharat.
Thank you, sir. I would like to invite Dr. Ajit Tyagi, former DG IMD, to address the gathering.
Thank you, Dr. Mahapatra, President, INTROMET Society and the Director General of Meteorology, Dr. Rathore, Professor Mohan Kumar, Dr. Ramesh Kumar, Dr. Joshi Saib, Professor Keshamurthy sir, members of the organizing team, thank you so much and inviting me to share my views. I joined Dr. Mahapatra and Dr. Rathore in complementing the organizing committee headed by Dr. Mohan Kumar and ably assisted by Abhilash and Dr. Patnaik in organizing this INTROMET in an excellent manner. And I have no hesitation in saying that this was one of the best organized INTROMET despite the constraints of COVID challenges. Congratulations and compliments. And the teamwork which has gone behind that, as Abhilash has shown, was really commendable. It shows the leadership, like you said, the participation of students, and I'm really impressed, and positively it must have benefited them immensely. So it is their contribution and the learning which they must have benefited from the presentations which were made. The number of presentations, the number of papers received, it is really impressive because of COVID. I wish if there would have been a physical INTROMET, they would have much more benefited, but within the limitations, the quality of presentations were really remarkable. And what I'll urge INTROMET Society, National Council, as well as the organizing committee, to come out with the proceedings of these papers presented, peer-reviewed, because so much of valuable papers and the findings have been shared here. They should not be lost. So this is one of my requests. And the way it has been organized, I see no reasons why it cannot be done in a time-bound manner. So I'll urge again Professor Mohan Kumar and his team to take up this and see that the peer-reviewed. Unfortunately, many of earlier INTROMET we were not able to bring out these proceedings. We used to bring out regularly, but now it's again a time that we have proceedings of this important INTROMET, because the topic is very relevant and it is going to be, as brought out by Dr. Rathore and Dr. Mahapatra, is of great importance both as for the science and for the society. So we have to build up what we have gained from this INTROMET and take it further through the regional workshops, regional seminars, and public outreach. So this is one important thing which I'd like to share. Dr. Rathore has gone in great details, so I don't wish to repeat. All those issues are very relevant, and they are going to become much more pressing and demanding in the future to come. Now, as a professional society, we have to work at a number of levels. One is to promote the climate science in the country. And now for that, we have to do advocacy. We have to come out with impress the Ministry of Earth Sciences, Ministry of Environment and Forest, to come out with doctorate fellowships in the academic institutions in the climate science. Unless we have a young, bright people doing research in climate science, I think next level of quality of research will not be possible. So we have to come out as one of the recommendations is that there should be, we have got now fairly good amount of academic institutions where if we have a now Center for Climate Change and Research, they could be a center which can create linkages with these universities to promote such activities and assist them by providing computing power and mentorship. So this is one important thing which we should take up as a society. Second is as Dr. Rathore is the climate services, which is becoming important, which there is. We have started providing the INTROMET Society, INTROMET department and various institutions are providing climate services, but then we have to further strengthen these services in each sector, and sectors are almost all sectors of the societies. 30 odd sectors have been identified which provides weather services. All these require the climate services also for long-term planning, mitigation, adaptation. So how do we strengthen as a IMET society, help the Ministry of Earth Sciences, INTROMET department and other government institutions in providing these linkages with the civil society, the users and the stakeholders. See, we have got strength in the terms of our regional chapters, which is spread all over the country. They can convert most of the things in the local languages and can be a very good center for the outdoor activities, which no government department can do of its own. So this is very important, that how do we leverage the INTROMET society with its regional centers and state centers and the chapters which are there to work to extend the climate services to the part. Third level is the public awareness, especially among the students and the teachers. So for them also, I think INTROMET society should take lead to have structured regional programs for each climate, because there is so much of regional variations also in climate and the hazards which are there, extreme weather events. So we have to tailor-make such modules and the programs for each region to come out, and then sector specific also, and extreme weather events and the precautions and the safety measures which can be taken can be also built in this. And fourth, of course, is the mitigation and adaptation, which is going to be there, which is linked with the projections. So if we have got, because they are very costly decisions to be taken, and some of them are no regret solutions. So first, we should identify these no regret solutions and advocate them. And second, if they are going to be heavy investments, we should be very sure of the confidence in our projections. And then, so we have to work on both the sides to advise various stakeholders where the investments are going to be made, whether they are scientifically sound investment decisions are being taken. So this is another area which needs to be positively looked into it. We are already working with many of the societies like the INTROMET society is there, Ocean Society is there. So we have to develop more linkages with all in the health sector, in hydromet sector. We have also a lot many nowadays disaster related NGOs are working. So how do we have some linkages through the citizen science, make use of I think as our partners to communicate and spread our services at the grassroots level. So we have to develop these linkages, because no single institutions or the society can do in such a task in a country like us, which is so diverse, such a huge country. So we need to develop partnership, and IMET society can do a wonderful job in this respect. So we should try to work, strengthen our I think this is really a achievement of successfully organizing this INTROMET. It shows the country's strength. I'm sure we should showcase the outcome of this particular INTROMET and build on this for the future activities. once again, I attended many of the sessions, and especially the plenary talks were excellent. Even the contributing papers of some of them were really of good quality. So I compliment the technical committee for have selected good papers for presentation. And also, again, Professor Mohan Kumar, Abhilash, and entire team for under the guidance of NOC, Dr. Mahapatra, Dr. Patnaik, to have planned and successfully organized this seminar in 3 parallel halls. And also the physical presence of students, which was really, I'm sure, must have benefited them immensely. And you said should make use of this learning process to become one of the leader in the climate science and services. Thank you. Jai Hind.
Thank you, sir. Now I would like to invite Dr. M.R. Ramesh Kumar, Chairman, Scientific and Technical Committee, INTROMET 2021, to address the gathering.
Good evening to all. Let me say, respected Dr. Mahapatra ji, President IMS and DG India Meteorological Department, Dr. L.S. Rathore sir, former DG IMD, Dr. Ajit Tyagi sir, former DG IMD, Professor Mohan Kumar, Dr. Abhilash, and all the fellows who are listening to this. I would like to continue from what Ajit Tyagi sir has just now said. One of the most important things is actually this has been one of the most successful INTROMET so far. So some of the outcomes of the results should be published in some national journals, maybe like Mausam, Vayumandal, Journal of Earth System Science, Current Science, or even Indian Journal of Geomarine Sciences. This is one activity which we should positively do. Another thing which I would like to follow up on, as Dr. Ajit Tyagi sir correctly mentioned, was actually the outreach activity, which is a very vital thing, because in the current scenario of actually climate change in this one, fortunately, people like say Dr. Abhilash and Manoj and several of the scientists are always on the news media, at least in Kerala. In fact, in Kerala, from April onwards, it has been raining continuously, non-stop. Whether the people are really worried, and they have actually one after the other, low pressure systems or areas or water, never ending. In fact, the people are cursing the rains nowadays. It is the other extreme we have gone. First, we had actually southwest monsoon, then we had the northeast monsoon. And I would say this theme of actually has actually been really fantastic and very relevant in this present scenario. One major problem which, let's say, TROPMET or INTROMET things face is actually the crunch of finances, which I would like to stress upon. Main thing is actually I had been 2 earlier INTROMETs. One was actually the SRM University or maybe at SAC, etc. They were fully supported by the institutions. Unfortunately, Cochin University is a small university when compared with this one. So I would strongly urge the India Meteorological Society, Ministry of Earth Sciences, IITM, IMD, INCOIS, NCPOR, NSES, and NIOT, etc. to help. So I would request the President, Dr. Mahapatra ji, to get enough financial this one for this activity. Another 2 innovative things which we did during this conference was actually, I was preparing to bring out 3 special covers on the eminent international scientists. When I thought only of a small venture, Professor Mohan Kumar went one step ahead and thought of actually making some memorial public lectures on the name of this eminent scientist. Both of them have killed very well. As Dr. Ajit Tyagi was mentioning earlier in the IMSP WhatsApp group. Unfortunately, we don't have a stamp. There are hardly any stamp on a meteorologist. Maybe other people might have had, but maybe we may have a stamp of Benjamin Franklin, which is actually published by USA. But in India, we have only the stamps of geologists, like say D.N. Wadia or maybe C.V. Raman stamp is there. But high time we need maybe the Indian Meteorological Society, as Dr. Tyagi Sahab has correctly mentioned, India Meteorological Society should try to make stamps on maybe Professor K.R. Ramanathan and maybe whomsoever we find, or as Tyagi Sahab and maybe several people from IITM also has strongly supported that in each of the TROPMET or maybe INTROMET, at least we should have a minimum of actually some special covers released in future, which should be fully supported and funded, maybe the IMS or maybe the local chapters in each of those things. Another interesting fact about this INTROMET is actually earlier most of the ProfMet or INTROMET were actually restricted only within the IMD and IITM community. But it has slowly started spreading into the various universities. In this present conference, we had actually people from Kashmir to Kanyakumari and from Gujarat to maybe Assam or maybe Guwahati. Cotton University is also, Professor Goswami is working, that also the students have participated. So we had actually full length and breadth. We have the participation from the IITs, ISERs, universities, central universities, you name anybody, IMD, IITM, no doubt they have actually gone out the limelight. But then, and another interesting aspect is actually we had the plenary sessions, maybe from the different continents, whether it's the USA, UK, France, and Japan, you name anybody. So almost all the states, all the institutions, all the universities, all national institutions, and from all nations. So the plenary talks were excellent. And we have chosen excellent memorial talks also was delivered by actually Professor J. Srinivasan from the IAC and C.R. Sridharan, IMD gave the Anamani memorial talk, and Professor B.N. Goswami. Yesterday I attended a very, very interesting, lot of interesting anecdote also he gave about his association with Professor P.R. Peshariti. So all the talks, whether it's the plenary talks or the lead talks or the oral talks or the invited talks were actually outstanding. And there was hardly any absentees in this conference. That is also very, very interesting. We didn't have any, almost I would say zero absence, whether it's oral talk, and we had some fantastic posters, which the students have actually really worked on and done a wonderful job. So I would like to thank especially Professor Mohan Kumar and his team of Dr. Abhilash, Dr. Manoj, and the persons I forgot. Okay, the whole team has actually worked day and night to make it a grand success. Thank you very much.
Thank you, sir. Now I would like to invite the delegates, session chairs, session co-chairs, plenary speakers, and others to give their valuable comments and feedback. I would like to request Dr. Anand Kumar Das to give his valuable feedback. Please, sir.
Respected sir, am I audible?
Yes,
You're
please go
audible,
ahead.
sir.
Yeah. Respected both chairmen and president of IMS and Professor Mohan Kumar and local organizing committee and our National Council members and honorable fellows and members. I am happy and also privileged to be part of this valedictory function. We first organized this virtual platform workshop in ProfMet. That time we had our confidence, but INTROMET, it was a huge event. So we are a little bit hopeful that we will be going for physical, but somehow we could not go. But we could do it with all help and all enthusiasm from local organizing committee in virtual as well as physical, so hybrid manner. So we are thankful to all chairs and whoever could participate, that all speakers and all the deliberations. It was really very good, and through YouTube we reached up to huge people. Every day all the 3 halls were on YouTube. I could not personally attend all the halls, but I could attend 1 or 2 halls presentations, whichever was very much interesting. And I was watching that lot of people were there in every hall, and they are putting questions through chat box. So that itself shows the interest in our INTROMET and moreover the engagement. Sir, every time local organizing committee and our national council were interacting for any kind of issue is there. So we sorted out immediately, and Abhilas is actually relentlessly trying every time to do the things perfect. So we could do that, sir. And that's why we congratulate Abhilas and his local organizing committee and Professor Mohan Kumar, sir. And then nonetheless, sir, our president, sir, he was busy with his own schedule, but he was overall putting his guidance in each and every aspect of the whole program. And for our secretary, IMS, Patnaik sir, he is an actually champion for organizing events. So, sir, you did it this time also. And then, sir, whole program, when I was watching from the presentation of Abhilas, actually it was, I was feeling, sir, it was as if we have done it really. So it is done. Sir, and for as a treasurer, IMS, I am happy that we could manage whole event with our whole financial support from other partners and collaborators and sponsors. So that way we are also thankful to all of them. So that way we will be expecting that every other future events of our society will be successful with all help. Okay, now I'll be also thanking our local technical team who actually in the beginning we were a little bit in dilemma about hybrid, but technical team could sort out, and that is so that shows that the technical team and scientific team can work together to get an event very much successful. Certainly we are scientists, we are also technical people, but the technical people who are working behind, they don't know anything about atmospheric science or meteorology, but they realize the importance of the event. So they wholeheartedly supported us. So that is also very heartfelt thinking. So with that, I finish my and I congratulate everyone, and also I am thankful to our seniors and their for their blessings. Thank you.
Thank you, sir. May I now request the IMS fellows to give their valuable comments, please?
Professor Kesamurthy sir, Joshi sir.
You are not audible, sir. You have to switch on your mic.
First of all, I would like to thank congratulate Professor Mohan Kumar and IMS Chairman and Secretary for the wonderful way this INTROMET has been conducted. I think you deserve all praise for this very wonderful and successful INTROMET. I know Dr. P.V. Joseph personally for a long time. He was a long-term colleague and also a good friend. So I was happy to see him virtually.
Mic off, sir, again.
I was also happy to hear the names of our earlier mentors, Professor Pisharati and Professor Ananthakrishnan. I was happy to work with these great scientists and great people, human beings in IITM and TRL. I was reminded about their kindness and the way they worked with us junior colleagues at that time. It's very heartening to see that so much considerable progress has been made in climate modeling from our days to this day, in both in the outside and in India. IITM, IMD, NCMRWF. I think we are dealing with a very complex system, and we are developing very complex models. It is also heartening to listen to some young people working on new areas like AI and ML being applied to meteorology. I think this deserves more attention, I think, in future. I think it's also time to celebrate and rejoice the first ever Nobel for climate modeling. I was very privileged to work with Professor Manabe in Princeton. He's also a great scientist and a very great man. So I'm reminded about that. So thank you very much once again. And we are very happy that the science of meteorology and climate modeling is progressing so much from our days when we were using smaller computers and smaller models. I think there should be more interaction between national laboratories like IITM and IMD and NCMRW and the smaller university community who may need computer time and other exchanges, etc. This should be formalized in some way, I think. Thank you very much.
Thank you, sir. Dr. P.C. Joshi, sir, would you like to make some comments?
Thank you. I forgot the name, whatever is your name. The organizer, representative of the organizer, thank you. And thanks to Patnaik and others. First of all, Dr. Mohapatra, President IMS, Dr. Professor Mohan Kumar, Chairman, Local Organizing Committee, and our old teacher at Ahmedabad and colleague, Professor R.N. Keshavamurthy. Very happy to see you, sir, after a long time. Dr. Tyagi, Dr. Rathore, and many others. So if I take name, then taking name, I may forget some. I was very happy to attend this INTROMET. Happy side is in many ways, Professor Keshavamurthy will realize, because this was a small seeding we did at Ahmedabad in 1992. Professor Keshavamurthy was one of the very active person behind it. Some of us are in front, so people know the front person, but the real brains behind where many, it happens. It happens, for example, in your local organizing committee. Professor Mohan Kumar and all others are there. Behind them, there are many more people working. So the seedling of that 1992, that was a very nostalgic time, that way, how to do, what to do. And it has grown to such a big scale. Now, if I was just counting, this is the 29th event in INTROMET series. INTROMET 29th event. So it's a very long and a very big way it has expanded. when we started it, I remember few of the persons in our Space Application Center auditorium, they were, you have started it, but how will you sustain it? Where are the papers? Where are the persons? Where is the money? So we said that, sir, don't worry, we'll try, and this is happening. So in that series, congratulations to the coaching chapter that you have organized so well. INTROMET, real INTROMET, a very good, great, internationally standard, and a very, very technical, heavy INTROMET that has been organized. Congratulations to the. In fact, I was involved, actively involved, even now also we are involved. When Cochin organized the first INTROMET, I think it was around 2000 or some around that time, I was actively involved around organizing that also. So I remember, but after that, our resources, physical as well as intellectual, they have increased tremendously. And that is apparently that we are seeing in, but I was a little amazed when Ramesh Kumar said they had financial crunch. Now, this, I don't think this may be a temporary local transient Ramesh Kumar. These days, if you see in the TopMet, INTROMET, there is no financial crunch. You take for granted from me. Now, the reason here could be because of the pandemic, because not many communications were there. So maybe could be that of that reason. But as future organizers, I will say that please don't get afraid of the financial crunches, and they are available. And in fact, we have seen in all the past organizers will see that there is no financial crunch. Okay, so that is. So now on part of the symposium, it was a great job done by local organizing committee chairman. And I also admire the technical committee chairman, the way this scientific program has been structured, the way the people have been called, the way the themes have been, in fact, the way the topic itself has come up. Such a nice topic. So that was wonderful part on. I am only wondering about Ramesh Kumar. He seems to be everywhere. He was in Goa. He is right now in Cochin, and I see him through his extension very much involved in Pune also. So I wonder whether he is settling between all these places, or I have no idea. I will personally talk to him and get. I also remember Ramesh Kumar, some time back, he was saying that he has great desire to hold a INTROMET in Goa, right? So that.
Yes, sir. Yes, sir. We will do it. We will do it. At least first a TopMet. First we will have a TopMet, then we will have INTROMET, both.
Okay. So that
we will do it.
Has the desire also.
We have the desire. We have the desire.
I think the future it will be done, and
we will do it, sir. We will do it.
Okay. Great. So I'm very happy to. I attended some of the lectures. It was good.
Yeah.
And many of the things have been told by the earlier speakers. In fact, Dr. Tyagi has so nicely summarized everything. So not much is left to that. But Dr. Mahapatra said that you, being the fellows, you should also say something about the society. So Dr. Mahapatra, my one or two suggestions I will give. Now, this is a very good opportunity around this time. Around this time, we are having two great things. One is the political one, Azadi Ka Mahotsav is going on. And society is involved. You are organizing many lectures, but that may not be sufficient, something more. But in addition to that, we had the Nobel Prize in Physics in terms of the climate change. So this, our society should in a big way take up this in expanding our membership to different institutions. Like all those, this is a Nobel Prize in Physics. That's a great thing. I remember my student days, once a climate change paper in Modern Reviews appeared, there was a world over, there was a halla gulla that climate change in physics. So my suggestion would be to expand this to those institutes which are like TIFR. Why not we go to TIFR, hold a symposium with them, IMS and or the local chapter Bombay, TIFR, that is just my one example. There is Med Science in Chennai, there is Harrison Institute in Allahabad, like that those who are front-ranking institutes in physics, mathematics, we can go to make to those institutes, involve them in some activities, make members from there, and then so that they know about, because through this climate change, they know and they will contribute. They will definitely contribute. I remember once the director PRL, Professor Devendra Lal, he said that had I heard Professor Krishnamurthy giving this lecture, I would have long back joined meteorology. So the similar thing would happen if you go to these big places and big, well, of course, we have to be very careful. Unless the quality is shown to them, then, so this is a good opportunity to both these things. We can visualize and the society can expand in activities with them. Even the Academy, National Academy of Sciences, and I say you take maximum advantage of this Nobel Prize so that we organize different activities at different places. School children, with the education of the school kids and the college students, telling them about the climate change, not climate change only. Climate change, every Tom, Dick and Harry is talking about physics of the climate. The physics part, mathematics part, if we try to expand, that will be a great opportunity for us. That I thought just a small suggestion I could give. And thanks to the National Council also for getting the good, and you have to be little getting involved local chapters, because I found that the last general body meeting, we had hardly any local body, local chapter represented there. That was a very, very sorry type of thing, that because in, at least in pandemic, they are sitting in their house and attending the IMS general body, but even that also did not happen. Even today, I think that so you have to involve, sir, with them in a big way so that the activities go spread. And thank you very much. Thank you, Mohan Kumar, all those 4 persons, 5 persons sitting there. Thank you very much. Namaskar.
Thank you, sir. I would like to thank all the delegates for their feedback. Now I invite Dr. D.R. Patnaik, Convener, NOC and Secretary IMS, to address the gathering and announce the results of student poster competition.
Namaskar, very good afternoon, good evening, respected Mahapatra sir, DGM, IMD and President IMS, respected all our fellows IMS here, Rathore sahab, Tyagi sahab, Joshi sahab, Kesamurthy sahab, respected all our colleagues from Cochin chapters, Mohan Kumar sir, Ramesh sir, Dr. Avilas, Manoj, and all other team members, and also my colleagues from NC, as well as those who are watching this program through online YouTube. So as already spoken many things about the IMS activity, and I have been associated with the IMS for I think more than 20 years maybe. I started associated with IMS in Pune and then also continuing here. And I have also seen a real transition of as far as IMS activity is concerned in last 1 decade actually. Yes, it is going on 30 years from 1992. Now it is 30 years we are celebrating this annual event. That is also itself is a great achievement. As Joshi sir was telling, initially was a lot of difficulty comes, but sir, it is gradually growing and growing. Sustainability is there with improvement, day-to-day improvement, year-to-year improvement is there. So 30 years were completed. And when I recall just to let us say 2012 actually Dehradun INTROMET was started with associated with the IARS. So whenever we associate with one university or anything in local chapter, actually the functions really improves a lot. That has happened like just like Cochin chapters, now Cochin University. So that has contributed to the improvement of the IMS annual. So in the Dehradun actually the 2 things started. One is Ruchi Ram Sahani Memorial Lecture. So that memorial lecture was started sorry, not memorial lecture. Memorial lecture started in Chandigarh actually, 2015. But that time we invited all the many international delegates also for the INTROMET. So that was first event. Then subsequently the memorial lectures are continuing, and this time also we have seen a good 3 memorial lectures by distinguished scientists. It was very well appreciated. And then also there are several awards were constituted in recent times, last 5, 7 years, 10 years. So that also we are giving to encourage the scientists, those who are writing papers. And if you see, really lot of papers are coming for award, and it is becoming difficult. So committees are constituted. So people are writing good papers, and that's why we also want to give the regular awards for. But this growth of IMS is not come in just in a year or two, because a lot of people have contributed. I must thank all our previous president, previous DGM of IMD, and also the MOES like organization like DST, MOES, then SCRB, ISRO, IITM. Okay, even state government, whenever we are organizing some events, state government are also supporting ICMR, ICAR, CSIR. These are all organizations, they have contributed, they have supported financially from time to time. Okay, so when these virtual events are happening, we are very little bit skeptical to ask a lot of money from the different party, because when it is physical, yes, we have a plan that we are going to spend a lot of money. So that's a little bit we are hesitating to ask huge money. But as Ramesh sir was telling, need not worry. Okay, so whatever this INTROMET spending, definitely we will be able to fulfill that work. So through different agencies, still we are awaiting money. So that should not be an issue, as Joshi Saab has told. So that let us keep aside. Otherwise, let us focus on activity. So it is going on. And another point I would like to highlight: the IMS, Indian Meteorological Society, role is to enhance the science of meteorology, recognize the people also. In that sense, the research institution and the operational agency. Research institution also working hard. There's a lot of good papers are coming, modeling, as you see, Rakesh Murthy sir was mentioning. I was also there when climate modeling started in IITF. So now we have seen the transition. So all the activities IMS is encouraging, so that should come here. And at the same time, IMD as an operational agency also need to improve the services. So that's a R2, research to operation. So this type of platform where this annual event, 600 papers with a lot of experts from national, internationals are gathering and discussing, deliberating their results. So really it is contributing to R2. I mean, something research is contributing to the operation. That means after men, our role is to enhance this service also. So in that way, IMS is playing its role. And one thing I miss here actually, that was also started in Dehradun, that whenever this type of event was at the last day, we actually felicitate our local chapters, personally, Misal, etc. That we are missing here. But I must thank all this, the local chapters, local organizers, and for nicely conducting the session. Although 5 people are sitting there, but there are many people are behind that we have seen in the presentation by Dr. Abhilash. So I must thank each and every one of them. They have contributed. Otherwise, it is not possible to have such a great event successful. So let us thank you, not physically, but online. Thanks to you and our national team here. Also have supported us, arranging this technical thing. Dr. Das, Anand Das, our Joint Secretary Laskar, and our Samanti, Sanjay Beast, Giri, international event, because since it is international work, there are also some permission were required from the international level. So that also we are coordinating to our international division. So I must thank all the National Council members here, Dr. Sai, all this for supporting. And as I said already, all chapters we miss this thing. And next time, some of the suggestions are very good to bring out the publications. So many research papers are there. So that presented, that we will consider. And also Tagisa was mentioning that also there are variable points, and that we will take care, so that we will see that thing, how it can happen. And regarding the next chapters, actually INTROMET, we have got some suggestions. Since it is not finalized, we are not discussing here. We will have our separate NC meeting, then there is need we can have another GB meeting before the end of this term. So that will be announced which will be there. But recently we'll see the location. We have arranged this INTROMET in last 5 years. Bhubaneswar, Chandigarh, Ahmedabad, Visakhapatnam, then now it is Cochin, Shillong. Okay, so that we will find out some other place, maybe Central India or North India, something like that. Some proposals are there, so we will discuss and we'll finalize the date. So I must thank all the sponsorer also, the chairs, speakers, and lecturers, and all the memorial lecture delivered, those who have lecture, invited talks, all participants for their contribution in making this event a grand success. Thank you very much. Okay, thanks. 1 second. This is the job of announcing award. Sorry, yeah. So actually, there are some poster awards that to be given. So yes, I didn't watch, but there is a committee. Yes, Abhilash can explain. But yes, they have selected. So I will just share the screen. 5-6 awards. 1 page is there. So let me just share the PDF file. Okay, so it is very readily available. Yeah, this is the so awards actually. Best poster presentation award. 5, 6, 7. 7 papers are there. I understand that the second place 2 award, some 2 people, something like that. Third place 3. So total 7 papers are identified, selected for this one. Just I did not read here.
All awards are same. All awards
are same. So there is no first, second, third.
No first, second. No
Yes.
first, second.
All awards are at the same level. So it is not first, second, third. So you can see some name: Jia et al, then Moher et al, Rajwal et al, Pritam Das et al, okay, Renju Nandan et al, Shruti Kep et al, Yasmin Jahan et al. So these seven poster have got awards. So congratulations to all of them for their making the good poster. I think thank you very much, sir. So I'll now back to, I'll just stop the sharing. Yeah, thanks, sir. Thank you very much, sir.
Thank you, sir. Now I would like to invite Dr. M. Mohapatra, Chairman and President, IMS, for concluding remarks.
Thank you. So I should once again congratulate local chapter, IMS, and Cochin University of Science and Technology for successfully organizing this INTROMET 2021. So my special thanks goes to each and every member of this local organizing committee, Professor Mohan Kumar, Professor Ramesh Kumar, Dr. Abhilash, Dr. Manoj, and all the persons behind. It has been an excellent INTROMET. It will be remembered forever. It has brought out a lot of science and its applications. And certainly this INTROMET 2021 will help the further research and development in the field. As it was being told by our respected fellows and participants, we should bring out the publications of the proceedings from INTROMET 2021 in different journals. Maybe readily we may consider Biomandal, MOSAM, Journal of Earth System Sciences, and some others, because we have got a lot of papers, so it can be distributed and it can be published in 3-4 journals. Journal Biomandal has also come up a long way. We have made it a regular affair now. It is being published in time, twice a year. It has been tried to improve the quality of the publications in this IMS journal. And one more step we have taken, just like we have made MOSAM now the online journal. The entire process is made online, starting with submission till publication. For Biomandal also, we have initiated the process. The Entire process will be made online, starting with submission till publications. By that way, we can improve the timeline, we can improve the quality, and maybe the proceedings of this INTROMET 2021 will be the first issue with both online and offline publications of Bimandal. The suggestions and guidance given by our distinguished fellows like Joshi Saab, Kesamurthy Saab, Tyagi Saab, and Rathore Saab are well taken. We'll certainly try to expand the wings of Indian Meteorological Society. We'll try to have collaboration with new institutes, those who are involved in meteorology and allied sciences. And by that way, we can have the footprints. Also, we can have the new members of the society. This process is already on, and gradually the number of institutes and R&D organizations being involved with IMS are increasing. The second important suggestion, whatever you have given, that we should take advantage of this pandemic and the Nobel Prize towards the climate change. Taking this opportunity, we should not only organize the seminar stage, which is being organized till now, we should also have more number of small conferences or symposiums with different organizations and highlight not only the role of Indian Meteorological Society, but also the science itself, and hence the collaboration with other allied sciences. I must thank all the members of the National Council and the local council of Kochi chapter for their hard work, continuous work, for a long period, and which has resulted certainly in this success. As Dr. Patnaik was telling, there are many people who are involved for quite a long time with the development of Indian Meteorological Society. And because of their contributions, we are marching forward. At the same time, the young mass are also coming up, as you can see with Dr. Abhilash and Dr. Manoj. I express my heartiest congratulations to all the youngsters, and their contributions has really made it a different from the previous DropMets or INTROMET. I hope in future also we will have the enhanced activity of the society with more and more contribution from the young researchers and scientists and many organizations and many allied sciences. Though the basic objective is to nurture the science of meteorology and allied sciences and make it popular, IMS has also an objective to serve the society by improving the awareness about the various aspects of weather and climate. That way, we have come up to certain extents to organizing certain popular lectures and etc. and symposium conference, but there is still scope to improve it further by aligning ourselves with many societal organizations where weather and climate play a dominant role. I hope we can all work together to not only improve the science, but also the scientific applications to serve the society and hence the country. So I once again thank all of you for your dedications, commitment, and involvement in Indian Meteorological Society. And your contribution has seen the success for the past 30 years in the conduct of DropMet and INTROMET, and also in the past years, the evolution of Indian Meteorological Society. Thank you all.
Thank you, sir. Now I would like to invite Dr. M.G. Manoj, Treasurer, LOC, Intromet 2021 for a vote of thanks.
Good evening, most respected Professor Mohan Kumar sir, Dr. Abhilash, Dr. Mahapatra sir, Dr. Rathore sir, Aditya sir, Keshamurthy sir, Joshi sir, Patnaik sir, Ramesh sir, and all the distinguished delegates on and off the dais. My heartiest gratitude and sincere thanks to one and all. At the outset, I would like to appeal for an anticipatory bail because this list is so huge that reading out everybody's name would be like a Herculean task. And if I omit somebody unintentionally, please forgive me. First, I would like to thank respected Dr. M. Ravichandran sir, who is the Secretary of the Ministry of Science and DST, for sparing his valuable time during his busy schedule for addressing us and delivering a plenary talk also. And also, I would like to thank Dr. M. Rajivan, former secretary, and who has always been a support for Cochin chapter and also for the Radar Center at Cochin University. I thank from the bottom of my heart, and also to Dr. Mahapatra sir, Director General of IMD, for his valuable suggestions and presiding over this function, and also to Dr. D.R. Patnaik sir, Secretary IMS, and for valuable suggestions for organizing this seminars and his constant advisors and emails even during late night hours. I also thank all the national and international organizing committees, national advisory committees, and I would like to thank the scientific and technical committee headed by Dr. Ramesh Kumar sir. As mentioned, he is omnipresent. His presence was here throughout this conduct of this conference. And I like to thank all the distinguished eminent scientists who had given the plenary talks, lead talks, invited talks, oral and postal presentations. And I would especially thank the three eminent scientists who had given the memorial lectures on behalf of Professor Ananda Krishnan, Sharadi, and Annamani. That's Professor J. Srinivasan, Dr. C.R. Sridhar, and Professor B.N. Goswami, respectively. And though it is for official purpose, I would like to express my sincere thanks to our mentor, Professor Mohan Kumar sir, whose presence is always has been an inspiration for the younger generation like us, because he has always been here guiding us. And at the outset, we had the starting trouble how to start, because there was no prototype how to start this hybrid online or offline. We were not having any idea, but at every juncture point of time, he had his guidance. And also it is official. I would like to express my sincere thanks to Dr. Abhilash, who had not even slept. I don't think he had not a good sleep for the last 1 month. He had recently taken over the charge of Director of Advanced Center for Atmospheric Sciences, Cochin University of Science and Technology. And immediately he was assigned this charge and also some other social responsibilities also. And he has been doing this wonderfully. I would like to thank. Additionally, this conference would not have been possible without the sincere help of each one of my colleagues and the IMS Cochin chapter, because they were, even though they are behind the scene, their presence is felt through the successful conduct of this conference. And I can't name them individually, but I express my sincere thanks to all the colleagues, technical support providers, rapporteurs, hall managers, assistants, and especially I would like to thank Mr. Prabhat Kurup, who is my former student, also a research scholar at ECAR, who has been behind the scene for right from the beginning of this program till now. And I think we should thank him and Mr. Abhiram also. Next is the turn for IMS itself, because they had given and encouraged us through the seed money. That's 2 lakhs. Without that money, it would not have been possible. So I thank IMS National Council and especially the Ministry of Earth Sciences, right from secretary to all the officials. They had the good support for successful conduct of this program. CSIR, ISRO, then the Kerala State Government, Kerala State Disaster Management, Department of Environment and Climate Change, and also all the stakeholders like the Campbell Scientific, Joanne Research, who already provided a good support for this program. And another important thing I want to mention is the support of the administration of Cochin University of Science and Technology, especially our respected Vice Chancellor, Pro Vice Chancellor, Registrar, Planning and Development Officer, Finance Officer. All these support actually gave us strength to go forward and organize this seminar. We are organizing this seminar through the virtual platform for the first time, and I thank Alcode Solutions for designing this web platform, and also all the technical supports provided by the local agencies. And at this point, I would like to express, because I am sitting this stage as a disciple or as a student of our respected and beloved teachers who had introduced us to the alphabets of meteorology. Professor Ramon sir, Professor Arun sir, Santosh sir, and Babu sir. I express my sincere thanks on behalf of my personal level and also for IMS. I won't say finally, but the mostly this conference is actually not only a mental exercise or an intellectual exercise, but it is it provides the safe environment for our public to sustain. And the media has always been our strength to spread the awareness among the common public, and they had been in constant contact with each one of us, not only for this conference, but also for the day-to-day activities of especially during the inclement weather in Kerala. And they had given a very nice and wide coverage, not only at the state level, but also in the national level. Had given a very wide coverage. Probably you all might have read the news. So they had assembled here and provided us all the support from my personal level, and also on behalf of the IMS Cochin chapter and also IMS National Council, National Committee, I extend my wholehearted thanks to each one of us, one of them. Thank you all.
Thank you. I think, can we?
Thank you, sir.
Just one second. No, I think just one minute.
I was just, can we take a photograph, switch on those who are present actually at least? Yeah, because it is very limited people, but still we should have a photograph of.
So you can take.
Please switch on your camera.
In group stand, but we don't come here. Camera may not come. Okay.
Tyagi sir.
Sir, no, sir. Yeah.
Raju.
Camera switch on. Camera.
Yeah, one hall is also there. Good, good. Tyagi sir. Tyagi sir, camera is not there. Joshi sir is there. Yeah, yes, it is coming. Report there.
That is our one hall we are sitting
Yeah,
here.
we are sitting in a hall.
Pampa hall is too much light. Yeah, this reporter Pampa something, it is light to come.
Including Patna.
I think Tyagi sir nahi hai sir.
Okay.
Tyagi sir, Rathore sir.
सब चलेंगे. मैं पहला लिया हूँ उनका है, but not with group.
I think we can manage with our.
Okay. Okay, thank you.
Thank you.
Thank you.
National anthem. Thank you all. Thank you.
Now,
अच्छा, there one national anthem.
Yeah.
तो खड़ा होना पड़ेगा. Adjust your camera so that face should be visible. Namaskar.
this concludes the event Intromet 2021. Thank you.
Thank you, everybody. We'll see you again 2022.
Thank you, Patnaik ji.
Yes, sir. Namaskar, sir. Thank you very much.
अभिलाष जी, मान कुमार जी, आपको तो हमसे कुछ दिनों में ही बात करना पड़ेगा.
बाकी सेटल करेंगे सर. Okay, sir. Thank you, Jesse sir. Thank you.
Thank you and bye to everyone. All the best.
Sir, we are missing. Actually, we are looking for your photographs that time, sir. Oh no.
Okay. Doesn't matter.
We can have.
Thank you, sir.
Good. Okay. Maybe one more.
Yeah, we can have one more, sir. Sir, you are there.
Yeah, all of us are there. Just yeah, we'll have.
Yeah, we'll have.
Mahapatra sir.
Thank you.
Okay,
Thank you. Sorry for.
One more. Don't
Good
worry.
to see you, Rajan Sahib.
Yeah. Thank you. Aditya sir, with Aditya sir, we'll have one more.
Yeah, I have taken one.
Yeah.
Thank you. I am honored and sorry for.
Okay,
Bye. All the best. Good show. Great. All the best to QSET and the team. Bye.
Yeah, sir, please come and visit to set.
Yeah.
Our radar
Yeah,
center,
positively.
Sure.
Yeah. I will try. Let the things improve positively. Said you. Okay. All the best, Mohan Kumar Sahab, Rajan Sahab. Nice seeing you. How are you keeping? Okay.
You remember? You have
Yes.
come from Monsoon Center.
Yes. I'd come. I very much remember.
Yeah.
Acha, Rajan sir, namaskar.
Namaskar.
I remember, sir, that first conference in meteorology I attended in Cochin. That I think 96 or something.
2000.
No, not 2000.
No, that is
That
another conference.
climate variability something. 96 and 96. Yes, that was my beginning of 94. I started meteorology, so I just write a paper and I presented.
Yes.
I remember, sir, you were there.
सर आपको और भी बाद में बोलना है.
Okay.
हिस्ट्री बाद में फ्यूचर प्रोग्राम में अभी से 96 शुरू कर दिया.
ठीक. Okay, sir. Thank you, sir.
Okay, thank you everyone.
Thank you.
Okay, thank you. See, I used to remember.
Yeah.
In Ahmedabad.
Yes. Ahmedabad to pura yaar.
Really chilling night dance in the open air auditorium. And we couldn't take food. So my hand was shivering and
Yeah, I remember, sir. Yeah.
Sir, it is streaming. YouTube is
live streaming.
That's a part of it.
Yeah.